Okay, guys, so let me start. Welcome to Connection 2026. It's good that we last did this in March of last year, and we are able to do that again in July. And thanks for the people who are up here early on time. That's always good. Thank you. It's, at least for us organizers, it's always good to see people who come early and on time. So thank you for doing that. So I'll give you a quick introduction. Are there people who have not experienced IETF at all, as in not attending an IETF meeting? Maybe let's start with that. Remotely, you have attended an IETF meeting? So a brand new experience. Have people read an RFC or a draft? I think everybody has, right? Good. So at least we know that. Maybe just the meeting aspects that I will try to cover at the end. But let's first give you an introduction of Connections. Connections is our annual event by IIESoc. This is our IETF community meetup. Our aim is let's get all the people who are active in the IETF space, maybe not participating directly, but maybe they are consuming the RFCs. At least they are involved in the discussions of the internet standards in way within Bangalore or within India. There are people who are coming who are at least registered from other cities as well who are coming here. Our aim is we work in networking. Let's also do some kind of human networking and make sure that we make these connects, touch up at least annually, see people face to face. Some of us who actually go to the IETF do meet at the IETF as well, but sometimes even IETF meetings get so busy and everybody is active in different parts of the IETF, we don't really get to hang around that much. So this is our one event where we get to talk about various different things in this space that we are working in, as well as try and connect with people as well. So we start fixed mandate, which is mostly focusing on the enterprises side. As you know, the internet protocols get deployed everywhere. Of course, the main key thing is on the internet itself, but the same protocols also runs within the organizations, within the enterprises. And somehow those enterprises' interest gets lost when we talk about the things at the internet scale. And it's true, I will talk about IAB a little later. I'm on Internet Architecture Board, and that's always a tussle that we have to deal with. We are writing protocols for the internet. If somebody wants to use those protocols in a much more limited fashion, we don't want it to impact the original scale of the internet, but at the same time, we want our protocols to be general purpose, and people should be able to use them in constrained environment as well. So what is the right balance between that? That's a struggle that we always see in IETF playing out in various different debates in the past, and it will continue for a while. So INTC has been forefront on that debate for a while now. We do webinars, so not just in-person events. These are online webinars. The current main one is going on Quantum series, which Nalini will also talk about. That will give you if you are interested in this is something which will impact all networking. So I think we all need to gear up and be aware of what's happening and how it's going to impact our protocols as well. Almost all protocols, security protocols, are changing with respect to making sure that we can handle the PQC aspect. And it's not just the PQC. Once quantum networks are there, how it will impact a lot of other things. So Nalini is talking about quantum sensing and other things as well, rather than just the PQC aspect. And RFCs we love. We used to do events within the IETF as well. That has become a little difficult to organize these days. But if somebody wants to help out and who is a regular at the IETF and want to create an IETF meetup again, we would love to start that once again. This is the QR code for our WhatsApp in case you are not there on our India IISoc WhatsApp. I think that's our most active place that we have discussion. We have a mailing list and all, but I think we being Indians, I think our life runs on WhatsApp. So even our IETF India WhatsApp group is pretty active. Use it, ask for help. You will find help there. People share information. But at the same time, be respectful. And there are various different people there. Not everybody is, for instance, there was a little bit of a tussle last year with respect to, if you remember, some government policies. So be respectful. We can have debates, but it needs to be within the community guidelines that we follow everywhere else, including the IETF. And the same thing should be applied for our WhatsApp as well. So if you're not there, please do join. Okay. So any questions about IISoc, RFCs we love? What is this event all about? We are all good. Yes? This Connections is a once in a year event. So let's start with IETF. Most of the people said that they may know about RFCs, but may not have known about the organization called IETF. So let me give a very, very quick introduction to that. So like everything, our things that matters are always written down in RFCs. So even IETF mission statement is in an RFC. That RFC is RFC 3935. And it says, make the internet work better by producing high quality, relevant technical documents that influence the way people design, use, and manage the internet. It's a very, very specific. People think of, like, there are lots of times people come and say, oh, IETF isn't doing this, IETF is not doing this. Because our scope is very limited. We can't go and tell people how to operate our protocols. And most of the issues that people face is with respect to operations. What we focus on is whether the standards can take care of everything in the right way. And there should not be a fault in the standards itself. So that's where, like, when things like DNS abuse or AI coming in and is changing this, yes, we care. We care at the bigger level, but you won't see a working group dealing with that. Because working groups are dealing with technical documents, technical protocols, only, not so much as operations. That doesn't mean that IETF doesn't have operations. We have a whole group called Ops, which deals with things like, oh, what are the best practices to run operations? But again, those are guidelines. Those are best practices. We go and go to Airtel and tell them, oh, you are not doing this right way, or you are implementing this differently. We are not protocol police. We just write the best documents, and we hope those documents are of that high quality that everybody will deploy. Yes. First, everybody would implement. As a vendor, you make a choice whether this RFC I want to implement. You make a decision because, yes, I would be able to sell this to somebody. Somebody would be interested in it. Somebody would then deploy it. So all these things are completely independent. And we as an IETF do not play a significant role, except for, like, how we are all in the same industry. So we talk to each other, we give our guidance. We give, like, for instance, in IIB, we sometimes send liaison statements saying this is what we believe, but that's all it is. It's just on paper. This is IIB believes this. It's up to other people to see value in what we are saying. So it's the words on the paper, words in the RFCs. That's our most important mission. So we talked about the mission, but basically what do we do? Our key part is developing protocols. Protocols which run over the internet, everything that you see from HTTP to email to DNS to TCP/IP to IPv6, everything you will see. There's so many different protocols. We want to do that with consensus, and that's the most important thing. And that's when the idea of, like, once the RFCs are published, people will actually deploy it. And note that, like, not every RFCs gets published. Not all RFCs even have consensus. So consensus is a very specific things that we use for our protocols or for our standards, and we say that, yes, IETF believes that we have consensus to publish it. We have a definition of it. Consensus in dictionary would say everybody agrees, but what we believe in is what we call as a rough consensus. Of course, that's full consensus is not possible. That will give veto power to, like, everybody in the room, and the way the IETF is organized, that doesn't work. Rough consensus gives lots of judgment on the working group chairs, on the area directors, to make decision not so much based on how many people support it, how many people are against. We are not doing voting, we are not counting, but we want to know what is the reason and what is the forcefulness of that reason. Sometimes even who is making that reason. Is there a commercial interest there? Is it a policy interest there? Is it having, is it against the internet architecture? Do we understand the tussle? I was just talking about the tussle between what's internet protocol within an enterprises versus open internet, that tussle. So all of those things matter. And we have to make a judgment call. And that's why it's a rough consensus. And you have to justify. Everything is in open. There's no backroom dealing. We cannot go because everybody gives their response on the same mailing list. The mailing list is completely open. And the working group chair's consensus call is also on the same mailing list. At the same time, we do get appeals. People disagree. And there is a whole appeal chain that we go through where people say that, no, I think you made a wrong call. these things are these concerns were not handled, and that's why the consensus cannot be called, for instance. And final thing is, as I was saying, RFCs is our bread and butter, and that's what we do. One thing that people come and especially to us in the IIB, we get this a lot. Look, we come to the IETF, the documents are, you're talking about so much details, but there is no clear vision. There's no building plan. There's not if I want to participate in IETF or I want to build something, everything is not clear. But if I go to 3GPP and if I go to 5G, I get a full system diagram, everything is clear, I know where the building blocks are. Why can't IETF do this? There's a reason. Because IETF has from the start, fundamentally, from the day of OSI versus TCP/IP that we learned when we were in our school books, and what is the tussle between the two protocol stack, that's happened at the IETF. And the ethos of the IETF is built on that we write our protocols in such a way that they could be reused in whichever way, in a permissionless innovation way. And that's how you will see that the way that we developed, for instance, TCP/IP, our networks were so different. We were doing things in mainframe, then PC came, then mobile came, now we are talking about satellite, but your protocols are not changing. Maybe their profiles are changing, maybe you'll change a few things, but your protocol itself and how you use the same protocol in totally different environments, that's where the IETF doesn't come in. That doesn't mean that IETF doesn't talk about it. We have reference architectures. Mostly you will see them as informational. But the idea is your core protocol, people can find new use for it all the time. And that's why you will see the same protocols like IP, DNS, security ones. People just keep reusing them. They don't even have to come to the IETF in sometimes to tell, oh, I'm going to deploy this in a new environment. Same thing happens with the enterprises thing. Like for the longest time, we were doing all of this for internet. But people said, oh yeah, TLS works here. Why would I not use TLS within my enterprise as well? Why would I come up with a brand new protocol here? So that's the ethos of it. And this tussle now we are seeing in AI world all over again, where people want to believe that, yes, we need a brand new architecture and brand new things. But IETF keeps saying that we don't have a structure for that. IETF believes in Lego blocks and it's not going to let go of Lego blocks because that ethos has been most successful part about the IETF. And that's what this slide wanted to show. So let's quickly go over the ethos, which are sometimes very unique from people who have been active in IEEE or 3GPP or ITU, for instance. The first main ones, everybody participates as individual. This is kind of a weird one for a lot of people. What does this mean, you participate as an individual? Well, I tell people when I go that I work for Huawei, but it's not like I'm always representing Huawei. And there are so many times you would see within the same companies, two people arguing on the IETF, and that's what it means, participating as an individual. That you are putting your individual point and you have to stand behind it. It doesn't mean that we get influenced, our biases comes in. We are based on people that you are interacting daily or the products that you are building daily, that impacts you. But at the same time, it's different from I'm representing them. And that's when you see in government organization or when I go and participate in other standard organization, you have to be much more careful because you are representing your company and the company's viewpoint needs to come in. I talked about building blocks. The main thing that we have is all our outputs are available for free. That's again a big thing, no membership, no login, at least for reading documents and all. Maybe for submitting ones, you do need one login, but again, it's free. And rough consensus, judging contribution by technical merit, and the final one that you see is determine success by voluntary deployment. And as I was just saying that IETF writes an RFC, can't force anybody to actually go and implement and deploy it. That has to be voluntary. And that's what gives us success. And there are some widely successful IETF products, and then there are some RFCs which never gets published and never get traction, but that's completely fine. This is the grand, breakdown of, if you look at our IETF agenda and to figure out, what is happening where, this is how it looks. Let's start from the bottom, internet. That's where you have IPv6, 6-man, You have all the DNS related groups as well, DHCP, NTP, core internet protocols. Over that, routing, that's where you have IDR, which does BGP, LSR, that does OSPF and ISIS. I do a little bit of PCE, segment routing, MPLS, all those interesting things. Over that, transport and internet, web and internet. We used to have something called transport that got changed, combined into web and internet transport. That's where you have HTTP, Quick, all that transport protocol business. On top, applications, WebRTC, SIP, RTP, even things like calendaring, all of that is in art. Art has like lots of groups as well. The two pillars on the side, because irrespective of which layer you are in, you always have to operate and manage them. So that's where the ops comes in, and you need to make everything secure, irrespective of where you are. So that's where the security other pillar that you see on the side. Giving you a rough figure of from the last meeting, the participation. Last meeting was in China, so for the first time, China was on the lead of number of people participating. Usually it's always the US, and the US was still second, even when the meeting was happening in China. So that gives you how active the US folks are. And we have been making a dent in India around 4%, 5%. This includes both in-person and remote. In-person in China was definitely less. As you can all imagine, it's much difficult for us to go to China. Just to give you a big snapshot of amount of work that happens in IETF, there are around there are people who attend the meeting, but IETF participation is not based on just attending the meeting. We count anybody who posts an email or as also as an active participant of the IETF. That itself goes up to 8,000. The number of messages goes in lakhs. There is nobody who is aware of everything in the IETF. We are in the leadership, we know. There's nobody it's not possible. Now maybe now with AI coming in, things might change, but for right now, nobody knows the whole picture, but we all somehow make it work. The community, lots of people from our private sector, business, lots of academia. So that's also one thing which I wanted to sort of highlight. It's not just the business, there's lots of academic participation. Civil society participation is also increasing, mainly because the things that we do in the IETF has direct impact on civil, on policy things as well. So those people have also started showing up at IETF in big numbers. Geography, as you can see, North America and Europe still leads. Asia, even with China being there, still makes a small part of our community. So Asia is definitely lagging, with Africa and Latin America following us. So there is a huge skew, even after connections and IIESoc and this, and we have been doing this for so long, it is a very slow trickle, and it's going to take a little bit time, and we have to continue to do what we do. And of course, the sad part about our industry has always been that gender equity is really, really, really bad in our industry, and it's also reflected in ISOC, and it's also reflected in this room right now. The mission, we reject kings, precedent, and voting. That's a famous one. We believe in rough consensus and running code. So we will cover running code, the hackathon part as well, and that's a picture from the hackathon. The idea of this was it's not, as I was saying, we don't believe in grand architectures, things that might look perfect on paper versus something that is working. So if you show us working, get it deployed, that gives your idea a much more force behind it, rather than it looks really good on paper, it is well presented, it is this. That's not as important. And that's the debate that we saw when we were doing the OSI versus TCP IP thing as well. Looking at my time, I should go a little faster. So the IETF core organization is on the left. That's where you will see all the areas, and all the working groups are inside that area. The IAB in the middle, and I'm part of the IAB. I chair the IAB. I've been with the IAB for the last 3 years. Good, we have Shraddha, so at least some progress. I was just talking about how the gender thing in IETF is bad. So what does IAB do? IAB provides long-term technical directions. We do interesting things like workshops. Our past workshops have been actually quite good, because they have led to new work coming in the IETF, and that's one hope that I also have during my term, that we do run pretty good workshops and try to make that job of the IETF pretty interesting. And then liaison coordination. This is when we make sure that we work with rest of the bodies, ICANN, ITU, all the other standards bodies, as well as like IGF, governance, policy, that we are able to work well with our industry and the outreach aspects as well. IRTF is where the research happens, lots of interested research groups. These days, like, they are thinking of starting new research groups as well. So people who are looking for new ways to contribute, especially students and all, I think IRTF is a pretty good place for you to start. I'll move a little fast. I covered the top ones, but then you have the trust and the LLC and the RFC editors. And I also wanted to point out that we have Ketan in routing AD, who is from Pune, who was there in the last connections and gave us an update about what's happening in routing area as well. So we have people in the leadership from our community as well. So if you have any questions, any doubts, any ways, come and participate. It's not just like, people somewhere doing it. It's our people who are actively participating in IETF, so use this opportunity. I think I'm going to skip this in terms of time and move more towards the next set of presentation, which is about welcome to IETF 126. So the key thing for our hope is, like, for people who are joining connections, that you'll at least join it remotely. I think the time is going to work pretty well. Vienna is UTC +2, we are UTC +5:30, so there are just couple of hours difference, so there will be a good overlap. Otherwise, like, sometimes we have stayed up all night and attended some of the remote meetings, so at least that's is less this time. So find the working groups that are of interest to you, join remotely. As we were just saying, remote fee waivers are available, so please use that opportunity and join live, and not just like, oh yeah, I'm going to read the minutes, or I'm going to this thing. It's kind of nice to show up this thing and get a feeling, so that when the opportunity comes, hopefully once an IETF happens in India and you guys are attending, it's not your first experience, you know how things are run. So you will be more productive when that happens. So that's our hope, and continue to participate in whichever way you can. So I'll just quickly go over the types of sessions. So when you are looking at the IETF agenda, it doesn't confuse you. Working group sessions are the most important ones. This is what you will see on the agenda most of the time. The working group sessions are working meetings. People will be talking about, this is my 15th update to the document and I have made these changes. So you need to know the history, you need to know what people have been discussing on the mailing list. Like for instance, in connections, you show up, it's fine. We'll talk about slides. You don't need to have enough background. Most of the presenters will give you the background and then talk about their key message. You won't get that in IETF. IETF presentations are very short, sometimes even 5 minutes, 10 minutes, and they are document based. So you need to do some, you can't just show up without preparing. BOF, on the other hand, you can show up without preparing, but actually preparing is always good, because BOF aim is to decide whether we need to take some work on. So we are talking not just so much about the documents per se, but giving a lay of the land. What is the problem? Why is IETF the right place to do it? We are talking at the much more high level. So when it is working group forming BOF, I think the main aim is also to finalize the charter itself. That this is the exact things. So people will go over the charter. Charter is very important, and you should have impact on what is the actual deliverable that this particular working group will do. But most of the time is also spent upon understanding what is the problem, what is this they are doing, whether IETF is the right place to do it or not, and what are the right boundaries. How do we scope? As I was saying, we believe in those Lego blocks. So Lego blocks only work when you can actually scope the problem really well and think that how this thing can now be fit in different places. So you need to have those interface and boundaries set correctly. So BOFs are interesting. This time we in fact have 5 BOFs. So if you are interested in AI side, there are 3 AI related BOFs, some security related BOFs. So go over them, that's always interesting. Research groups have mostly, they also do draft presentations, but their draft presentations are very few. They mostly have people presenting their papers. So again, if you are from the academic side and you want to participate in IETF and you are starting, participating in research groups gives you a much better, I can follow through and I can understand what they're happening. Presentations are longer. This time also they have ANRW, which is on Monday, the whole workshop itself, which is all, not just research group papers, but Suresh is the chair for that, and he's a pretty good agenda for that. So if you are from the academia and research focused, do attend ANRW alongside other research groups thing. Then there are area meetings that gives you a lay of land, like what's happening in the area as well. Lots of other side events. So even if you are attending remotely, those side events also have Meet Echo supports and tools, so come and participate. Lots of interesting things in IETF right now is happening in the side meetings as well, and this is a parallel side meeting agenda that you are going to see. Side meetings, remote participation can be very tricky, so unless you are a core part of that one, participate. Otherwise, I would more, like if you're starting, I'll say pay more attention to the working groups and the research groups. But if some topic is cutting, you want to participate, click on it. They have, when you click, they have an ICS file. You'll download, you'll get a WebEx link, and you can also join remotely. But the remote participation have been a little dicey on this one. But yeah, you can give it a try. Hackathon. So Saturday and Sunday at IETF is an hackathon, and especially if you are implementer and working on open source, and this is a very good way for you to have an impact and talk to oh, I'm implementing this, I want to talk to the draft authors, I need to figure out new ideas comes from hackathon that people go and implement, people sometimes measure, people find flaws in the drafts. So hackathon, the good thing in IETF is not a fixed format. You decide how do you want to use that time. Sitting on a table before the IETF meeting, who do you want to invite, where do you need help? You get to plan and decide. People sometimes give demos, people sometimes actually code, sometimes people use this to update wiki pages because they want to get the right information out. Up to you, you decide. And that's the beauty of this hackathon, so use that. But the key part is in IETF and in a working group, when you go and say you have implementation, and you have shown that implementation are written by multiple people and it interops, that gives your draft a huge, a boost. Whereas something, oh, this is a standard, I think it will work, nobody has implemented it yet, there's always a question mark associated with it. So doing hackathons for your ideas or even other people's ideas. And if you are just an implementer, you want to get involved, this is an excellent opportunity. And looking at my time, I'll just quickly move to questions. And main thing that I wanted to say, this is our Meet Echo tool. This is how you will participate remotely. So try this out in advance. It's not a Zoom and a WebEx that you guys have always used to. It's intuitive, but the first time is sort of oh, what the hell is this? So that's why instead of wasting time during the meeting, just try those things out, be ready, and then contribute to the IETF. Questions? Any questions? Was this useful or just me talking? Let me see. Nalini, are you here? Yeah. So it's 10. I think let's stick to the time since there are no questions. I'll pass it on to our first presentation, which is from, yeah, we have one question, sorry.
Generally, most of this, whatever in the last 30 years it has happened, is happened for the Western countries. So now, of course, of the designs in the IETF forum, everybody has participated, thinking it in most of Western country as a background. But now this is spreading in the country where it is more popular, or even the various kind of scenarios like power outage, too much fiber cuts, or larger geography, or too many people under one region or one cell or whatever. Considering all these things, what do you think that these kind of problems, which are real problems where India is facing, if you go to and talk to any of the Indian operator, these are all the different aspects what Indian operator is facing. What do you think that IET should try to influence considering these problems?
Yeah, so a very good question, and this is one of the things that we have been pushing for why Indian operators are missing within the IETF realm. And frankly speaking, there are two people who would carry your local issues at the IETF scale. In some cases, people have the vendors from those countries, and they want to sell things, so they want to sell problems that people are actually facing, and they carry the weight. But in India, as we know, we have starting to see some Indian vendors as well. I think either they have to participate or the Indian operators needs to participate. And actually speaking, Indian operators have such a unique point of view because of all these issues that you were, Keshav, just highlighting, which are very our scale, in India scale and China scale, as well as the unique issues that we have to take it to the IETF and talk about it. The key things that we see is within the IETF, one thing which I wanted to also talk about is, are these issues operational, or are these issues which are there in the protocols itself? Are they implementation issues? Are they the way we have decided to run the networks, that's why we are facing these issues? Or are they fundamental issues in the documents? I think what IETF cares most about is if we can highlight protocol issues. Yes, this is the fundamental flaw in the RFCs and the protocols itself, that they are not able to handle the scale. Most of the time, these discussions, what happens in an IETF is, yes, we are very interested, but most of the times the issue is implementation and deployment specific. And that's why those discussions happens more in the operator conferences, and you will see more of these things happening at APNEC and Apricot or this thing.
Those goes to the operator level. If the things are just like that, then problem will push to the operator level. But take an example, if there's a too many link flap kind of scenario, and most of the timers, whatever is set across the links, whether it's an IGP link or whatever, it is thinking that it is for a stable links. Had it been considered if too many flappy links, or there may be degradation of the link this thing under level 1 L1. So considering all these things, the protocols have been designed like that even at the designing of the RFCs.
So we are right, the RFCs are designed based on the assumptions of the people in the room. We have such good examples about, for instance, internationalization itself. People just worried about English for the longest time. It was only when other folks coming in and saying that, oh, you missed so many of the population, and later on IETF and other organizations, yes, we need to extend our protocols to make sure internationalization is taken into consideration. Same with this lossy link, there were separate working groups which were doing, actually IoT and all changed the game as well. It was not just issues that were listed because of countries or because of whether it's a development country. All over the world, people were facing issues, and separate working groups focused on that got created. So we have to drive it. The way IETF doesn't work is why IETF hasn't done this thing.
No,
it's most like why we haven't done this at the IETF.
I'm not questioning that. I'm not questioning that why IETF has not done. I completely agree. Take a typical scenario of micro loop that's coming in segment routing. That's a big problem actually for an Indian kind of scenario. Obviously, things takes time to settle down, and it's quite obvious. Power, if you go to suppose if you put your solution in a gram panchayat, so that's where our company, because it's an Indian company, Tejas Network being. So if you try to put it, there is an obvious scenario. It takes time for either the links to come back or the power to come up. If any of the things are there, and if you have a ring kind of a network, there is an easy hit of micro loop coming for us. And so as of now, those are the things that is, I don't think that's completely solved in IETF to handle those kind of things in segment routing area, at least in the best effort SR scenario. So, how do we, you are right, why IETF has not done, how do we influence is the next question that we need to think for the kind of where we are living. So, that is something that we may have to think.
And let's use this opportunity to talk a little bit more. Shraddha is there. Shraddha has written drafts on this.
I know. Once I talked to her. I'm just making a comment here, right? And two parts to that, right? So there is a lot of experience in operators and vendors, right? In kind of problem statements that you have set, right? And related to, traffic engineering, segment routing, in action, in live, right? What I have observed is that there are working groups in which, operators come and share their experience to say, hey, we face this problem,
we solved it this way and these drafts helped us. And then they also state that, these are the areas in which we find that there is a gap and we have to overcome, and they come and share that experience. Now, you are right. I mean, the people who do come and present that, most of the cases are, what they faced, right? So which it comes more from, European, North American perspective.
Correct.
Now I see like there is also Chinese operators, vendors who also come and share that, right? So the thing is that the work is happening. It's just that it's not public and it's not published there. But I think amongst the vendors on other operator space, and you would find that the nature of problems in India is similar to the nature of problems in Africa as well, right? So there are deployments in Africa where people come and say that, hey, we had a problem here, because of very long links, forest, we solved it this way. See, it exists. It just, someone has not come and presented yet, and maybe it will happen in future, right? Or maybe it will happen here, right? I mean, there is nothing that stops from, someone, come and saying that, hey, I faced this problem, I used this draft and it helped me, or this draft, I tried this draft, it doesn't help. Both are valid things. It's just my comment.
Yeah. Thank you.
Let's move on.
Yeah, let's move.
Yeah, thank you so much. We have good times for breaks, and let's continue to have that discussion. Yourself, I will not put that.
Along with Dhruv and some of the others, co-founder and chief operating officer. And I've done a bunch of stuff in networks. And right now, I'm real into PQC and quantum stuff. Also interested in TLS, IPv6, MLS. Ask me what I'm not interested in. But I'm going to be doing some of this stuff at the IETF too, in MapRG and IEPG. But I'm going to really encourage you to join the quantum series. We have a series of webinars, and they really go into depth. Actually, next Tuesday, I'm going to be doing an in-depth one in PQC. We had the Quantum 101, just a little bit ago about entanglement. Got some really great people coming up too. The one after mine is Dr. Vadim Lubashevsky. He's from IBM Research in Zurich. He co-authors of the main crypto algorithms, MLDSA and MLChem. And so you really, really want to see him. We also have NIST speaking in a little bit. And then one of the really big topics is digital certificates and whether all this stuff is implemented in the crypto library. So we'll have people from the certificate world, we'll have OpenSSL, all these people talking, and then we're going to have, QKD. Just really, I really encourage you, because I'm going to tell you what the big deal is and why I'm sort of obsessed with this whole topic right now. So quantum technologies writ large are likely to change many, many things. Like what, right? What are they going to change? Well, I'm just going to take three things: quantum sensing, computing, and PQC is really what they call orthogonal. PQC tries to fix a problem that quantum computing creates. But let me just talk about what some of the things you're likely to see are. So let's just talk about one thing. Let's talk about GPS. Everybody knows GPS. Everybody uses GPS. It's like, thank God for my phone, because before that I was always lost. Problem with GPS is you can jam it, and that's what they do in warfare. They jam it. You can spoof, and if you're inside or in a canyon, just like your cell phone, all kind of places. There's a lot of places where it doesn't work. And I tell you something, this whole thing with space, so many conversations conversations right now about space, you know? It's like the IETF, you know, people, a lot of folks talking about, okay, so how are we gonna address Mars? How we do Moon? Naturally, I have opinions too on that, you know? It's funny, it's like, one of the fun and great things I love about the IETF is you know, you're living 4 or 5 years out. And because you remember, I certainly remember a while back when all everybody was talking about was cars and like how we were going to do driverless cars and stuff. And then here I am with, you know, when I visit my daughter in LA, they got Waymo everywhere. Waymo's driving around with, you know, with no drivers. And so it'll be very, very interesting to see, and I bet it will happen, that 4 or 5 years from now, people will be talking about what Mars colony will do and how they communicate to rover and so on. But one of the big things that a lot of that stuff depends on is things like geolocation. And so how exactly are we going to do GPS on the moon? So you kind of see it's like a lot of this stuff is really tied in together. So advances in one impact advances in another. So one thing that I think is likely to be one of the first things commercially out that people getting very close to, keep your eye on, is quantum sensing. Because what quantum sensors do, it's very, very tiny changes in nature. And so then they have very accurate positioning. And I think one of the guys is going to be talking about IP geolocation, but just imagine how that can change if you've got a little sensor just right here in your phone now. You know, it just changes everything. You know, how GPS and protocols might be done in the future. And one of the big things, you know, Iran, one of the big things that they do is they have these little tiny drones, not like this, these are kind of big drones, but they have real effective drones that fight the big U.S. military. But you know how they are fought against GPS jamming. So now you can see how like the impact of changing something like that. You see what I mean? It's like these small changes in hardware technology can impact protocols, can even impact warfare. So the next thing that I think is really important and will be transformational is quantum computing. So now, okay, quantum computing is not like all of a sudden now everything is going to be 50 times faster. You know, no. Somebody tell me I'm wrong. But my understanding, you know, I've been playing around. I actually got on and started doing some quantum coding and stuff. And what I can see, is that it's very, very, very good at certain kinds of things. And those kinds of things are very, very hard for classic computers. Having said that, Nalini's opinion, the best thing will be if we can do some kind of really good hybrid. That is, do like database access, something like that. You know, maybe networks is a tricky area, but like certain kinds of access, maybe even memory access, you know, certain kinds of things with a classical computer or classical programming, hop over and do some optimization and combinatorial problems with a quantum computer, hop back in. I think that is, in my opinion, I think that is probably where we need to go and where you will see us going. So let's talk about what I'm talking about. So one of the things, this famous problem, I'm sure you guys, had it in whatever, high school maybe even, but it's the traveling salesman problem, It's like you got to go to all these different cities, and you got to spend gas for everything, spend time. So what's the route that goes to every city once and comes back? You don't want me backtracking and all that kind of stuff. But this is a classic problem in many different things, right? I mean, you can extrapolate to routing and so on, but it's a classic kind of problem. And in some ways, it's a searching problem. But it's not a classical searching problem. And we have many, many kinds of ways to optimize classical searches. Binary searches, ratchet trees, even Merkle trees and that kind of stuff, So we do a whole lot of that today. So quantum algorithms, how are they different? Well, so they take on a whole, there are many different kinds of problems where where classical algorithms make it very hard to do. Where you can't come up with a big efficient strategy, and one of which I'm going to get to in a minute. But I'll tell you, this is the reason why many people, many of the financials and many of the stock trading companies are getting very interested in this kind of thing. It's like portfolio optimization and stuff like that. I don't know if you remember a while back, they had this thing where it was like some stock trading companies, they had connections. Some people had connections where they were able to see a trade coming, and they execute a trade a half a millisecond faster than other people. And they got the better price. And I'll tell you something, I have actually worked on some stock trading network folks, worked with them, and they really, their response time really is very, very nanosecondy. They really care about time. And anytime they talking about money, and as you can imagine, anytime somebody sees a way to make more money easier, they're going to be very interested in this kind of thing. But what people are really talking about, quantum computing's doing, is not in some ways not a positive thing, but I guess a negative thing, which is that when you get something which is powerful enough to break public key encryption, and the term used throughout the industry is called a CRQC, a cryptographically relevant quantum computer. And so what that will do, it was essentially break the first part of TLS. Many algorithms have as their very first part the asymmetric or public key algorithms, and those come to my presentation if you're interested in exactly how. I'll talk more about exactly what is to be broken. I mean, if you're a glutton for punishment, that is, it's essentially at least in the case of RSA, it's prime number factorization. That was the initial impetus for some of these algorithms, Shor's algorithm and so forth. But there's a lot of people, IETF, NIST, and so forth, who are fighting against this. And this is what is the whole post-quantum thing. So as I say, when you hear people talking about post-quantum cryptography, it's this, is that in PKIs, the public keys will be broken, and so people are doing different algorithms that quantum computers can't break. we think, right? I mean, this is a huge argument right now, and in some ways, I'm kind of like, it's a tricky thing, you know, because people don't know, and I'll tell you, NIST has had a bunch of contests, and I'm so eager to hear what Dr. Lubashevsky has to say, because as I say, he was one of the winners of the NIST competition for both MLDSA and MLChem, which is what's being implemented today. And so, but it's a process, right? It's a process. You have to get the algorithm. You have to modify the protocol. You have to put it inside OpenSSH. You have to get Java done. You know, bouncy castle. You got to get C. I mean, everything. It's a big process. But some good news. And this is something that I'm going to be talking about too. I've been going through it and doing getting some real world numbers of like, I've done like the top financials, 50 top financials in the US, 50 Latin America, and I think I got like 38 from India. And so I'm just showing the India ones. So you can see here that in India, it looked like about 1/4 already doing PQC hybrid. You know, I said we tested them, can you do it? And sure, they could. And this is kind of interesting. Of the ones that could, 5 did only 1 and 4 did 2. Now, this is, again, one of the things INTC would like to do, and we welcome you guys to come join us and to come help, because as Dhruv said, IETF is not going to tell you about really how to implement, what to do, and so on. So, but we think someone needs to help, someone who really understands the protocols and understands about enterprise networks and so on. And quite a few of us grew up on those networks, and we do understand. And so one of the things we would like to do at INTC is to come out with some roadmaps, because just this slide alone, I could spend about an hour on it, because this is the only one of these groups, the 25519 ML-Chem is approved, quote unquote, approved by the IETF. The second one is I mean, there's a lot of people really, should you do it, should you not do it? People, I'm telling you, all over the world, I see that one being used. And I think there was some legacy, because that was one of the ones that was on one of the NIST FIPS approved groups. And I am talking to NIST about a bunch of this stuff. And it's a really such a moving target for everybody. As I said, and there's a whole, enterprises are tremendously complex, because just think to yourself, what if you only do this, and you have to go back to your disaster recovery site, and it's not doing that? You better have yourself a backup, you know? As I said, I could talk an hour on this slide, but I will not, so moving along, sorry. Don't get me started. So TLS support is super interesting too. As you might imagine, most people are doing TLS 1.2 or TLS 1.3. There is one site in India who's still doing TLS 1.1. Banks only. I only measured the large banks. It's not a thorough test of everybody, but it's a little problematic to see. I don't like to see that. I see this in again, I totally understand why people are doing TLS 1.2 only and not going over to TLS 1.3. Believe me, I understand exactly why people are doing that. But the problem is you're not going to be able to do any post-quantum stuff if you do TLS 1.2. So that is interesting. So, yeah, come join the discussion. if you have the stomach for it, join the TLS list. Now, I'm sort of teasing. I mean, there can be some very opinionated people on there, but it's super interesting. Just Google the NIST PQC forum. A lot of super interesting stuff happens on there. I haven't even talked about signatures and certificates. If you're interested, I'm going to do a presentation at IEPG. It's 10 o'clock on Sunday at the IETF. And that's I'm going to talk mostly about that, because that stuff is very immature, especially it's not well defined, even at the IETF. The standards are very ill defined, and there's a lot of, I often represent the enterprise point of view, and there's a lot that is going to impact enterprises when certificates change. So, but yeah, I mean, come on in, the water's warm. Yeah, so this is the quantum series again. Please go up there and sign up. The webinars are free, of course. Talk to me anytime. Happy to talk to you. Talk to Dhruv.
Yeah, thank you. Thanks, Nalini. For asking questions to Nalini, use our WhatsApp, join our webinars, join the IPG session. There are various opportunities for you to ask questions to Nalini, and in case of time, Nalini, we are going to not take questions live here right now. So you can go back to sleep, have a good night, and I'll see you at the ITF.
Okay, thanks guys. Bye.
Bye. Speaker is Siddharth. Siddharth works for FASTA, and which is a geo IP location company. Siddharth will talk a little bit more about this, but let me first get his slides running. This is working. Yes.
Oh wow, fancy. Thank you. Thank you, Dhruv. So please be sure to sign up for the WhatsApp group. I hope you all are on it, or you took a photo of that QR code that Dhruv just showed and will show hopefully in another 15 minutes. We really need to have more conversations within that group. It's awfully quiet in there, and at least some of the young people in this audience should ask smart questions, engage, and stop fearing the people with the gray hair, right? So please be vocal, ask good questions, and if you have niche questions about deployment or real world questions about how to use stuff more practically in the Indian context, please wake up and engage. Otherwise, all of these things will stay a Western construct, and we'll not be able to make our own engagement forums, trust channels, standardization forums. All of these are long games. They require a lot of trust-based interaction. So more than me talking about my stuff, I want to say that the framework that we are trying to build here is long-term valuable. So you have to engage, you have to talk, you have to act dumb sometimes, you have to ask silly questions, and you have to make a conversation. So if we only do this once a year, it's not going to work out. We have to be doing this every week or every day. Yeah. So that's my request to you. Please engage. I'll post a lot of the links to my talk, my material later on the group, so that you can go home or go to your office and follow up on material. So what I do is I'm firmly on the implementation side, like Dhruv mentioned in his opening remarks. So I do not write RFCs. I read RFCs and I write code and I sell software. So I'm proudly in the startup area. I sell software for a living. So I'm not going to pretend to be Gyani about RFCs or the skill of cooperating in IETF, or how a working director is different from an acting director, or whatever nomenclature they may have. So I do for a living IP-based geolocation. Some of you may have seen things like websites telling you what your country of location is, what your city of location is. Google search, for example. Facebook app localizes your languages in mysterious ways without you asking for it. That's because they're inferring some state or geography from you and defaulting the login screen in maybe a language that you do or do not speak. So there are many hidden use cases of IP-based geolocation. It's basically just taking your public IP address and running it through a large lookup table with key as the IP or the subnet, and sort of the value as which state, country, or maybe city that you happen to be originating from. So you use this in visible and non-visible ways a million times a day, pretty much on all the internet. So we give API-based data for developers primarily, who are our constituency. And because we do this, we happen to interoperate with a lot of RFCs and other standards-based mechanisms that exist and will continue to exist. So content personalization is a huge. Routing of media is huge. Licensing, so when you go to log in with your Netflix account and say Bangkok, you're on a short holiday and you've gone to Vietnam, some of your movies may mysteriously disappear from your catalog, right? That's because Netflix or Prime Video, Amazon Prime are running IP-based geolocation, and they're seeing that the country that you're subscribed to is India, and the country you're watching videos in for the past week is a different country, so they start sort of withholding some content which is not licensed in that country. So there are a lot of media licensing mechanisms all around the world, including watching FIFA matches, by the way, as you've probably been seeing in the last few weeks, are heavily gated by country in terms of licensing and rights. A lot of our banks, in Indian banks, everybody asks you for your GPS location all the time. You might have seen that you're logging in on your desktop or your laptop with Chrome, but HDFC Bank refuses to stop asking you for your GPS location. And that's super annoying, but that's how a lot of the banks abroad do it, which is they don't ask for your GPS location all the time, even on or desktop browser, and they infer as one of the many variables used for security of your account what your IP-based geolocation is, and together with other two-factor authentication, your fingerprint auth as a passkey and other things, they use that to layer on multiple mechanisms for fraud detection in terms of financial security. Of course, Government of India keeps writing new laws, and so do all governments. It's by no means an India-only phenomena that various banking regulators, insurance regulators, consumer rights regulatory bodies, and central government and federal government agencies keep adding some sort of IP logging or presumption that that IPs are originating from a given country or territory as the record-keeping requirement for a business to act in a certain licensed or lawful manner in that jurisdiction. So the stakes vary. For some, this is just Netflix movie not being available on your Vietnam vacation is not a critical problem, but for a bank, like a large bank, keeping an audit trail of where money is being siphoned off from in a given account is actually a law enforcement problem, because as you as a consumer would expect your bank to have a clear paper trail or a digital trail of what happened and how their security algorithms approved or disapproved of a given transaction. So the stakes vary widely. There's a very long tail of outcomes that you can attach to it. So IP addresses, as you know, are historically nothing to do with location at all. They were there to route traffic from point A to point B. So this is all a huge made-up story, and there are entire ecosystems, regulatory postures, and all those use cases which I showed in the previous slide hanging off it. So you could do like Google Google search localizes your language of search results based on your user perception, the perception of users' geolocation. But other things could be a CDN or a DNS resolver trying to figure out whether to send your Airtel originating query to a Mumbai endpoint of an API or a Singapore endpoint of API. So those type of things are run by your DNS serving organization, and they are trying to infer that your IP is this in Airtel Bangalore pool, and where should the nearest server be, given that they have two options on how to send you. So things like GeoDNS, and which some of you may have configured, if you have ever configured an advanced DNS configuration, those implications of this data are visible in many layers of internet software, not just the consumer side user experience. So interpretation of where an IP geolocation, what an IP geolocation implies in terms of application behavior, security posture, network routing, all of those are different facets or projections various actors' interpretation of what they want to solve. Right? So CDN will look at it in a different way. A government or an insurance company will look at it in a different way. And if you're building consumer apps like Google search engine's UI web interface, you're going to use it in a different way. So we're going to do a state-of-the-craft overview. Again, Dhruv mentioned a workshop that IETF often does workshops. So IAB, the Internet Architecture Board, which is one of the key bodies in the IETF, just a few months ago, they ran a beautiful workshop on geolocation. So this was really valuable. So I would encourage all of you to read any notice that Dhruv posts about a workshop very carefully if it overlaps with your area of interest, because they're really fun. They bring actually companies, startups, big businesses, cloud companies, ISPs, and all people from around the world together in one big room, virtual room in this case, and it went on for 3 days. So it was quite relentless, but it is really a very wide spectrum of knowledge and friction points and good things, both good and bad things that come out from it. So I would highly encourage you all to use the workshops that IETF and sometimes IAB organize in a very deliberate manner. They are really useful. So for those of you who do wish to get into the practice of this, this is relevant for the audience who actually manages IP reputation or public IPs yourself. How many in this room actually manage public IPs yourself? Okay, a few. And do you have a login into AppNic or somewhere where you maintain those records? Okay, excellent. So a lot of this, the practice is going to be relevant only to folks who actually maintain public IPs themselves as infrastructure or consumer ISP or any such role. So I'm going to keep this short, but you'll have the slides later to follow up on in case you need the masala. So this is the CSV file. You're supposed to author a CSV file, which is RFC 808005. And then you can just put the prefix in the first column and the country where you want it to be known as in the second column, the state, broadly a region. It doesn't have to be a state technically, it can be a geographical region. And this dictionary must be from the ISO 3166 standard, right? So ISO 3166 is the standard which whitelists all country codes as well as all state codes in each country. So all of India's union territories, states are all coded there. Some countries define territories, like if you have a big island that is not a state in the legal sense of that country, they say this geographical region also has an administrative code in the ISO standards. So all those are fair game. But for our case, for our country's case, all UTs and states have their own code. Pretty much like how our licensing of ISPs and circles used to be governed and how RTOs are structured. So it's broadly the same set of ISO documentation, that is the reference documentation. And optionally, you can add city at the end. And you can drop one or more of these the column values if you want to dial down the specificity. So for example, if you are, say, geo in the Delhi region, you can just say DL as the Delhi region, and you don't have to say whether this is Mayur Vihar or New Delhi or Old Delhi or anything thereabouts. So you can even say SG for Singapore, and any portion of Singapore can use that. So for smaller countries, for example, if you manage your nodes in another country outside India, you should use something which is honest in terms of geo-accuracy. You should, as a best practice, this is not part of the standard, by the way, this is my interpretation as a practitioner, you should dial up and down the specificity which is appropriate for how you allocate those IPs from that subnet, right? So the standard allows you to dial up and down, and you should use the standard and hold people like me who are actually interpreting your feed in a manner that's compatible with the written standard. So we discussed this. Then the other fun stuff is 9632. This is about actually sharing your feed now. So you've hosted your CSV file on a public URL. It's not password protected. Please don't block it with a firewall or a country geo block or things of that nature. So you can log into your AppNic account or wherever you have an account for your IP management on a public internet registry, and you can actually advertise it there. You can even use RPKI This aspect is not very widely implemented, the attestation part, which is part of 9632. But the whole publishing it in RIR is extremely important in case you do decide to do it. And I highly encourage for those of you who manage public IPs to actually publish your geofeed in your IR or regional internet registry records. So this basically aids people like us who consolidate IP data or scrape IP data from around the world, including RIR Whois records, that this shows up in your Whois record, right? So Whois is being replaced by RDAP, as many of you may be aware. So 9877, the one on the right in the headline, is the one which makes it more compatible with RDAP. But for the sake of simplicity, RDAP and Whois are being used interchangeably here, and both you should advertise your geofeed through your internet registry's login page and associate with all the INET nums that you register there. So in terms of best publishing, you should do it frequently. If you're an ISP, you should do it like monthly minimum. And for cloud and other companies who move their IPs around a lot, so for example, Starlink is one feed that I think they haven't gone live yet, but they're aggressively testing their network in India. So Starlink, for example, refreshes their IP geofeed like twice a day, right? A lot of large US ISPs, Comcast and all, they also refresh them like at least daily. AWS, Azure, all the cloud companies, they do it like twice a day minimum. So there is based on how frequently you move your IP allocation geographically, you should do it and set a cadence for it. And this we've already gone through, but this is again a best practice in my view. So we should intentionally use how big an accuracy or geo-accuracy you want represented by your IP allocation accurately for each line of your feed, and not try to pin everything down to Mumbai. Like Maharashtra is a big state, so if you're using, Airtel Maharashtra region is your business planning way of IP allocation, then you should definitely just say MH and don't say MH and then Mumbai. It's not in that city, so you should not pretend that Nagpur is the same as Mumbai. So this we discussed that you should not be artificially scarce in terms of or over specific about the city. And for points of presence and CDN nodes, it's okay to say that you're in Mumbai or you're in Chennai, and Mumbai is not Chennai or Nagpur is not Mumbai. But if you are a mobile operator, you move around your IPs a lot, then you use the modality, the semantics, which is appropriate for your class of deployment, right? So all deployment should be honestly represented in your feed file. So hosting cleanliness, again, serve it with the correct UTF-8 encoding. Don't do any other fancy encodings. The RFC does call for UTF-8, by the way. People serve it with various kinds of content protection. They put it on their main website and then feel very angry that why you're not crawling my feed. Well, because your Cloudflare bot protection blocked our crawler from accessing the feed. So you have to be sure that maybe carve out a separate virtual host or a separate TLS configuration so that you serve things which are not protected by your bot defense of Cloudflare or your hosting provider. So again, we discussed pulling from your IPAM or whatever tool you use. If it's a CSV file or an Excel file, then Excel be the IPAM address management tool. And then you validate all the ISO codes and the city names are legit. And then you host it. GitHub works great, by the way. GitHub's a free hosting service. All of this is public information, so there's nothing to hide here. And the GitHub URL links work great in terms of sharing plain text files with your RIR records and the rest of the world. So in terms of the IETF and IAB scene, there's a lot of fun which happened in December. There was a large meeting of minds, like I said, strong plug for the workshop ecosystem that IETF runs. And there are things in terms of freshness, trust, verifiability of IPs, and some of the India-specific things like we discussed, like Dhruv also tested, China, India, Brazil, all of these are using a lot of IPv6. We are scarce in terms of IPv4 allocations. So our CG NATs, for example, my home Airtel Fiber has like one IPv4 being used by thousands of people probably, right? At least a few thousand homes. So that's probably like 10, 20,000 people minimum. Anybody who has a better number can tell me that. So a lot of problems which occur because of one IP being used by a huge amount of people. And when somebody scrapes from one IP, that whole 10,000 people get blocked by that hosting company. So there are a lot of the cases, there's work going on by Cloudflare and others to improve the situation, but a lot of the IP owners need to say, so for example, if Airtel were hypothetically saying that this whole subnet is representing, 100,000 people, then a company who's consuming that data would actually handle it differently. So there is a lot of expressiveness which is missing. There are a lot of work ongoing in order to do that. There are still a lot of gaps in tooling, software implementation, API from data providers like us that need to catch up with this demand and needs. So there is a lot of ground to build new infrastructure in this area. And of course, from an authoring perspective, you need to author the city names correctly. A lot of Asian nations have problems, like Japan had representatives at that workshop and they were saying nobody understands our feeds. And then I actually wrote a geocoder myself for our startup. And I was struggling to geolocate all the Japanese names because the way they write it in the English language, they put city at the end. So like they add Halli at the end, so they actually write the whole city suffix at the end. So it throws off all of the geocoding databases that only have the city only in the name. So there are a lot of language sensitivities that we have not adequately addressed at the RFC level as well as at the implementer level. So we need some amount of work to clean it up. In terms of the ecosystem, there are a lot of actors who need to step up to the game. So if you are one of these actors and have a point of view, please interact on the WhatsApp group that Dhruv will showcase again. There is work going on both extending the CSV format in a more JSON and extensible manner. There are a lot of missing features which are attempting to be layered on in a more graceful, expressive format. But a lot of the under specification is a feature, not a bug. Like Dhruv's mentioned, it's not very prescriptive. It's like you register a new variable name and then tell the world what that variable name needs to be used for, right? And hope that everybody in the implementation space actually abides by that proposal. There are non-CSV, non-expressive, non-self-publishing formats which are being also championed by Apple and Google, who own the smartphone chain of trust. So for example, if HDFC Bank wants to know your location when you're logging in, what they're effectively proposing is that you do a fingerprint touch or a face ID, and some sort of stapling system or geo stamping will go from Airtel to the bank, and that becomes a country level feature. And then there is some amount of user consent that they ask you on the phone. Since they control the Google services and Apple services on the phone, they can say that for my banks, you always give them course location or do not give them any location. And instead of the bank asking you for GPS permission in Chrome again and again, you can do some sort of attestation that is backed by your operator and then backed at the phone level by a consent framework that is on your phone and run by Apple services and Google services on your phone. So there are alternative mechanisms which have more, in some ways, consent built into it, but they are being championed by people who are running the stack on your phone. So if you are an IP owner, own your geo reputation. That's too important to mess up. I would encourage Indian ISPs specifically to be more engaged. We currently have very poor adoption at all of even the base level of practice. And the format is evolving, and there is much scope to make it more relevant to India and Asia in general. So that's it. Thank you.
Just like little bit background, when we were discussing this in the IIB to do this workshop, there was this whole thing because you used the word standard. Actually, it's sort of a very loosely used as standard. It's not a standard. It's an independent stream document. And because for the longest time, for us in the IETF, the idea of IP address having geolocation is against the basic principle of the internet architecture itself. But at the end, we have to live in the real world. And real world, it's actually solving a real problem that people have. People are paying good money to Siddharth and all to solve this problem. We have to live in this world, and we have to now see, okay, how do we evolve it? Is there a better way to do this? Can we add the idea of consent and doing it in a privacy preserving way, and let's start to explore. So that's why the main thing, we had a huge debate of, by having this workshop, are we legitimizing this thing? Are IIB saying that this is the right thing to do? It's like, yeah, we have to live in the real world. We can't live in, like, as I was saying, like what looks good on paper versus what's actually real. So it was really good for Siddharth and other people to participate and bring out all these points that you saw today during the workshop as well. So quick questions.
A quick question. So whenever we see that kind of an accurate database building in US and European regions, and for India, we don't have that much accuracy. So where do you find the gap from your experience, and what are the challenges?
So what I've seen is, our startup itself is a new entrant relatively in the past few years to the space. What we've observed, especially after this workshop, is that a lot of the big players in this area, in the IP data area, they were just doing some secret sauce algorithm, and they don't work very well. So you can claim that they work very well, but ultimately you have sometimes the IP owner needs to take control and say, for example, cloud, right? So let's assume Indian cloud companies and compare them with, say, AWS, right? So AWS has 1 million IPs. They move them around the world all the time. Some of their services use Anycast, right? Anycast, you routinely use IP as in a non-geolocation attributable manner. That's kind of the whole point. So the people who operate the IPs, who manage the IPs, who attach them to a given compute or a router or an end user endpoint, they take ownership of it, and they say, here is our feed. And provider X or Y, you're shipping nonsense to your customers. And we are the ones who are managing this, so you have to trust us and take us as the fundamental truth. If we are lying, we're lying. But then you can't run a trace route on an Anycast IP and then do a bad job at it, because it's obviously it's either wrong or it's going to change tomorrow because we're going to deploy it to Singapore because we had a peak demand in Singapore, or AI was going up in Ohio, so we wanted it to move to some other region, and your thing is now broken for the next 5 years. So they want to take control back, and which is a good thing in my opinion. So ISPs, like you said, in the US and the West, they are taking their own IP feeds like this, self-published feeds, very seriously. They're doing an honest job at saying that this is the source of truth for our IPs that we manage, that we attach and take decisions on every day. Who are you to tell us that our probe is telling that this thing is in the wrong country? We have to be the anchor. So there is a lot of evolutionary pressure on keeping up with the actual IPs of the operators of those IPs. We are not doing that. So if you're not managing your own reputation of your IP, who's going to look out for it? So the inaccuracy is because everything is based on dark art, which is not verifiable, and nobody is being held accountable for it. So everybody is asking for GPS location, right? That's the fallback. Nobody trusts in India IP geolocation databases. So everybody is asking for GPS location, even on the desktop. And of course, we don't have a history of strong privacy regulations. So everybody, we started the internet with mobile apps. So mobile apps had GPS location easily accessible. So that became an accepted default for all our consumer behavior. Right? So all of us have given GPS location to HDFC app or ICICI Bank app on our phones right now, almost certainly. And that is not the case with the rest of the world. But even if you ignore banking, I think the people who operate the IPs in our country and in APNIC region broadly need to take control and then say that this matters to our business processes, our routing and our traffic and our cost and our support. And that is when the ecosystem starts self-correcting. So it is, that's really the answer. So the IP owners have to start publishing their truth.
Vinayak, one quick question.
Yeah, sorry, he was saying something.
We have to move.
Yeah. So, I mean, as a privacy conscious person and also somebody who's very tech savvy, I feel that this sometimes this is very problematic, right? Because you want to pinpoint the location. I get the use for that. Many people use VPNs like Tailscale. Like now it's like super easy to self-host your own VPN. How does, I mean, doesn't that break your
So
thing?
my view is it can break
Just
all.
before you respond, one more thing. The other thing also is that IPv6 has this address randomization also built in, right? So, I can at least think of two cases. One is like VPNs, including self-hosted VPNs, and IPv6 randomization, which is kind of as Dhruv said, is a defense mechanism against geo IP location in some sense.
Okay.
One of the ways, yeah.
Yeah, so VPN, it can break the tool as much as it wants, this whole IP geolocation based concept, and that is fine with me personally, because when we sell this tool, we are not claiming that it solves all these use cases at all. We say that this will give you 80% of the information in 80% of the cases, but the other 20% you're not going to be able to solve with this tool. And you need, if you're a bank, you need to layer on two-factor authentication, your passkey, your Face ID. Face ID has become a default now in banking apps, which is great. So it is always part of a larger solution. It is not a monolithic solution to that problem. So we do not strive for perfection in all corner cases. We are going to do 80% of the job 80% of the time, or something thereabouts. And we cannot and should not strive for perfection when it comes to a banking use case or even a CDN use case. You need to have other sorts to mitigate that. When you're doing Prime Video, you will have the account information of the consumer because they signed up for your service in a given country. You will have the banking information of their charge, credit card or debit card. So those are your fallback mechanisms for verifying identity and trust anyways. And those are part of a good consumer experience. So use this in balance with other sources of truth, which you control as part of your business flow. And this need not need to be the 100% solution, which is 100% authoritative all the time. And that is okay. And IPv6 obfuscation, I'm not sure there is a need to care too much, because most of the IPv6 geolocation happens in huge chunks, also like /48 and /64. So even if you fuzz one single IPv6, like you're still going to land within that really huge subnet, which is probably geolocatable to the same city. So yes, we are not going to tag you to a GPS location. We don't sell it ourselves because it's privacy violating, and again, wrong tool for the wrong job. So at most a city or around say 100 kilometer diameter. So it's very coarse level, and that's the only solution that we propose ourselves. And we continue to abide with that this is the right tool for this class of problems. Anything more finer or privacy violating, you're in the wrong territory.
For the VPN one, in fact, that's a tool. Like you are paying money to a VPN person to get an IP address that has a geolocation of a different country. So in fact, it's you were completely true from the business point of view, but as a consumer, geo IP is in fact, I'm paying money to a VPN provider to give me a geo IP of a different place. With IP thing, the IPv6 part, I think when we do the privacy addressing, it's on this sides of the bits, not the prefix that we are putting it in the geo IP, which is, we don't have to worry. So I think those two problems are orthogonal. With that, let's have tea, and we will do a little smaller break. And we have one more presentation planned in the previous one, which we had to skip. So we are doing a 15 minutes break, and after 15 minutes, we'll have a 15 minutes presentation on Narasimha, then we'll move to the IPv6 one. The person who had a question, take the question while we are having tea. Let's go have some tea. And people, please sign up so that we know, like, whoever people RSVP'd actually RSVP'd and came or not. IETF in the ops area. So off to you, Narasimha, and introduce yourself, give us more context of how you got involved in the IETF, etc. as well. And then let's keep it a little bit more time. We have been running this thing. This is 15 minutes. Keep your questions ready, and keep your questions short and to the point.
Thank you.
And this is for moving up and down.
Hello.
I was originally based in US. I relocated to India maybe a couple of years back. So because of people not being able to pronounce the first part of my first name, Narasimha, everybody knows me as Prasad at Cisco. So if you tell them Narasimha, nobody knows who I am. So I've been at Cisco most of my working career in US. Maybe the last 10 years I've focused on routing, control plane, system architecture. I started focusing on BGP monitoring protocol over the last 2-3 years. My engagement with IETF interestingly started only last year. So it's just been a year at IETF, and it's been a great experience. IETF, I had heard a lot of negative things, which kind of forced me not to engage, but since the last year I've joined, it's been amazing. It's a very collaborative forum. Everybody's very welcoming. Somebody was asking me during the break, so I already have 5 to 6 drafts. So that should tell you that if you have any idea, it's pretty easy to put forth your idea and then start working with other people from the industry. Okay, and then this presentation is not sort of a deep dive into BMP, BGP monitoring protocol. It's more about use cases, why is this important, and then I'll give you a little bit of perspective into what is IETF in general doing. It's not like what work I am doing, but in general in BMP, in Grow, what's going on, what are the areas they're focusing on, and then how maybe you can also participate. Should I just use this? Yeah.
This is
okay.
Stop and
okay, got it. Thank you. Yeah, so we will look at why BGP observability matters, and then maybe a quick overview of BMP. So that you get an idea for the subsequent slides. And then we will look at what is already standardized, what is RFCs, and then we have a whole bunch of drafts, which is before it becomes an RFC, and then what are the takeaways. So why now? I think a few things are contributing to the BGP observability becoming more and more important now. One part of that is the scale growth itself of BGP. So it used to be around 250K, 300K, maybe a decade and a half ago. Now it's easily 1 million plus 2 million routes. And then there is network complexity also has increased. There's a lot of churn. There is more complex route policies which people are using. There is RPKI, which Siddharth touched on a bit. And then most importantly, there is a lot of network automation happening, which is also contributing in turn for the observability piece also, because they're looking not just at observing things, but also the whole closed loop stuff. So we will see how BMP kind of becomes a part of this whole story. So it's becoming like a data mesh problem. So one part of that is what BMP is trying to solve, wherein it's giving you a view into BGP routes, peer states, reviews and such. But along with it, most of the operators today, to troubleshoot their networks, for their network analytics and automation and stuff, they use IPFix NetFlow, which gives you the data path monitoring, which tells you what the flows look like. And then to add to that, there is control plane telemetry via YANG, and then there's your logging and events. So people try to stitch all this together into sort of a data mesh to build their network analytics and automation. So from my vantage point as a vendor, we are seeing two large use cases. One is, of course, the observability piece. The other one is a lot of traffic engineering also happens using BMP. These are some of the use cases. So first one is the traffic and path correlation. So for example, why is there a traffic drop? Why did the traffic move? So they get a view from BGP if it's BGP related, and why it happened. Did the best paths change? Did we get some update from a peer and such? Then the other key piece which a lot of operators use is for policy validations. Like I said, the inbound and outbound policies of BGP are getting very, very complex, and all operators want to make sure the intended motive of the policies are achieved. So they want to monitor all of that. RPK also is coming into this. There are some recent drafts in that area. And then another piece is to know more about individual paths itself. So there's a prefix, and there could be multiple paths associated with that prefix learned from multiple neighbors. It's your standard BGP. So they would want to know what is selected, what is not selected. If it is not selected, why it is not selected. Is it stale? Is it invalid? You know, like adding more color to the path itself. Then there is security and anomaly detection, especially around leaks, hijacks, invalid origins, which ties into RPKI. Then there is automation validation. So it's not just enough that config is pushed. Everybody wants to know, did the config have the intended action from BGP? Is the route programmed into RIB? Is the route programmed into the hardware? Is it really advertised to the peers? So it's not just enough to know that the BGP peer got configured, but they also want to validate what went on into hardware and what went to the peers. So this use case is both real-time and historical. So typically all the operators tend to store all the routes and paths into a time series database, and they do a lot of historical analysis. So that's one other use case. Yeah. So this is a quick overview for you on BMP itself. So it's a passive export only. It doesn't get into, so you don't need to peer with BGP for BMP. So you would have BGP peers, and then you would configure BMP on the router to peer with collectors. Collectors are the ones which are consuming data from the router. So it runs over TCP. So all the sessions, like if you have 5,000 BGP sessions, all of them can be monitored through one BMP session. Before we had BMP, they used to peer with BGP. So yeah, that's about it on this. We'll look at it a bit more in detail. So this is a BGP pipeline view for you. On the left is the updates coming in for BGP. Those are the BGPs on the left, and then the same updates going out all the way on the right. And then what happens on each of the routers within the BGP is sort of broken up. This is standardized. And I've listed the RFCs which standardize those individual pieces as well on top. So first the BGP updates come in, you apply the inbound policy, that is ADJ ribbon in the IETF standard terminology. And then you apply the pre-policy, that is in the green box, and then after the policy is applied, you may change the local pref, you may add community, remove community, RPK stuff, all that happens in here. And then you do your path selection, which is your best path algorithm, and then it goes into your local RIB. Then after local RIB, now BGP has to send these paths to the peers. That's where the out pre and the out post happens. So within BMP, there is 5 monitoring points which is defined, which is in pre, in post, local RIB, out pre, and out post. And the in pre, in post is standardized in 7854, and then the subsequent RFCs standardize the other parts. So as you can see here, all of these views can be monitored by BMP servers at the bottom. Server and collectors are interchangeably used as a terminology. And typically there is about 4 to 8 collectors which monitor the routes. I've seen typically 2 to 3, one for redundancy and one maybe for other reasons which operators use. A little bit more color on what each of the RFCs do. So the base RFC, which maybe came about a decade ago, kind of defines the ADJ ribbon. There is also messages defined for peer up, peer down. And BGP updates is encoded in something called route monitoring. So route monitoring works exactly like BGP updates, wherein it is store and forward, which means the updates can be coalesced. You don't see every single update which comes into the box. So it's coalesced every 10 seconds, 15 seconds, 30 seconds, which is configurable. The updates are sent out. That is route monitoring. Route mirroring is as-is replication. So as soon as the BGP update comes, the BMP header is slapped on it and it is sent out. So there are use cases for both these message types. Then ADJ rebout kind of adds on to that. As BMP grew, they wanted to monitor people wanted to monitor the outbound side as well, and then the local RIP. Typically, I've seen local RIP is used along with IPFix and those kind of data flows, because they want to know what is the best path BGP picked. It can be the best path, or it could be the multipath, it could be ECMP. They really want to see what BGP programmed into the hardware. And then they use IPFix or NetFlow to actually see whether those flows are actually getting used. If they're not, then they do troubleshooting based on that. And typically the inbound and outbound is used for policy sort of debugging, and then there are tons of other use cases like I touched on. So as you can see, it's moving from a basic route view export to a multi-view sort of observability sort of feed. Then you will see how it's further evolving. So in the last couple of years, there have been like 25 plus drafts which have come into the BMP area. There has been an explosion of drafts. Almost every other month there is a new draft. We have, I think, close to 35 drafts. Not everything is adopted by the working group. A lot of these are individual drafts. Yeah, I mean, we will cover the details in the subsequent slides. Yeah, so I kind of broke it up into 5 broad areas of what the Grow working group is looking at within the BMP space. The first one is extensibility. Because when BMP started, there were a set of use cases, but in the last decade, there has been so much which has changed. So there's a lot happening to look at extensibility of BMP. I think some of it Dhruv also touched upon on how we want to have more and more people use it, and we kind of do work at IETF for that. And then more work is getting done on the explainability part. Like I said, explain more on the path status, the policy outcomes and such. And then operational events, there's more work happening there. It's kind of becoming like a route log event, system event, kind of logging, more from a BGP point of view, but that is also happening. And then scale and efficiency is another piece, and the deployment readiness is another piece. We will double click on this in the next slides. So this, like I touched upon, it's for extensibility and adding metadata. So there is already BMP v4 being defined. The foundational RFC started at v3 for whatever reason, and now it is at v4. So there's a lot of work with TLVs and extensibility which the working group is looking at in this. The next piece is explainability and event logging itself. Why was this path not used? What's the path status? So there's more metadata getting added. If a policy gets rejected, why did it get rejected? Or if there is route instability, why there is route instability? There was a recent, maybe 1 or 2 years ago, a huge event, cap case in some sorts with, I think, Optus, where I think 30 or 40% of the network came down. I think one of the reasons for that was there is something called max prefix in BGP. So there is a maximum amount of prefixes which a particular neighbor can accept. So that number went above the threshold, and the default action taken was to bring down the neighbors, and all the neighbors came down and the network connectivity went off. And the network was such that even the manageability network was over BGP, so they lost connection to the entire network, and they had to physically go and bring the boxes back up. So it was almost like a day or two outage for Optus. So after that, there has been a lot of focus on that aspect. So how BMP can sort of send events to monitor, getting close to the threshold, 30%, 50%, 60%. So there are this work going on around that. Yeah, and then what else on this? Yeah, and then there is generic events. Like there could be configuration events specific to BGP, which you may not get from Yang or netconf. Then this adds much more color to that. Okay, so this is another view of the operational state synchronization itself. We are looking at health monitoring. We are looking at so there are cases where a peer stays down for a long time, though it is configured. So operators want to know about that. They want to know when the route import is complete, when the route export is complete, for example, because these are used on their network analytics dashboards to infer other things. and then a rib view getting unmonitored. So you can configure what specific rib view you want to monitor on the router. So when it gets unmonitored, when operator comes and says they don't want to monitor anymore, there was no event to tell the collector for that. So I think there's some work happening around that. This is another area which is important, mostly I think from a vendor point of view, but also for people who work on the network analytics side. This is because the scale which we are monitoring is increasing. And then if you think of it on the router, we don't have as big CPUs which you can have on like typical servers. So doing both BGP and BMP is a big challenge because it does take more resources, more CPU, more memory. So there is some work happening around this on how we can optimize the encoding itself. How can we improve and reduce the number of messages within BMP, within a review, across reviews and such. We are actually using the best practices which we have learned from BGP and bringing that into BMP right now. So I am actively involved in this and maybe even in this area, the previous area, operational state synchronization, and this. So I have a few drafts in all of these areas. I'm just sharing that so that you know that it's easy to participate in IETF and contribute wherever you have ideas. This is a large, this is one other last area where we are looking at deployment readiness. This is where BMP YARN comes in, transport security like TCP AO. We are looking at BMP over quick. There is RPKI, BMP being used for RPKI monitoring, then the statistics interpretation, and the compatibility piece which is coming in. This is a snapshot from Swisscom's network analytics dashboard. There is much more to show, but I just wanted to show you a quick snapshot of how they're using the historical analysis of BGP data, and they're using filters. This one is showing you the local review, wherein for a given RD and a next hop, they're showing what kind of events came in, how many events came in across the timeline. So this is just for BMP, but they have such correlations, like I said, in the whole data mesh, correlating a lot of other things, other data which is coming in. So this is the key takeaway for you. If you're a network engineer, please do look at BMP if you're not looking at it. Please do participate at IETF because we want to really solve the right operational problems at IETF. I think more network operators who come in and share those problems. I think one of the problems this gentleman was sharing, I think like that we need people to come and share their problems so that the right problems are addressed. For vendors and implementers like myself, we need to be aware of this work. We need to bring the implementation challenges to IETF so that they can consider that it is not just enough to define a standard. It has to work, it has to be practical, so we need to bring in that perspective. And then there is security angle, and for automation teams, you can sort of look at what's happening here to improve your network operability. So these are some links for you to engage and join us. Yeah. That's about it. Thank you.
Thanks, Narasimha. Questions? And you were mentioning why we did BMP v3, because actually BMP was done by Juniper first as a v1 protocol, which was never standardized. So v3 is when they took the work to the IETF, and that was the reason why we have v3 as the first version for BMP in the IETF. And interesting, like, when there was this all debate about which protocol at IETF is like most important, like BGP has a flex because it gets its own monitoring protocol and no other protocol out there gets their own monitoring protocol. So which is actually a very interesting thing, that why BGP needs its own monitoring protocol. Why it could not be a general purpose monitoring protocol that could have solved this thing, but this thing. Could you want to cover that a little bit? Like what makes BGP special that it needs its own specialized with its own TLVs, its own format in this way?
Yeah, I think there are a few things. One is BGP works across ASs. It works across different service providers, so that makes it complex. And I haven't seen any other protocol deal with the kind of scale as BGP does. And so this cross-vendor deployment of where BGP sits also makes the policies very complicated. So I would say maybe the complexity, it working across operators and maybe other two reasons. In fact, somebody took this idea and tried to do a monitoring protocol for IGP, but it didn't go forward. I think there is still an expired draft out there for IGPs. A generic way to do it would be telemetry. I think Google is actually trying to leverage telemetry. They have defined, in fact, parallel OCNI rib views, which are exactly like how BMP looks. But from what I've seen, most of the industry still prefers BMP. One of the reasons for that is also the scalability as of now. I think telemetry maybe will eventually catch up. Yeah.
Yeah, I mean, do you see, I mean, because you said it goes across AS and all, so across service providers, I mean, do you see any challenge in the security or the agreement when it comes to sharing the information across the different service providers?
Yeah, so what happens is typically so far, operators have their own controllers. So they tend to monitor whatever service providers, they tend to monitor only their network. But vendors like Cisco and such, we have generic controllers which are available, which helps them monitor things across, which tries to address some of the things like what you are bringing up.
But do they agree?
Do they agree? No, not always. There are security challenges. So that is why you see this more in the service provider environment, like BMP getting used, and maybe less in the data center environment where it is just controlled by one. So yeah, I think it's a mix of both, I would say.
Today, I mean, if I understand, this is predominantly used in the core or
yeah, that's right.
Free core. It's used in the free
mostly
core.
Mostly service providers use it. So it is used on the edge roles.
Okay.
A lot, like peace, I think is where I've seen. Recently I've seen it getting used on route reflectors as well, but the use case is less for route reflectors. It's mostly on the edge.
Okay.
Yeah. Thank you.
All right. Thanks. We are running 8 minutes late, but we should be able to cover up. Let's hope so. Next speaker with us, by the way, the next set of talks that we have from now until the lunch break are all related to AI in networking. The first speaker with us today is Vinayak Hegde, who will be talking about AI native networking. Vinayak Hegde brings 20 plus years of product development and software architecture experience spanning IoT, large-scale networks and internet protocols, data processing and AI ML as well. He has served in both IC and leadership roles, building teams across continents in several different companies that include InMobi and Zoomcar. Previously, he was worldwide CTO startups of Microsoft. He currently runs a tech and AI advisory firm called Brainiac Consulting LLP, advising early and growth stage startups on AI and also helping them build robust, scalable systems. Over to you, Vinayak.
Hi, thanks for the introduction. So I have been active in the IETF and I'm also one of the founders of IESoc. So some of you might have met me before. But to be very honest, in the last maybe 5-6 years, I've not been very active in the IETF, though I've been following work in the IETF. I've kind of changed tack, going more into the data domain. But networking is like a fundamental aspect. So eventually when you're building systems, you do run into it. What I'm going to cover is a little bit about, based on my experience. So when I was at Microsoft, I used to work with a lot of startups, right? And initially the work was related more to cloud and applications. And being at the right place at the right time, when Microsoft actually made a partnership with OpenAI. I was in the startups team and we worked with some of the early customers. This was GPT-2 before like ChatGPT 3.5 came, and then the world kind of changed in I think September 2022. So I had a very good ringside view. So I'm going to, based on my experience with IETF and with AI, I'm going to talk about how standards are made and where we are with those standards and why this time in AI or technology is very, very unusual, right? So let me start off with that. So this is a very famous slide by David Clark, who is an MIT professor. He calls it, he doesn't call it, actually he has a clarification on his website where he has not given this name, but this is what it is known as, called Apocalypse of the Two Elephants. The two elephants being the research and the $1 billion investment. And typically the way IETF works, or what standards, the standards which are most successful happen is when there's a lot of research. A good example, HTTP, there was a lot of work related to HTTP, and then the web kind of took off. Now there are people in the room, I think Rahul and others, who might say, okay, the hyperlink and the way HTTP was implemented was not, in some senses, the vision of the people who actually did the research. But commercially, it became very successful, right? And then, just as we have the AI boom now, we had the 2001 internet boom, and then there was a $1 billion investment. And a lot of this was based on standards. So we have seen this in multiple waves, right? So keep a view of this, because my talk is going to bank on this. So what has happened specifically in terms of AI is, especially with AI, there was what is known as a long winter, where there was a boom, and then the technology did not deliver. Like there were examples, especially with like things like Watson. Some of you might remember Jeopardy and how it was able to solve. There were also breakthroughs in chess. So there was a lot of research. But when LLMs came to the fore, what you are increasingly seeing is both the elephants, which is the $1 billion investment, and the research is kind of overlapping. So how do you standardize for an organization is getting crushed? So there is, the elephants are not separated, but in some sense overlapping. And that has a huge impact on standards, which I will talk about. So there are 4 acts we'll talk about. One is the pivot. We'll talk about the infrastructure and the fabric. Again, like this is not like my core expertise, so I know that there are speakers after me who will go into this detail. My expertise is more in the application area, so that's what I'll focus on. So the challenge is also in the access and content layer, and we'll talk about the mechanics and why commercially that has an impact. And then we'll talk about automation and where some of the protocols are being standardized, interestingly outside the IETF. So typically when you build AI model, there are 2 parts to it. One is the training. So you have a neural network, and you, for a, lack of a better word, you actually are showing him training it by increasingly adjusting the weights by showing it data and how the output should be. So actually tweaking the inter knobs, and that is what typically the training traffic is. So it is very scheduled, it is batched, it's bursty, and that's how the traffic is different. And typically in a large cluster, it remains entirely within that large cluster. And it's very tightly bound in some sort of a mesh, because typical GPUs follow what is known as SIMD architecture, where you have a single instruction, and at a CPU level we have multiple data. So the same instruction is used multiple times. So typical examples are linear algebra and matrix multiplication. And what that involves at a network level is, when one phase of computations is done, then there is a collect phase where all of the results are collected, and then there is another set of compute. So it happens in like waves, and that is how it is different. If there is a failure, there is this possibility of doing a checkpoint, wherein all the computation done to that point are loaded onto disk or some substrate, some storage, from which it can be restarted, right? So the entire run does not need to be done again. Similarly, when it comes to agent traffic, what happens is it is always on, unpredictable. There's constant communication because agent goes through multiple phases. There's reasoning, there's tool usage, there's also memory access based on what are the actions that have done in the past, what were what are all the data that it is access to, what are APIs that it has access to. So it is very, for lack of better, very, very latency sensitive and very, very frenzied depending on the traffic. So the access and the training traffic, the inference and the agent traffic are very, very different as compared to the training traffic. So again, as I said, like, there are three aspects. Layer one is fabric, which is basically moving bytes between GPU and the inference node. This largely, I would say, focuses on the training aspect of it. Then we'll talk about the inference part. Inference is like what we typically do to explain is like when we talk to ChatGPT or we talk to Gemini through a chatbot, or we generate a document. That is typically what I would say inference, right? So once the training is done, then move to the inference phase, and you will see that almost when it comes to inference, the amount of traffic that it gets is much larger. In fact, there is a case being made in India that even if you are not developing the LLM models, we should have different kinds of providers that provide inference, because the need for inference is almost 100x or even higher than typically training the model. The second part is access, and we'll get into that, and IETF is active in this area using AI Pref, WebBot, Auth, Working Group, and RSL. So we'll look at that. And the third part is automation, right? So earlier you only had a chatbot or different interfaces, but now with agents, agents can have personality. You can give them prompts. You can give them access to past memory and actions through markdown files, through long-standing memory. And there's a lot of research again going in this area about how to do it. So the agent can use tools. Tools are basically ways of accessing different kinds of resources, could be proprietary databases, could be different kinds of doing computations. And there are again a bunch of standards in this area. So we look at MCP and A2A. So the fabric wasn't, this will be covered in more detail by later speakers, but I'll just go a little bit brief into it. So distributed training and disaggregated inference now share clusters of 100,000 plus accelerators. And while these GPUs are individual, because of the chatty nature and the bursty nature of the traffic, they have to act not as like one, like different sets of GPUs, but they have to act like one machine. So you have like basically, when you're building a GPU cluster, essentially it's a GPU cluster is another name for a supercomputer, where the underlying fabric is really, really important. This is where I think somebody like NVIDIA has taken a huge leap from a commercial angle, and one of the biggest acquisitions that they did was with Mellanox, which has a huge market share when it comes to InfiniBand. And they also had this proprietary protocol where you could do direct memory access between different GPUs, or what is known as RDMA, using this protocol NVLink, which is not standardized, but which is then licensed. Again, it's a proprietary protocol again. So typically, the focus is how do you move data fast between different sets of memory so the computations can happen faster, and there is what do you say, the underlying fabric can move data around really fast in a very, very bursty manner. And that has been the focus. But if you look at the TCP/IP protocols, they were built for like, there can be out of order delivery, there can be multiple routes. But such kind of requirements in some senses do not exist for GPU, because what is the destination, know what is the source, and what the underlying fabric is. So the idea is to move data fast, and some of these characteristics may not actually be needed. And that has, though the underlying fabric, whether Ethernet or TCP/IP uses this, it's not as useful. So again, like as I put in the notes, through the Mellanox acquisition, NVIDIA built a complete stack, which is GPU, NVLink, and InfiniBand, which is the internode communication. And because it had a vertical stack, it had a huge advantage, not only when it comes to like the computation, and which it did with CUDA and other kinds of better primitives to access the GPU, but also at the network layer using the Mellanox acquisition. So there are two bodies. One is the Ultra Ethernet Consortium, which is a Linux Foundation governed organization, which is actually building a bunch of specifications for making this faster. And then there is RTG WG, which is part of the IETF, which is doing this in parallel. And again, like the drafts that I have noted, actually there are links to the problem statement to those problem statement in the references. So both are very early stage routing area drafts, but people are not, again, like because of the apocalypse of two element, research is going fast, and every research that gives you because there's huge amount of competition and also investment, any kind of advantage that you get, whether it is at routing layer, whether it is in terms of the agent architecture, whether it's in the LLM architecture, it is getting used. And while you would want people to share, and there is some sharing, whether it is NeurIPS or ICML, some of these conferences also in standards, it is not happening at the pace because there is huge commercial advantage attached to it. And hence, like, standards are kind of, in some sense, I would say, suffering. Also, you would see that many of the standards, as we go on, are being done by donations of where commercial organizations want a protocol to win, and hence they are donating it to the Linux Foundation or others, rather than coming to the IETF and kind of having that consensus. So it's a very different kind of model formation, where I think there are competing standards and you want your standard to be de facto as well. So every client can be a bot. So typically what happens now is because one of the tools, as I said, when you are kind of looking at an agent, and a good example, when you do Google search, the bot always has an access to LLM, but also has access to the search index, right? So this search index is built by bots. This is one example, and there are agents where you can get very specific queries. There are startups like Utori, for example, where you can tell them that, okay, I want to monitor XYZ area, and you tell very broadly things. You could say commodity markets, for example, and I want to crawl the news, and any event that meets XYZ criteria, either a spike or something that can move the markets, I need to get information. Now what is happening is there is a bot that has made a list of all of the such sites where you could get those news, constantly crawling at a very high frequency, and it's getting all of this information. That is get fed into the LLM to see whether it can move the markets in a little bit, and then it sends a thing. So there are multiple layers when it comes to retrieval, reasoning, memory, and eventually compute, and then notification. So a lot of the traffic on the internet is now with bots. Now that has created a very weird commercial tension, wherein the protocol was that somebody like Google or Bing or any of the other search providers would index your site. They would get access to a lot of it, including things behind a paywall. And whenever Google gives you, or whoever gives you the results, you click on that, and then you go to the site and you monetize that visit by either showing ads or selling a subscription. But now all of this data is now getting pulled in by the LLM. And the end websites where this contract was there, where in terms of monetization is broken, because now you're getting all of these bots. First, the commercialization angle has gone. The second thing, what is happening is all of their content is getting slurped in by the LLMs at a very high frequency. So the amount of traffic has increased, and the amount of monetization has dropped. So it's like a double whammy for some of the competitors. So I'm giving this context because all of this has to be seen in the commercial context, and then it kind of has an impact on the advisor. So, so it's binary. You can allow or disallow a path. You can say index this, don't index that. I think robot.txt is there. AIPref also has something similar. It's unauthenticated, right? So it is based on self-declaration. So there is no way of saying that you are who you are, and anybody who has built any kind of crawling system know that we do fake it because there is bot detection. Cloudflare was an example somebody gave, is an excellent example of that. And again, it's an advisory, so there's no enforcement. So there are multiple competing standards, as I said. There's AI.txt, there's LLMs.txt, there's a W3C standard called TDM Red, which is I forgot what the T stands for, but it is like data mining. I think training and data mining exception. So text and data mining reputation management. So again, this is a standard by W3C. It has some legal weight under the AI Act. But I don't see a lot of adoptions. Some of the AI companies have proposed AI.text or LLMs.text similar to robots.txt. So this is an attempt at more granular purpose-based permissions, because commercial organizations are now at a quandary, right? If you don't give access to LLMs, you are at a loss because your competitors will get discovered, but you won't. So you want to give access, but you don't want to give all of your content because then your monetization suffers, right? So they're trying to solve the problem of discoverability and commercialization by using these two levers in that sense, that you want to be discovered but not give too much information, just like you have a paywall. And that boundary is now getting negotiated, and that's where the battle is from a standards point of view. The work in the IETF is AI Pref. Again, there are two drafts, AI Pref vocab and AI Pref attached, which are kind of an extension, I would say, of robots.txt, which allow fine-grained control, whether you can allow this data for training or not for training. Where it should be used, what are the rules in terms of using that data. The challenge is there is no enforcement, and because there is no payment that can be done to agents or bots, because some of the because like for example the NYT actually sued OpenAI. There has to be commercial agreement at an organization level, but if you are a small provider, there is no way to do micropayments if I am consuming your content. So even if, like, as an LLM provider, I want to pay you money, there is no easy way for me to do that. So again, it gives you a little bit of fine-grained control, but it is advisory only. But again, like, what I said, like technical enforcement, authenticating crawlers, preference registry, any kind of auditing or transparency, it does not check or compel compliance. So there is no like policeman or any penalty for doing that. So what is the incentive for me other than the goodness of my heart to comply? And that is a challenge with the standard, because the commercialization, as you saw in the initial slide, commercialization has closely followed research. So research gives you an advantage in commercialization. So there is no reason to either share that standard or even disclose that in many cases, or even comply. Because why would you, right? Because if everybody else is doing that, there's no incentive for do that. Then there is a WebBot auth that tries to kind of solve these issues to some extent. Again, like you can see that a couple of them, Cloudflare, Anthropic, OpenAI, and Google, they have already deployed ahead of standardization. This is sometimes happens in the IETF, where you get real world data. One of the other examples from the application world that I can remember is when HTTP 2.0 was initially implemented in Chrome browser, which had a lot of market share, and then eventually it was kind of standardized, and there was this constant battle, or rather I won't say battle, but a constant communication between the deployment team and the standards team. But again, like this is where I think the apocalypse of the two elephants comes in, because now even before the standard goes, people will keep on making forks and doing that. So actually the standard is moving slower than the commercial angle. Third one is like automation, right? The reason why AI is popular is largely because of two things, right? One, it improves productivity, and the other thing is also wherever humans are involved or where automation involved, reduces the error rate. So error rate means there is some kind of penalty there whenever you make mistakes, and productivity means like if you replace humans, because humans can maybe only work 5 days a week, 9 to 5 typically, whereas your bots can work all the time if you do automation, right? So because there is some amount of automation that is happening, there are two sets of protocols that happen. One is, as I said, in tool discovery, right? So you have a LLM, and the LLM needs to know if I need to look at a search index, or if I need to get financial data, this is the tool that will allow me to do. Or if I want to say convert a currency to another, this is the computation, and attached to that I can get and translate maybe the currency. So that is how typically an agent works with a tool. An agent is basically an autonomous system that does reasoning, has access to memory, and can do computation on your behalf, right? So it can take actions on your behalf, and that is where I think LLMs built on top of agents built on top of LLM have more agency as compared to other software systems. The other thing is when you spawn an agent, typically it's not just one agent, right? Each agent will have a specialized profile. Like for example, one agent might be really good. Let's say if you're writing something, one agent can be tuned to basically generate text. The other one will act as an editor. And the third one will say, okay, we may be a domain expert. So say that, if you're writing about environment and generating articles about the environment, that can actually see, whether the domain is being covered adequately. There could be a fourth agent that can do all of this and, reference check. So you have an editor that checks for you have a generator that generates a language, you have an editor that checks the language, you have a domain expert that says, the text is actually conforming and makes sense to people in this domain, and you could have a fourth one that does like a reference check, right? So whenever this happens, they work in conjunction with each other. So the agents need to communicate with each other. So when you need tool discovery, typically every agent will need to discover some kind of tool, to invoke some kind of tool. So it has an n versus n problem. That is what MCP solves, to discover what are the tools available to do a certain action. Whereas when the agents are spawned, they need to communicate saying that, I am done with this text, now can you please edit it? Or I am done with this text and, can you see if all of the references are proper? So there has to be agent-to-agent communication. So one solves a vertical problem, another solves a horizontal problem. Again, interesting part to be noted is this was a problem, again a research problem and an actual practitioner problem that was solved by Anthropic. There were also other competing standards to MCP, but MCP quickly became popular because it became de facto, everybody started using it. So it was open sourced by Anthropic. In this case, in the case of agent-to-agent protocol, which is a horizontal communication, there was an agent-to-agent or A2A protocol. Again, there are competing standards, we'll get into that a bit. But the one that is gaining a lot of traction was A2A protocol, open sourced by Google. Not standardized at IETF, but at the Linux Foundation. So this is a little bit of more detail about what exactly, I explained this already. MCP solves like N is to M kind of mapping, whether it's agent to tool integration, so that agent can discover the capabilities of the tool and do this in a way which makes it easier. So now you will see that many of the websites to interact with agents, they have an MCP protocol to allow to tell you this is the surface area of APIs, the surface area of compute, the surface area in terms of what data I can provide, and then the agent makes a decision whether what API or what protocol to use to get that data or access that compute or so on. So here also you'll see that many of the large players like OpenAI, Google, Microsoft, GitHub, all are on the steering committees, and many of the cloud providers and also some of the financial operators are also backing this as members. So it has in a very short period of time gained a lot of traction. Even in the agent-to-agent communication protocol space, you have A2A protocol. There was also agent, I don't know how this is pronounced, but agency or agency as it is called. It's a play on the word agency, because what makes different agents different is the agency, right? Like humans have agency that they will take decisions. Agents can't take decisions on your behalf. That's why the protocol is named agency. It was introduced by Cisco. Unfortunately, it hasn't got as much traction, and A2A is kind of in some sense becoming the default standards. IETF is following along with WIMSE, the IETF group, which is workload identity in multi-system environments. But I don't know how much traction it will be getting, because now that the surface area when it comes to standardization is shifting really, really fast. So this is a challenge, for people who are actually in the IETF to be able to standardize this, because a lot of the standardization, at least in the AI age, when it comes to the application layer especially, is happening outside of the IETF and not at the IETF for various different reasons. I'm almost done with my talk, but the challenges I want to talk is, many of these protocols look at preference and what the provider wants, and the negotiation between the consumer and a provider is not very well done because there's no enforcement. So at best you can say don't use this, but who is to stop, right? Like for example, a lot of the artists or a lot of the book providers, their books were slurped in by the LLMs and trained on that. In fact, there are like lawsuits undergoing, and many of them. There is a very famous case where Aaron Swartz was actually convicted and eventually, unfortunately, committed suicide because he actually made JSTOR and some of the scientific publications available for free, which were behind paywalls. But a lot of the LLM providers have done that, but you can see that there is no enforcement, right? So that is a challenge. There's no way to authenticate identity. It's a patchwork. There are competing standards, but there is no convergence in terms of how the identity should be tracked. There is no shared cost layer. Even if I were ready to pay you, just like I pay you, just that is protocol in terms of ads. I send traffic to you and you make money via ads, or you make money via subscription. There is no shared cost layer, right, to do micro payments, right? There is no, for example, in an Indian context, there is no micro UPI where I can say, okay, this is my wallet, and every time I read an article or my bot actually access your website, make a payment of say 1 paisa or what for a fraction of a paisa. So there is no shared cost layer. There are commercial reasons for this, but also I think the challenge is also because there are no agent initiated payments. Again, there's some work happening in this area. And clock speed mismatch, which I said, right, like at the beginning, where deployment moves in weeks, whereas standards take maybe sometimes years to synthesize. So what to track? AI pref, I said, like WebBot AuthSpec is standardized, and I don't think standardized is adopted. AI pref's IESG submission has happened. See if you can build on governance protocols like MCP and A2A, because again they have traction. But again they are outside of the IETF. Identity layer, Vimse in IETF is trying to solve that problem. So see if there are certain ideas that you can take from it, or implement the protocols. And again, Fabric is a whole different battle, which I think other speakers in this can possibly talk about. So I think that's it from my side. Yeah. I don't know how I'm doing on time. Oops.
Take the questions at the end. No problem.
Okay.
So I would request you to defer your questions till the end of the session. All 4 talks are on AI. We are running short on time, so we'll just keep the questions at the end. Vinayak and the next set of speakers are already here. If you have something, you can just make a note of it and then please check it with them. Unless somebody wants to ask one urgent question. Anything that you think you will forget it. So if you think you won't be able to do that, then you can ask one question. But otherwise, we'll move on. All our 4 talks are on AI. So these slides are available, yes. All right, so next talk is by Shraddha Hegde. She'll be talking about the networking problems and solutions in AI data center. She's a principal engineer in HP Enterprise, ex-Juniper. She has co-authored 11 IETF RFC documents and several internet drafts. She has more than 20 years of experience in the networking domain, particularly in IGP, FRR, segment routing, MPLS, and IP security. She has vast experience in building and deploying highly scalable data communication platforms. And prior to joining Juniper, she worked as a system architect for a major telecom equipment vendor. Over to you, Shraddha.
Thank you. Thank you, Mohit. So I will get a bit deeper into the first layer from Vinayak's presentation. Fabric was the first layer of AI networking, and I'll get a bit deeper into it, and then we'll see some of the bits and bytes of what the problems are and what the solutions are. Yeah, so that's what I have on agenda. We'll talk about what are the problems, what are the solutions in traffic management, congestion, mitigation, and then some of the work that is going on in IETF, as well as the other research, which is research papers that are being worked upon outside of IETF. So we are getting deeper into the problem space of data centers for AI training workloads. So the the traffic characteristics of AI workload is very different from typical data centers that in the past, right? The typical cloud data centers. What is the difference, right? It's high bandwidth, low entropy, and synchronous bursts. So if you're aware of this collective communications, right, from NVIDIA, they have this all-to-all, all-reduce, these kind of operations for basically your in AI training workloads are, there is data parallelism and model parallelism. So the data sort of the computations get spread into multiple GPUs. And then the operations require that the data is collected from all the GPUs at the same time, and then there is a next step. That's called checkpointing. So when that happens, right, there is synchronous burst, like everybody is sending to one guy. So the traffic is peaking simultaneously, reaching one guy. So, if you look at the traffic pattern of this training data, it's like flat for some time, peaks, and then again flat, and then peaks. And that peak is a very short time, like in milliseconds. So, and then this traffic is very failure sensitive. What I mean by that is, the cost of GPU is very high, so you don't want them to keep the GPUs idle, right? You always want them to be working. And this training has a step dependency, that is like, to move to the next step, you have to collect data from all the other GPUs, whatever computations they have done, so that the training can move to the next step. So if from one GPU data doesn't arrive, then it cannot move. Then everybody has to wait until that comes in. So if that data is dropped, then he will retransmit, and then until it comes and reaches wherever it has to reach, it cannot continue. So that's what is tail latency, right? So the tail latency governs the completion of the task. I mean, you can't keep computing. There are checkpoints, and by that time, all the data has to come. Only then it can move further. And if it doesn't come, the other GPUs have to wait. So, and then there is problem of scale out and scale across. So what do I mean by that? Because the size of the model is like in frontier models, right? They are billion parameter models. So like initially the 38K GPUs was fine, but then because of the increase in the size of the model, the number of GPUs required to complete the training in a reasonable time, it grows exponentially. Now you hear of 100K, 200K GPU clusters. So that has scale limit, and then these are all power hungry, right? And availability of power is limited in a geography, right? So you have to spread your data centers across multiple locations just because the availability of the power. And then when you spread your data centers across geographies, you need to, your compute is also spread across multiple geographies. And now you have to sync between those locations for this training to compute. And so how do you scale across, and how do you make it reliable? How do you make it low latency? Those are the kind of problems that govern this space. Next button.
Now it's going up. Okay, so first coming to the traffic management solutions, right? So we discussed, the spikes, and simultaneously the traffic going in spikes, right? Then how can we avoid that? So generally, in data centers, it's a clause topology and very regular topology, and then there is the traffic is sort of ECMP'd. And because this traffic characteristic is like it's a low entropy, what happens is multiple flows will, even though capacity is there in the network, multiple flows will hash onto the same link. And if they are synchronous traffic, that is like both the traffic flows are like spiking at the same time, then that link gets congested. There's not enough capacity on that link. So there are these traffic management solutions being proposed in IETF. First one is deterministic forwarding based on SRv6 microstate. So you basically build paths, source routed paths from, so in this picture, if you see from the GPU, you say, from leaf 1, spine 5, leaf 2, and then GPU 2, there's one path, and then leaf 1,
leaf 3 and then GPU 3, there's another path. You basically build the source routed paths and then you pin down the flows to this particular path so that no two flows will simultaneously go through the same link. And that's how you kind of manage the traffic so that they don't cause congestion. So the second one is this BGP-based routing planes. You see there is a blue plane and there is a green plane. So you kind of segregate your network into multiple planes. And then you can, and this is a BGP-based routing plane. So there is a BGP is the routing protocol in the data center, and then kind of BGP makes sure that, for example, from the bottom leaf node, right, from R4, you generally have four next stops to reach to R3, right, R0, R100, R11, R22, and R33. So what this solution is proposing is you have multiple, you kind of make multiple plane, blue plane and green plane, and you assign them different locators. This is the SRv6 construct, basically different IP addresses. And then you, for the blue ones, you make only the blue next stops, and then for the green ones, only green next stop. And then you put some kind of traffic, for example, all reduced traffic onto the blue plane, and then all to all traffic on the green plane. So, and then there's a third solution, which is a multipath traffic engineering. So, this is basically a concept wherein you build multipath DAG, and then you do unequal cost load balancing. So this is more appropriate for a case when there are, for neo clouds basically, where there are infrastructure companies that rent out their GPUs to multiple customers, so that the customers' data models are getting trained on this infrastructure, and then how the network has to behave for this kind of scenario. Because in this case, because it's rented out to multiple customers, the traffic pattern is not very synchronous. So, so this solution basically, it's based on signaling and then reservation and so on. It reduces signaling and forwarding state. And then it is a strategically bandwidth managed solution. So the previous solutions are all based on ECMP and sort of doing a deterministic forwarding, whereas this is strategically managing the bandwidth based on, like, you know a priori like how much bandwidth this customer's training job would need, and so you go and reserve the bandwidth wherever the bandwidth is available. So next we move on to next set of problems, right? The congestion mitigation. Even if you do all this, like the deterministic forwarding or routing planes, or you do multipath DAG, there is still a possibility of a congestion. So if congestion happens, you still want to sort of avoid that congestion or quickly mitigate on the congestion and then push the traffic in a different direction. So how do we do that? And most currently deployed and popular solution is this DCQCN and PFC. So DCQCN is basically ECN-based regulation mechanism. ECN is an explicit congestion notification. So basically in your IP header, you set a bit. If there is a congestion, you set a bit, and then the traffic goes to the egress. And then from the egress, you see there is a feedback to the sender that there is a congestion in this path. And then the sender, it depends on the sender, can take various actions. He might slow down the traffic because there is congestion, and then when the congestion is cleared, he will further send. Yeah. And this priority flow control is an Ethernet-based mechanism. So what happens in this mechanism is that there are pause frames. So if a router detects a congestion on the outgoing link, what it does is it sends pause frames to all its upstream neighbors. And then the upstream neighbors, if they further experience congestion, they will further send to their upstream neighbors. And so it reaches whoever is like the ingress point of the traffic, and then he takes the necessary actions. There are some limitations of these mechanisms. For example, PFC, it causes head of line blocking. That means even unrelated traffic, because because you're sending pause frames to all your upstream neighbors. So it might even cause certain flows to sort of even the flows which are not really cause of the congestion, make them slow down. So so this is called unrelated victim, right? So yeah, so this is a CSIG is a latest solution. This is mostly driven by Google and Broadcom. So initially this was in IETF, but then it moved to UEC. UEC is the Ultra Ethernet Consortium. UEC is a closed forum based on only on membership, and then certain companies are driving this UEC forum. So now it's getting standardized in UEC forum. So what is this mechanism, right? So basically you see there is a CSIG tag right after the Ethernet. So the CSIG tag carries, it's a layer 2 tagging basically. It could be 4-byte or 8-byte tagging. And so you can put, when traffic is going, it's an in-band signaling. That means when the traffic is going through the network, in the packet, you add this CSIG tag. Okay, at the originator, the CSIG tag gets added, and then when it goes on hop by hop, if there are any congestion in the middle, then that router or the switch will put that information that there is a congestion in that CSIG packet. And then that packet goes to the end, and then application layer sort of figures it out and then sends a response back, and then the sender takes necessary action. So there are two ways that application may handle it. Either applications can, there is a receiver window in the application, so when the application figures out that there is a congestion, it can take action in the application layer to sort of slow down based on that window mechanism, or it can explicitly send a notification to the sender to slow down. So what action gets taken, that's in the application layer. So on the networking layer, it's just the recording of this information. And so what information gets recorded, right? So you can see the signal types here, right? So available bandwidth per port, so relative available bandwidth per port, per hop delay, and queue depth normalized by port speed. So basically, information is there about the bandwidth, information is about the latency of that link, and then by how much also, right? Like what is the, so everybody is like a minimum. You see that aggregation function is minimum. That means, like if the traffic now, the available bandwidth is, let's say, 10 gig on this link. When it goes to the next link, if the available bandwidth on that link is like 8 gig, then that guy updates. Otherwise, that guy won't update. So you know end to end what is the minimum bandwidth available. So that helps you to determine whether there is a congestion, right? What is the bandwidth available on this path. So similarly, even the latency, right? Latency also, like it's a max function. So if every router, when the packet moves, if the latency is higher than what is recorded in that packet, it will go record that information in the packet. So this is a very it's a high resolution observability because it's in-band signaling, and it's a very low overhead cost compared to other mechanisms that are being proposed in IETF. So this is either just 4-byte additional information, whereas if you see other mechanisms that are being proposed in IETF, they have a big header like 40-byte, 50-byte, and every hop you kind of record the information, which kind of bloats up. And so when that information bloats up, you can't really do it for every packet. So you will have to select the packets, you have to put some kind of a sampling and then record that information, whereas CSIG, because the overhead is very small, so you could do it for every packet. And then they have also defined backward compatibility, like in the middle some switch doesn't support this, then how to. So with respect to congestion notification, there is this new working group FAN. So the origin is from FANTEL BOF that happened in IETF 123, and the motivation of this working group is fast detection, signaling, and mitigation of congestion. So the CSIG and other mechanisms, right, especially CSIG, the DCQCN and then the PFC mechanisms, those are in the Ethernet layer, right? And then The CSIG is also is in the Ethernet layer. There isn't really any action that the network is taking when the congestion is detected. So it's in the recording is in the Ethernet header, and the what action gets taken is in the application layer when it comes to CSIG. And it is the CSIG header where it gets inserted is even behind the switch, right? It's on the host where the CSIG header gets inserted. That's how the mechanism is being defined. Whereas what is this FAN working group looking at is, all the detection, notification, action, everything happens in the networking layer on the switches or the routers. So that's what this, and it's a relatively new working group, and a lot of new drafts, and this is probably some very interesting area if people are interested in AI data centers. So this, what we talked about so far is all mostly IETF focused, right? And there are these research papers that got published. So this is work being done outside of IETF. So this is called MRC, Multipath Reliable Connection. So what this paper talks about, and this has been published by a number of companies together, right? NVIDIA, Microsoft, AMD, and a few others. So what this paper talks about is the way all these companies have been using the AI Ethernet networks for AI training, right? So that's what this talks about. So the first point it talks about is the topology, right? So topology is a two-tier topology, like fixed, right? I mean, we have seen three-tier topology and all of that, and we say 5-layer and all of that. But here they say that it is what they have used is two-tier topology. And then it's almost 100K, 120K kind of a GPU scale that they are able to build with this mechanism. It's just two-tier topology. And then it is multiplanar. And the reason they give why it has to be multiplanar is if there is a failure, if you build networks using 800 gigs, if one link is gone, then you lose 800 gig. Whereas if you build 8 planes of 100 gig each, if one link is gone, then you just 1/8 of that is what capacity is what you lose. So they say that that's the, doing a multiplanar network is a better way of building network topologies. And they say this is 2-tier, so it reduced number of hops. Like if it's 3-tier, if there's a super spine, then there's one more additional hop. So this kind of reduces the latency. And then, as I said, it's a reduced bandwidth exposure to failure. So, and what the interesting thing, right, they say that they're not using any kind of dynamic routing here in this at all. It's all static routing. So SRv6 UCID based pinned paths, and absolutely no BGP, no routing protocol. It's every switch says, every switch has switch and a link has a SRv6 microSID based identifier. And then from the NIC itself, you kind of stack those to say the traffic takes first plane, second plane, or third plane, and so on. And what they mention is that if you use, and how do they detect failures, right? If there is no dynamic routing, how do they detect failures? Is all based on the identification in the application layer itself that you are not receiving ACK, or you're not receiving, or there are mechanisms such as packet trimming. Like if the packet is getting lost, then you trim the packet and you send it. So this is an existing mechanism in the switches, and based on that, they detect that there is a failure in this path, and they kind of change their load balancing factor in there. Like if they have built 8 paths, they change their load balancing factor so that now traffic goes on only 7 paths, and the first one is sort of left out. And this MRC protocol is basically NIC based. It runs on the NIC, and the main function of this is the reordering efficiency. And they say if you build 8 paths and you do packet spraying, right? So it's not a flow-based ECMP. It's a packet spraying. Like irrespective of what flow it is, you just keep spraying the packet on these 8 paths. And then so the traffic is kind of evenly load balanced on these paths. So one of the problems with packet spraying is that packets will get reordered. Like one flow, maybe one packet is going through the first one, second one packet is going through the second path, and so their latency may not be exact queuing, and other latency may not be equal, so that when it comes on the receiver, the packet is not in the order. And then you have to have a mechanism on the NIC to be able to put the packets in order and then consumed by the application. And this MRC protocol enables that efficient packet reordering. So with this MRC protocol, you can do the packet spraying. And there is on the Ethernet no PFC and other congestion mitigation mechanisms, right? So it's recovery is based on packet trimming and selective retransmission. So that's the last thing, the graph that you see, right? And this is in the published paper, they show MRC versus Rocky V2 performance. So you can see that the blue line, top line is the MRC. So it gives, as the message size increases, you can see that it's performing much, much better than the red line, which is the Rocky V2 16 Q pair based mechanism. So, and the dotted lines, right, those are, whatever mechanism you apply, right, there's some kind of a packet loss or some negative scenarios that happen in the network, and how this basically behaves in case of packet loss scenario. So the dotted lines that you see is you can see that 1% loss, 0.1% loss. It shows like the MRC performs way better than Rocky V2 when it comes to when there is a packet loss scenario in the network. So this is the last one. This is random network graphs. This is published by Amazon. So this is a very different approach, right? And they also say they have been using this in their network for a couple of years. So what you see on the left side is a typical data center network that we are aware of, right? It's a tree. You see that leaves, spine, and then super spines network, and this is how the data centers are built everywhere today. So what this paper says is they have kind of broken away from this traditional way of building data center networks, and they have gone with the one which is shown in B, which is a random network graph. Basically, they connect nodes randomly instead of in a very regular fashion or tree fashion that people generally use for building data center networks. Why do they do that, right? So they say that these factories have some limitations, right? If on the higher layer, if there is some failure happens, right, then there is very less resiliency downstream in these networks. Like if your traffic has reached up till the super spine and then there are some failures in that layer, then there are very less resiliency mechanisms to reach down to the GPU. So those failures are very expensive in this kind of factory networks. And they say multiple tiers causes for every traffic there is 1, 2, 3, 4, 5, right? It's like from leaf to spine, spine to super spine to spine, spine to leaf. 5 hops before it reaches the other GPU. So, and every traffic has this 5 hops. They say that is very expensive, that causes some latency, and that's not really necessary. And they also say that scaling requires entire tier to be added, because if you see T1 to T2 is not directly connected at all. It has to go to the spine and then connect to T2. So if you have to scale this network up, we have to build layers. It's not like you can just bring in and add one router. That's not how the factories can be scaled. So you have to build layers. So they say that is very expensive. So what is the key innovation, right? They call something as shuffle box. So it's a physical hardware. So I'm not that hardware savvy to understand how exactly this works, but what they say is the shuffle box makes it easy. See, if you have random connections, right, it's really hard to make those connections for an operator who builds that network, how to connect, which port to connect to where, right? So if they say that this shuffle box simplifies it. So it's a hardware wherein you just plug in, just like how you build factories, you plug in your GPUs and your switches onto that shuffle box and then make connections from those shuffle box. And then their routing algorithm is not typical distance vector or link state routing. They have a routing protocol called spray point routing. So basically it says, so in a distance vector, what we typically use is the shortest path first algorithm, that you assign cost, and then whichever is the shortest path, you route based on that. But whereas they use kind of a spray point routing. Think of it as like building a BFS or a DFS, and then every path is sort of every path from the source to the destination, which is non-looping, can be used for doing load balancing. So you get many more load balancing. You get many more paths through which you can load balance basically in this approach. And what is the result, right? This result is really astonishing, right? And for any executive, if he sees this result, is like, mind blowing. They say that 69% fewer routers. I mean, whatever they can achieve with whatever capacity of the data center they can achieve with this factory, 69% is saved if you use this random RNG mechanism. 33% higher throughput, 40% reduction on power. And then losing 1% router reduces 1% capacity, and not catastrophic as in factories. So very, very impressive results for any executive level people who are looking into this. So this is again, it's a research paper published by Amazon, and they say they have been using this since past couple of years in deployment. Yeah, these are some references to drafts and research papers that you can. Yeah, that's all I had. Questions?
Yeah. So, thanks, Shraddha. I think we'll take questions after one more talk for you, Vinayak and Santhosh. So, moving forward, we have Santhosh with us, who will be talking about the AI inference streaming. So, let me take a moment to introduce Santhosh. Santhosh is an architect at Zscaler with over 20 years of experience in networking and systems infrastructure. He currently works on proxy layer infrastructure for cloud cybersecurity with a focus on AI traffic interception and inspection. Prior to Zscaler, he held engineering and architecture roles at VMware, Juniper Networks, Selector.ai, and Samsung, working across data center and virtual networking, routing protocols, distributed infrastructure, and AI operations. He holds 20 plus patents and has co-authored 10 plus IETF RFCs. So over to you, Santhosh.
Thank you. Thanks, Mohit. Today I'm going to talk about the AI inference streaming. All of you might have either used or forced to use AI tools today, right? I mean, all the IDEs or the web-based interfaces, right? Now, when you use it, what really happens behind the scene and on the network is what I'm going to walk through. In the recent past, I work on the proxy layer right now, and as a forward proxy, I had an opportunity in the recent past to really test all the AI tools, big vendors like Claude, OpenAI, web interfaces, and also the Claude Code, the CLI, as well as their desktop interfaces. And also a lot of IDEs like GitHub Copilot, and then Cursor, Windsurf, to figure out what the traffic pattern really looks on the wire. Because we need to do the interception of those and then apply DLP, antivirus, policies, firewall. So it becomes important for us to understand what the traffic pattern really looks on the wire. So I'll just, what do they really use? So currently they use HTTP2, HTTP, and Quick, not much of Quick I've seen because of not many proxy vendors supports Quick today. But otherwise they use HTTP2 predominantly, WebSocket over TLS. These are standard protocols, and above that they use SSE. These are all standard. But what is not standard is what the payload that they carry. Each vendor have their own way of streaming the tokens back to the client. Now, how does it look like, right? So there are public API, like, OpenAI, Anthropic, Google Gemini. So when you use a browser or a desktop app, so they use HTTP plus application. There is one request that goes from a client to the LLM server, LLM endpoint, where it is actually an HTTP JSON post, which usually what we see as a transactional HTTP post. The response is SSE. SSE as in server stream events. So basically here, it's all the LLMs will start spitting out the tokens. Now the token could be as small as few bytes, like I have seen just 80 bytes of a packet coming in, and as big as 40 KB as well. It depends on what the response is. Right? Similarly, there are IDEs. They take a different approach because IDE has their own backend. So they take a bit of a different approach. Now in an IDE, if you have already used IDE for your development work, then you would have seen that you can choose a model, right? Or you can say that, okay, adaptive mode, so that it chooses whatever the model appropriate for the prompt you have requested. Now, what they do is, between the IDE and the backend, they use Connect plus Proto. Basically, it's a protobuf, a message over HTTP2. And then the response is also a protobuf binary, right? So what happens in the backend is when they are talking to any of the LLM API endpoints, they do convert this protobuf into the actual schema that they, the LLM endpoint really supports, and then that's how the conversion happens. Now Microsoft took a altogether different approach. This is the only implementation that I saw, was that they are using WebSocket and they are using SignalR over the WebSocket, right? So each vendor, there is no standard on how to use it. Yeah, of course, most of the vendors or well-known vendors are using SSE, but what goes inside the SSE is not something standardized today. So what we observe on the wire, this is exactly what I was saying. Text at JSON path. Like if you look at that section, this is the actual payload that they carry. Now the tokens are spit out. There is a lot of metadata that goes from LLM to the clients, and they have a different format. Though they communicate the same thing, it's the token, it's the start of the message, it's the end of the message. These are server telemetry and whatnot. It's pretty much remains the same, just that the format and the schema is different for different vendors. Yeah, same token, different payloads. This is exactly like Hello. Hello has been represented by OpenAI with a different schema. Again, OpenAI itself has different schema for version 1 and version 2. Earlier, whatever I have shown you is the version 1. It is not very verbose. But then Anthropic had event, which used to say what event it is. Like, is it a message or is it a metadata or whatever it is. And that's how OpenAI also went to version 2, which is more verbose now. And then Gemini has its own way of, or a schema. And Connect plus Proto, it's a kind of not really a standard, but there is an open spec for this, where it says it has to be a 5-byte envelope header, which is 1 byte of a flag, which says whether it is gzipped or not, and 4 byte of a length, and rest of this is protobuf binary. So this is the real PCAP from the ChatGPT. So tell me about universe, right? So the actual response was the universe is the worst expense, blah, 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 blah. But 96% overhead. So basically what we receive on the client is 4 KB of bytes, bytes on the wire, but 181 characters is actually what makes sense, right? So what really happens in the background is interesting. So where did 4842 bytes go? Right, so from the server when the response comes back, you actually see that, it spits out tokens, that is the last one, that is 181 characters. Rest of them are mostly like JOT tokens, whatever the input message or the prompt that was given by the user, it sends it back for the context. And then message scaffolding, for example, you type something, it says thinking and whatnot, right? So that is what you see. And the message markers. So it has, like, ChatGPT at least has different channels. So what channels means is, like, what is the final channel, like what you see as an output, and metadata channel, like, it keeps spitting out some information, like, it is working on this, oh yeah, I went wrong. So that is not the final channel for you guys, or for the end users, but the final channel is where it actually gives you the output. So it has too much of metadata just to communicate 181 bytes of response. And it does make sense too, because which otherwise the context is lost, and server telemetry also comes, and also it tells what is the plan and whether the user is allowed to access this or not and whatnot, right? I mean, there are a lot of information that is flowing through. File upload pattern, this is quite interesting because I was trying to figure out, because for us as a proxy, it is important for us to scan the files, whether it has malwares, antivirus, any leaking of the data and all those things, right? So I was trying to figure out what really happens with the file upload. So some of the vendors have taken an interesting approach. If the file is within the threshold limit, for example, 30 KB, or I'm just taking an example because each vendor have their own threshold limits. So what they do is they read the file locally. They do a base64 inline message in the JSON itself. So as the end user or as a proxy, you will not know whether it is a file or a chat message, right? So we will have to look into the payload to figure out what really is happening, right? So Anthropic, OpenAI, Gemini does the same thing, pretty much the same thing. It is just that the Microsoft uses the SharePoint to upload the file via the HTTP to normal path, that is normal upload, and then uses that as a reference in the prompt to say, please go and analyze this file. For example, you upload a PDF, image, or a code .c file, right, or a .py or whatever it is. That is how the approach is taken, right? So Microsoft does HTTP or HTTP2 file upload, and then it actually gives the reference. Microsoft also does something strange. It has its own proprietary, though there is a standard for content range headers, that means that a file is huge enough, like 1 GB of file you're uploading, then actually it splits the file into multiple chunks and uploads it to the server. But what it does is it doesn't follow the RFC standards of content range, but it has its own mechanism, and that's how it uploads the file and gives that reference as the chat message. Now Cursor and Windsurf are the IDEs which sends all the files, reads it locally and sends it on the wire like a protobuf, right? So this was pretty interesting behavior that I saw. Stream behavior divergence. So basically they use HTTP to stream lifecycle, but again some of the vendors use one stream for the entire conversation. That means it's a long-lived stream. Now if you are not aware of what HTTP2 is, HTTP1 has one TCP connection for one session, whereas HTTP2 has one TCP connection but multiple streams above on the same HTTP, on that same TCP connection. So now if you look at the behavior, what is supposed to happen is one session lives for one conversation, and then there is an end of stream, that stream is gone, a new stream will come up. But different vendors have taken different approaches. Some of them, like Cursor, actually keeps the one stream alive forever, for all the entire conversation. For whatever reason, if it goes down, the next stream will be spun up, but otherwise it keeps it for a long, just one stream is enough for it to have all the chat messages to and fro between the client and the LLM server. But whereas Windsurf has taken a different approach, it actually kills the stream after every conversation and spins up a new one. So it's a random behavior across all the different vendors. Transport fallback behavior. So basically, if you look at major vendors, since they use SSE over HTTP2 quick or HTTP, the fallback mechanism is if the server doesn't support HTTP2 or HTTP3, then it falls back to HTTP 1.1. Whereas Connect Plus Proto is explicitly supports, it is supported only on HTTP2 or quick. So there is no fallback. So if a server doesn't support HTTP2 or HTTP3, or a proxy doesn't support HTTP2 or HTTP3, then there is no fallback. So that means that they just don't work. So summary is that they all use HTTP2 or the WebSocket, SSE. These are the common things that they use. Every vendor has their own different schema. There is absolutely no standardization over there, and there is no standardization on or the work going on in IETF either between the agents and the LLMs. I don't think right now people think that it is a private communication that happens between the agent and the LLM, but there are certain use cases that really needs a standardization in this area as well. Yeah, that's about it. I think I wanted to cover quickly on what you see on the wire today. Thank you.
Thanks a lot, Santhosh. So we have, please give a big round of applause. We have one more session by Dhruv on what is happening at IETF and IRTF with respect to AI. But before we go to that session, maybe it's a right time for us to take a few questions if you have for Vinayak, Shraddha, and Santhosh.
Santhosh, at least right now what you are showing is like I'm missing what is the multi-vendor interoperability scenario right now. It's not like I'm expecting my ChatGPT, local thing to talk to Gemini.
Right.
So what is the interop? Why would there be a standard here?
Right. So it is not the interop problem, right? I mean, I don't think a client which is talking to ChatGPT needs to talk to Claude. That is not what I'm saying as a use case. The use case here is right now, as an enterprise, right? I want to have multi-model LLM provided to me, right? So for example, Cursor gives you, or any other IDEs, gives you multi-service providers like, Claude, Gemini, and all those things. Now, for different LLMs to use, I need to have a different SDKs, right? Now, if this is standardized, then I can have one open source SDK to talk to any of them, any of the vendors, right? And from the proxy point of view also, if you look at it, for every vendor, I need to maintain the mapping of what the the schema is, right? I mean, now as an enterprise, you really need to have a security for yourself, right? And if you want to apply DLP, AV, and all those things, then I need to understand what the schema is, extract the content, and see whether the data leak is happening or not.
No, I completely understand your problem, but why would, if I'm OpenAI, why I'm going to standardize for your benefit?
Exactly, that's the question.
So what is the win for me?
Yeah.
Yes, please.
Supports the OpenAI format. But even then, what was earlier happening is humans were talking to LLMs and getting back. That's what I talked about, chatbots and other things. But the game has now moved to agents. So now I'm telling an army of agents, which is basically autonomous programs, they have to chat amongst themselves. This is not the most efficient way to chat. That is one. Yeah, I'll come to that. Now, the second scenario, right, is if you see how systems are built, today if you look at production systems, you don't typically use just one LLM. You use an LLM, you'll use an SLM, you'll use like traditional models, right? Like I can tell a real world example, right? Like in automotive, for example, if I want to detect faults for predictive maintenance, I get these fault codes. Now fault codes have to be mapped, and there is no kind of standard dictionary. So sometimes you can use an LLM for that. But once you get it, maybe then you will use the traditional models. So there is this constant orchestration between, and you can build agents for this, there's constant orchestration between them. Now what you're doing is you're building all of this scaffolding which was derived for human to machine communication, essentially, right? But this doesn't scale very well because, as I think the statistics that I think is on his slide is the amount of content that is there compared to the overhead in terms of the packets is very large. Yeah. Now if my two agents are talking, hold on,
this talk was not about agent, at least to me. That's why I was doing this.
No, but I think this has, why I'm talking about agents is this has implications on agent. So now two agents are talking, right? And if you are like OpenAI or Anthropic, you know that in the real world, you will have to do interoperability. There is no, like, if I am an enterprise, like, who is building such stuff, I am not just going to use one model or different model, because there has to be some amount of fungibility. Again, there are different challenges with that. But I would rather use something like what he said, like protobuf, where there is no overhead in terms of serialization, deserialization, because two reasons. One is the overhead itself, and the cost of serialization, deserialization, which adds to the overhead, not only from a network point of view, but also from a compute point of view. So now, basically, you are playing with three things, right? Like one is storage, compute, and network. Now, in terms of storage, if you are storing this, you're storing a lot of data, even if it is gzipped. Second thing, in network, you're sending a lot of data. On compute, you're serializing, deserializing. So if the format is, for example, say binary, which is I would say, the ideal possibly format for something like agent to agent, especially with, multi-tier orchestration. All these three tiers can be optimized. That is why there is that.
Like, you are answering a wrong, like, not my question. See, the thing is, we know that there are, that's why we are doing things in IETF. We know there are building blocks that we need. Here the question was, payload need to be standardized. As if every application who is in AI space needs to agree that, that this is the only way in which I need to build LLM. And somewhere there is a governance body out there which all LLM companies who are competing with each other would come together and standardize. I was asking, where is the, like, where would that happen? What is the motivation? I understand technically there might be benefits, but
the motivation is not from the LLM provider side. The motivation is from the enterprises or the user side. So they will force this to happen, which is why
No, enterprises agree, because, okay, there is a problem for an enterprise that if I have to use a certain LLM service provider, then I have to use their own SDKs, right? Now, this proposal is to have an unified SDK. It could be an open source, homegrown, or whatever it is. Yeah.
It's a great idea, but how would we?
Exactly. How do we see? This is a challenge. When I actually brought it up internally in Zscaler as well, this was the first challenge that came up. Like, why would anyone participate in this, right? And that's exactly why we are working with some of the Gemini folks and others to bring them on to make them understand what the use cases are.
Let's take other questions.
No, it's just related to this. Going back 30 years, why would have anybody gone on to REST and using HTTP? Some of it is you need some level of standardization on the communication side. On the traffic side, you want to leave some amount of freedom of what the actual traffic is. But still there is benefit in having some negotiation where you can have some standard forms of traffic at least. And that is, I think, this thing you are trying to point towards. That's the middle ground that you would kind of reach.
Questions?
So I would just like to mention that Vinayak mentioned that OpenAI standard is now kind of the de facto standard across all the APIs like Gemini. You can, so, and regarding the point on SDK, so there exists an OLAMA, like OLAMA and open source or being your own key kind of situations, right? Where you just have to put your key specific to Gemini, specific to OpenAI, whatever, and the API that it uses to basically ping the, say, Gemini server, Google server, it uses a standard OpenAI API calling format, and that is standardized now. So you can use just a pip install OLAMA, and then basically have your Gemini key within the environment, and you can do the Gemini call, you can do an OpenAI call, and in that API case would be standardized right now. But what it's talking about in talk here is the actual web interface chat client. That is what, when you're seeing through basically the traffic from the Wireshark and everything, that is a proprietary implementation of the company that is, say, OpenAI has a chat interface, right? When you're browsing through that, what you're seeing in WireGuard is that format. At the back end, that API is still standard. Like if you want to say in your own app, call OpenAI standard, like what Cursor and what is doing is basically they went with protobuf because they didn't want to expose their maybe implementation or the key on this. So they went with protobuf, we'll put it in binary so that also decreases the attack surface for us. So that was one key point I wanted to just mention.
So I have a different question actually, Santhosh. There's so much being talked about upload traffic versus download traffic. Any thoughts on that? What are you seeing?
Yeah, so actually the thing is, earlier it was thought that in 2028 is when we will see a lot of traffic for which is more of an AI traffic, and human traffic will reduce. But it has already picked up in 2027 as per Zscaler statistics, right? So we already see great amount of uploads. Basically, right now everyone is experimenting. All the enterprises are actually forcing people, not forcing, but actually encouraging people to use. So to use, no, I think it is getting recorded, that's the reason. So encouraging people to use AI tools. Now, some of them have not really understood the consequences of it, because when you give a tool, it's a dangerous tool to have, right? Some people are just uploading the code, not understanding where it lands up, whether it is training the LLMs or not. So right now, we are seeing the traffic, upload traffic as well, like a lot of PDFs and whatnots are coming in, right? They are uploading as part of either it is experimentation or training or whatever it is. But yes, upload traffic versus download traffic, if you ask, I don't have a data right now, but there is a tremendous amount of data that has increased with AI to agent to LLM traffic has really increased in 2027 itself. But prediction was 2028, so it has already picked up.
Some questions for previous speakers also.
No, I
Don't spare Vinayak and Shraddha. Ask them as well.
Yeah. So I have a question for both Vinayak and Shraddha. On the fabrics part, you talked about UEC standard, but I work on a competing standard which is CXL. Have you seen any thing on that CXL pushing towards AI clusters? Because there are a group of companies which work on CXL fabric for interconnects. Right?
Yeah,
Intel,
I'm not aware.
I think Intel is the one who donated their standard to CXL, which works on PCIe 6. Right? Scale up, yes. Yeah. CXL is an industry consortium one. Compute Express Link.
Which companies are part
AMD,
of it?
Intel, all of them are on that. I think Intel started by donating their universal interface, UIEC, towards this, and then now it's CXL consortium. They have version 3.
So this is also like, okay, so this is probably not an Ethernet-based solution.
No, it's not Ethernet-based, and it can interconnect varieties of devices. You can connect accelerators, you can connect external memories, you can connect also CPUs, GPUs. So there are three types of type 1, type 2, type 3 devices in CXL.
Yeah, interesting. Yeah. Probably it doesn't play in the part that I work on, so probably I'm not aware.
Okay.
Yeah, but good to know.
Okay.
Is it like more in the, did it come from a supercomputer interconnect kind of domain?
From data centers.
Okay.
But not on the Ethernet side.
It's more on the server. Within the server, if you have more interconnect CPUs and other PCIe devices,
Okay.
how do you...
Yeah, parallel to probably NV links and such.
Disaggregated data centers.
It's probably on the parallel to NV link, right? Yeah.
I have a question for Shraddha. So from a control systems point of view, right, like I saw in one of the slides, you mentioned that there's a pause frame sent back. Because it's a feedback system and kind of, cascades up the stack. It can lead to a problem where there is stoppage, startage. Like how do you, as a control system, how do you achieve some kind of dampening? Because I understand what you're saying, the problem you're trying to solve is like there is bursty traffic, right? Ideally, I mean, because of the way the GPUs work, ideal way would be to have like maybe a flat line, so you can actually provision better. And because of way training works, maybe that's not completely possible. So how do you control the feedback mechanism, especially the case of dampening? How will you do? Because otherwise there will be constant thrashing in some sense, bursty. So you're kind of making the problem in some sense.
Yeah, it's very approximation, right? Like you are trying to, and PFC also has this problem wherein the traffic which is really causing congestion is not the one which is getting penalized. Everybody is getting penalized, and the problem exists, but it is still better than having nothing. So PFC is like still quite very much deployed because it's better than having nothing, so that at least you have a mechanism. If there is a congestion, you kind of slow down on the sender side and try to bring about some kind of a coordination among all the senders. But it's not it has its own limitations, as you mentioned. I don't know if there's a problem of if there's a dampening required, or if there is, because the traffic pattern itself is very spiky, right? It goes up and then it comes down. Yeah. So if when it goes up, everyone slows down, and then after some time, we
had the same problem in a very different domain where we used Hadoop, because that also uses MapReduce. So there is this map phase which runs, and then when the reduce phase is there is a collect, and you see these like weird spikes. So there it wasn't this extreme, because why it is more extreme here is because GPUs are super expensive. That is from a commercial side, and again it is like hardware which is like very, very specific compared to MapReduce, which is like slightly more generic. And MapReduce cluster, you can run multiple different jobs to smooth it out. But here you don't, with the training, you don't have option. You have one training and there's this massive supercomputer. So it has to be in sync. There is this challenge which is very different from the from the MapReduce.
From other workloads.
But yeah, we saw these problems where, the signaling, if it is not dampened, you will have this issue where there is like, there's a burst, and then you say, hey, wait, then it will wait. So you need to have like some kind of, either exponential backoff or those kind of mechanisms to at least shift the wave in some sense.
I don't know the details of what all is being done in PFC and Ethernet layer, but the CSIG and other things which are very promising, especially CSIG, I feel it has information on like how much bandwidth is available and where the delay is, and so applications can take necessary action to sort of whatever bring it down or reduce the slow down, or all that actions can be taken. And because PFC is not that effective is where all these people are coming up with new ideas, right? The CSIG, the MRC and the RNG and all of those are kind of, because PFC is not fully solving the problem is why those are coming up. But those are still very, very new. Because CSIG, if you think of it, like every hardware has to implement that, and every switch, it has to be available, only then you can really deploy it. So PFC will stay for some time, I believe, and then slowly. If you see MRC, they are already saying we disable PFC, we don't use it.
So as far as I know, in PFC, it's about like the dampening or anything you're talking about is handled at the host layer. So the network never needs to do any action, like it's non-actionable. It's just signaling. Just like ECN, you only signal. You don't do anything. The network never does anything to control congestion. It only notifies the senders and receivers that there is congestion, you need to slow down. Like the network is congested. It doesn't tell you where it is congested, who is congested. It just tells you need to slow down. Now it's your decision to make whether how much, like if you want to slow down on 1 pause frame or on 10 pause frames. That's a decision you take. But it's... But there is some kind of distributed agreement which is not there in the... Yeah, so like Shraddha, I think, and others mentioned in their slides, these network protocols or these designs were done for older. So even today, most data centers have PFCs. And the reason why they have PFC is the standard traffic that used to come in infra, shared infra, used to work pretty well. Like it does good amount of, like Shraddha was mentioning, right? It can, like it's better to have something than leave the network just like that and suffer. I have a follow-up question on shuffle box.
So Dhruv is reminding me that there is FAN working group which is working on this exact problem. And see, all these PFC, CSIG and all, its host layer has to take some action, right? Whether its network is not taking any action. And FAN is for the network to take some action. Wherever congestion happens, there's a fast notification to the layers, network layers, the ingress switches, so that ingress switches can take some action. And network layer has knowledge about the network. It can also have knowledge about where bandwidth is available and take some action on that. So this is, it's still the beginning, but we'll have to see how this progresses.
So I had a question on the shuffle box also. It was very, very, very interesting, super interesting paper. But the one thing I was thinking is, if you connect it in this like random, seemingly random fashion, the good thing about the fat tree, though it's not proper and have these issues where everything is concentrated in one place, the failures are predictable. right? But once you go to a randomized network, you don't know how different elements will fail, how one link loss will actually have a difference. So you kind of, that problem makes, like it solves one issue, but it solves another, makes another problem little harder, which is reliability. But so that reliability statistics was very interesting, yeah.
So what the paper claims is that because they have more than one path that they can, so they have this spray point routing, right, which kind of comes up with multiple paths, not just shortest paths. And then they do load balancing on those paths. And that is what gives them more reliability, is what that paper claims. Do you have a point?
A very brief question. Does this have something to do with small world networks, why this is so efficient?
The RNG, you mean?
No, the shuffle box. Yeah, the randomization one. Yeah.
Yeah, the shuffle box itself it's just providing an easy way to do those random connections, right? So the crux of the innovation is that your networks is not connected in a regular fashion, but it is connected in randomly, and then you find paths to sort of. I'm not sure I understand what you mean by small world networks.
So small world network is this. So have you heard of 6 degrees of separation?
No.
You can reach anybody in the world by through 6 contacts on average. So when you have a it's not so strong. The thing is it has to be strong initially, and then when you have that kind of a topology, you can reach to. Basically, you want to move data from one data center to another data center quickly.
This is all within a data center.
Within a data center. This is GPU to GPU.
This is all GPU connection.
Yeah.
Principle. You want to move data between GPUs quickly.
Yeah.
You don't know which GPU you have to reach.
Yeah, yeah.
And what would be the optimized path if you don't have to calculate each time? The small world network says on average you might be able to find a path.
I think it's different because अपना जो fixed वाला है ना, उसमें भी देख number of hops are limited when we do a tree. So it's not like you're reducing the number of hops. What you're reducing is if a failure happens at the top, everything goes for a toss in one. If it is random, your failure is only a small part of the world is impacted. That's the benefit you'll get, not so much as reducing the.
I understand what he is trying to say. So the maximum number of hops that you might have to take is probably 6, but it could be still much smaller. And the concept that you're bringing in, I wasn't aware of this. I think it makes sense, you know. I don't know from where that concept comes in.
Direct communication.
No, but what he's talking about is, I think, general concept, right? That
graph theory. So
yeah.
if you do it in a factory versus if you do in a random tree, what will happen if you do?
Okay. Yeah. So yeah, I think discussions are pretty hot on AI all the time, no doubt about it. So, but well, the food is also hot. Let's have the food first, and then Dhruv will continue with the last session for what is happening in IETF and IRTF with AI. Just a note, we will start the session again at 1:40 sharp. So we have about half an hour, and the food is right here. So requesting you all to just join us for the lunch.
Everything is vegetarian. And yes, is what is going to be discussed, so that if you choose to attend those BOF, you are well prepared and are able to contribute. So let's start. I think some of this Vinayak as well covered, maybe a few points I'm sort of adding in my slides as well. I think network for AI is everything what Shraddha talked about, that various changes that we need to make in our network because of the way in which AI traffic is done, or AI training, AI inference. So how is my network evolving? The second part is, can I start using AI for running and operating my networks itself? That is, for network operations, instead of just relying on fixed rules, is there a role for LLM and AI to play in how I run networks? This actually scares a lot of operators, or some operators are like, this is crazy, one configuration mistake and we lose so much. You suddenly you have things on the net, Cloudflare, DNS, one config mistake had led to this. So if you let AI or an AI agent do this, some people totally freak out. But at the same time, you will see many people doing research in this area, and at least they are thinking how that is possible, and in which areas it makes sense, in which area it doesn't make sense. The other one, which is something that Vinayak did cover, which is the AI pref and WebBot auth, that basically now AI is using the same internet infrastructure. Are there any specific use cases from AI point of view that we need to standardize? Finally, what is the use of AI in standards itself? Like, is there something that we should be doing with respect to how we review drafts or how we come up with formal verification of our security protocol? Is there some AI use in how we develop internet standards as well? So those are the big 4 brackets, little broader than what we saw in the previous presentation. I'll sort of skip this slide because this we have already talked a lot. FAN is a brand new working group, so all the questions related to congestions, they are still starting with noting down what is the requirement and how would it look. They haven't decided anything on the protocol yet. So if you are interested in the Shraddha talk, this is the place where I would point you in the IETF. They are just starting, so you can start contributing at the early. This is not a working group which is running for a long time and already has a lot of drafts that you need to review to start participating. One part which we kind of not covered, there is already a lot of existing pieces inside IETF, especially when it comes to identity, when it comes to privacy preserving. All of those things are sort of available, not so much, they were never developed for AI agent or AI use cases, but IETF always believe if there's something that exists and if meets your requirement for AI, there's no point building a brand new thing. We can evolve our existing building blocks. And Whimsy is one of those which was written more for identity for workloads. But AI agent in some ways is a workload. And can I use the same identity mechanism that I have developed for other things also in agent concepts? OHI was more about the Apple relay stuff. Can the same thing can also be used if I ever want to do some privacy preserving techniques in AI world as well, especially if my agent actually doesn't trust your agent, but I still want to talk to you, what is the best way for me to figure that thing out? And a measurement is where the PPM comes in. The second bucket, which I think wasn't covered much in the previous one, is using AI to run networks. This is still a research problem. There's nothing that has been standardized yet. The network management research group is basically where they are focusing on this. The idea of this whole intent-based thing has always existed. This is pre-AI, stuff, but the use of LLM, use of AI, use of MCP, A2A, all of this makes sense in the NMRG part as well. Anomaly detection, for instance. Anomaly detection, for instance, is such a known problem, and of course we can all realize that LLMs and AI would be really good at figuring problems, like if I'm operating networks and there are multiple issues, multiple alarms coming at the same time, can I correlate the alarms? Can I figure out mechanisms in which this is the root cause? Rather than looking through the logs, people who have worked in networking, you remember we have gone through our logs and got confused and looking at multiple screens at the same time, trying to figure out a correlation in some ways. But if AI can help with something, and people are doing it, like there's so many times when your Linux system stops working, you just push it on the LLM and help me figure out why is this error happening. And they are pretty good at it. So same thing people want to use also in the networking side. The digital twin is a concept in which can I have a replica of my network and try to do things on that network to figure out, use AI techniques to figure out what is the impact of this. This is all research problem, but it is happening. The part which is being standardized is the smaller building block. At least can I make sure that all the data from my network is available for an AI system. And that's where the NMOP working group is trying to make sure that network telemetry can be fed into Kafka or can be much more easier for streaming and not just for the basic idea of observability of a route flap. Going more deeper into building things, getting quicker feedback from the network. The knowledge graph is again a technique which is very popular in a non-networking sense, in the web sense, like how different pieces of knowledge are related to each other. The same kind of ontology, can it be applied to network? This work has already been started. It's an informational draft. There is not much to standardize right now, but people are doing, and there are in fact products out there which claim to do this now already. So this part is also kind of important from the network management aspects, how we can use AI for managing our networks. This part I think Vinayak already covered, so I'll not go in too much detail about AI pref and webbot auth. The one part which I would like little bit differ from what Vinayak was saying with respect to AI preference, like there is when we charted the group, the history was that IAB first did a workshop, and the name that IAB chose was AI control. We really wanted to go in the direction of what Vinayak was suggesting, that yes, I need to actually say that whether this piece of data should be used for training, and it could be respected. But we realized during that conference that if you want to make progress at this moment of time, we have to go step by step, and the first step that we have to do is lay out our preference. That people who want to follow our standards, at least we give them the vocabulary that they should be able to clearly say that whether this particular piece of my website or my data should be ingested for training, whether search is okay or not. An AI search is a brand new concept in some ways, in which it's still Google, but it is giving you a search rather than a links. So where does that fit in? So there are so many problems that we wanted to solve without going into the details about how we would actually enforce it. And IETF always had this thing of we need to break the problem and solve that problem first, rather than worrying about, oh, this is not going to solve all the problems. And we all agree that that's not the case. So that's where AI pref is. And in fact, AI pref is in some ways has lots of challenges. There is not just a technical point of view, there's a legal things, there's jurisdictions. There are people saying that there is, how do we differentiate between somebody's preference between what the copyright law is saying? So there is lots of open questions that are still needs debating, and that's what this working group is right now trying to focus on. Webbot auth is idea of, if there is a crawler, I want him to crawl, I don't want, but I want to have a way to authenticate that that's the crawler that I want my data to call. And this is something which also is sort of like in some ways against the idea of open web in some ways, but we have to deal with it because the amount of crawling that is happening in the current system is increasing day by day. And the final bucket we were just talking about is pointing AI to IETF and IRTF itself. There is a research group called RASPARGI, which has been looking at, IETF has all these mailing lists going back so many years. All our data has been public, but we haven't so far done any AI analysis or try to use that data in innovative ways. So that's how it was started, that let's look at the data that we already have, and let's look at various different research or things that we can find from that data itself. Then that changed to, we still have somebody doing note-taking. Can I do AI-assisted note-taking for IETF? People are thinking about that. When I have to summarize a mailing list, can AI be used to give a summary of a thread and things like that? Where people have a huge issue, and this is we are seeing in the IETF already, that some AI agent seems to be participating in IETF, and it feels like, oh, the kind of messages that they send on the list and the frequency that they have or the time zone don't align. So these are automated agents who are listening to the mailing list and responding to people and saying, and they might have a draft that they have written, how that draft is related to a message that is coming in, and formulating a response and sending it to this thing. And as you know, an IETF, everything is just an email. We don't do any check. There is no membership. There is no nothing. So this is something that worries us as well, that this could be a DOS attack on the IETF itself, if this this whole idea of everybody just sending their agents to participate on a mailing list rather than themselves responding. Scary. AI written drafts, in fact, when there is a very old April Fool RFC written by ChatGPT, when we thought this would be a nice little joke, and now We know this is already happening, that there are AI written drafts, not just, oh, can you rephrase this, but ideas as well as this coming without any human intervention, which is very scary for IETF standard process itself. And basically, how do we have accountability for that? We have IPR rules, we have copyright rules. When AI is involved, those things are very, very problematic. So these are very open questions at IETF, and especially IETF leadership, that we need to start thinking about. Now, the main reason I wanted to talk about was all the BOFs that are there in the IETF 126. They are all 3 BOFs related to agents. I think the agents part is where most of the active interest in the IETF is. Vinayak talked about MCP and A2A, which are already working stacks in Linux Foundation. They are being used. What IETF is looking at is a questions. What are the real pieces that needs interoperability? That's are going to be multi-vendor, this thing, not just like, yes, we need to standardize this for the good of it, but yes, these are the building blocks that are problematic, and we need a standard for to solve them. And the 3 pieces that have so far come up, because there were so many side meetings, so many discussions, people talked about the grand architecture of how agents could work. There were terms like Internet of Agents, like an Internet of Things, IoT versus IOA, and various different things, like grand architectures out there. But the pieces and that are at least have good chances of being accepted. The first one was discovery. I think this is a known problem. You have an agent, we need to know where that agent is. What are that agent's capability, for instance? That is where the discovery part is coming in. That's in a BOF, which is Dawn. The third one that you see, ACP, this is basically a session protocol between agents, or agents to tool, or agents to LLM. Not the payload part, but the session. Like, how do I maintain a session in a standardized way between this, long-lived or short-lived, whatever is this, what is the best way to have a session? What is the building block that we built on it? Like right now, there is a lot of push for using media over quick, or whether it should be HTTP 3, or whether it should be HTTP 2, or whether it should be something else. At least let's get standardized on those. And then we worry about things like payload and other things that we were seeing in the previous presentation. The middle one, which is a non-working group forming BOF, and this is non-working group forming because we are still a lot of open questions around it. There's a group of people who believe that we need a concept of agent gateways. That these are the, like, agents to agents direct communication is not happening. They should happen through a gateway. They believe that that's the only way in which they can scale. They believe that because of the 6G architecture, or because of the enterprises use, it cannot be a free-for-all. We cannot have a peer-to-peer, any agent talking to any agent. There needs to be some sort of a control, and the only way I can have control is if I have these agent gateways, and who decides which agent talks to which agent. This is a very open question in IETF, that for this particular case, do we need to change our protocols, whether the session protocol and the discovery remains the same, whether there is a gateway or there isn't a gateway. So the focus would be on answering whether this is a problem worth solving. Whereas in the other two ones, of course, that's a big question, but also the question is, what are the right boundaries? What is the right charter that this working group will focus? So there will be a lot of discussion on the charter itself. So let me just quickly go over these BOFs. I think the goal of the first one, as I was saying, was the session protocol part, and that's what you see, use cases, framework. This is the main session, like how do I maintain session? Lots of discussions with respect to web transport and MOQ, things like that. The Dawn people are asking, find me an entity to talk to. And what decision that they have taken is that they don't want to tie this just to an agent. They want to say that, let's just, like, if I'm discovering things, why do we need to write a protocol which is very specific only to agent? It could be an agent, it could be a workload, it could be a service. Can I come up with a mechanism to do that? And of course, DNS is people's idea of moment they think about discovery of things. And of course, DNS is one of the protocol that they would look at. They have not committed. Even their charter doesn't say that we commit to DNS. They say DNS is the first thing that we are going to explore. And that's what they're doing. It's a good decision, because as I was earlier talking about that Lego block concept. Like sometimes what happens is there's a lot of push from an industry for a particular use case, but in IETF we like to do things which are general purpose. And we want that to be reused. With agent to agent, it is a little different because that's an application layer protocol. It's being written over a session protocol that already exists. And then you need to think about, yes, these are agents, these are LLM, these are tools. What is the right set of session maintenance that I need to do? So that is way more specific, and there is agreement. With discovery, the idea was, no, this doesn't need to be just a discovery of agent. This could be more general purpose. And DMSC, as I was just saying, the big question that they have is, do I even need this AI agent gateway? What are the use cases? What problem does it solve? And even if it isn't a problem that can be solved, do I really need a working group to do it? Or can the DAWN people and ACP people and the identity people, whoever are involved, can just do it? And this goes back to the big tussle that you see at the bottom. That so far in IETF we have a strong thing that we write our protocols for the open internet. And the big use case for AI agent is from a closed system. That is somewhere where we want to control it. We want to say that this is within my telco networks, or within how to use this within my enterprise network. And in IETF and even at IAB, and we always tussle with it. That is this something that we should be focusing our energy on, or should we limit things for the capital I internet? So this is a live tension that you might observe if you choose to attend the BOFs. And BOFs are very, very interesting. The conversations are much more flowing. It's not like a drafts presentation and this, and you're like, oh, I don't care. This, I added one more TLV, thank you. But this is basically answering a very big question of whether we as an industry, and we talked about the need for standardization in AI space. This is what these BOPs will answer. And right now, apart from WebBot auth and other smaller pieces, we haven't committed to agent work in IETF yet. So this is, that's why I'm expecting IETF 126 to be very interesting when it comes to agent work. The final slide that I have is there are still lots and lots of open questions that are unanswered. Whimsy can solve some identity, but is it the same? Do I need to think more? Authorization is extremely big, especially in the agent world, because there is level of authorization. You need to be authorized, but you should be able to revoke your authorization immediately. So you need brand new ways of thinking of authorization. It's no longer the authorization in our mind of like an AAA that we would usually do with our network services. We need to think much more scoped, much more revocable, having multiple delegations of authorization. Big problem. Discovery, we kind of commit. Auditing. So especially in this is where the governance part and the legal aspects are coming. Okay, who's going to be liable for these agents? If agent makes a mistake, whose fault it is? Is it the person who's deploying it? Is this the coder? Is it this? How am I going to figure it out? Auditing is the basis of that. That we need to have a trail of what happens, who gave the permission, who revoked the permission. Auditing is very important. And in fact, this was proposed at a BOF. It's still very early, that's why it didn't get selected, but this is a very important problem for in the agent world that needs to be solved. Observability is there, trust boundaries are always there, this thing. And the final set of slides that I have is like why it took a lot of time for us to come to this space, that there is actually BOFs, multiple BOFs being considered at IETF, because for the longest time, when the work was coming at the IETF, it was all grand architectures of how we vision that various different AI agents should come together, they should all standardize, they should all architect in this way, and IETF struggled a lot with it. So over the multiple conversations, that's how we have filtered down to these Lego blocks, these building blocks that we can agree that these are the ones that definitely need standardization. And these are the things over which we can build a lot more things. We still want to do permissionless innovation. We still want AI companies to go ahead and do things. They should not be waiting for RFCs before they are able to do that. For this, we need to figure out the right set of smaller building blocks. And that's what we have been trying to do. And that's my last slide, if I'm right. Yes. So let's take questions. Wow, no questions.
I wanted to ask if it is possible to participate in the BOF remotely.
Of course.
Yeah, it is. Because I didn't think it was possible earlier to participate in the BOF.
No, BOF is just like same meet echo, same working group session. I think, are you thinking of side meeting?
Probably, yeah, I think
so.
So
The side meetings also for a little bit, we don't use the meet echo, they use the WebEx. And side meetings, the concept is that's where the IETF leadership or IETF working group chairs don't control. These are just participants. Participants first come first, reserve a room, advertise it, and that's how lots of agent work first got started. A discussion in the IETF. We're just people getting together, bringing the idea, booking a room, and discussing it. Now even remote participation for that exists as well. Okay. BOFs are like normal meetings. You will see a BOF chairs, you will see an agenda, you will see a discussion, and very active remote participation in BOF as well.
Sorry, I missed part of the presentation, but where is the 126 happening? Like
Vienna.
what?
Vienna.
Okay.
So yes. Time zones are pretty good.
That's the reason I asked.
Yes. Remote participation, fee waivers exist, so please participate. And if you can book a ticket to Vienna, that's amazing.
Okay, I don't think there are any other questions, so maybe we can go to the next session. Okay, Vishal?
Yeah, so good afternoon all. So let's move on to the next session, right? It's a networking group. So the first speaker will be the Rahul Gupta. So he is an independent researcher currently investigating the open world and the malleable operating environments for intelligence, augmentation, and model of computation and computability theory. And an active contributor of internet standard across multiple SDOs, and he authors and contributes specification with a particular focus on a real-time notifications and internet decentralization. He currently serves as a co-chair for the Solid Practitioners Group. So, over to you, sir.
Thank you. So, hi, I'm Rahul. I'm a notifications enthusiast. You'll understand that if you come to the HTTP working group. So, okay. So I'll start from the very beginning. That's JCR Licklider. That's the reason why we are in this room. And even when he was thinking about what the internet should be, what the ARPANET should be in his first paper, they already had a concept that this is going to be a heterogeneous network. It's going to involve multiple participants that you cannot control. And fast forward 30 years, we have an internet that's grown a little bit. Now, the new hotness in that moment in time was the web. And here we have Roy Fielding, who's trying to, as a PhD student, figure out what is a good architecture for the web, what is a good architecture for hypermedia systems that are evolvable and are distributed and work at internet scale. So that is the point that I want to drive home, which is of internet scale. And internet scale has two aspects to it. One is anarchic scalability. So anarchic scalability is the idea that there is no central authority, no coordination between independent parties. You cannot expect servers to maintain knowledge of clients or the clients to keep track of session states. Data can be malformed or even malicious. And there can be, like, if there is a popular resource, there can be flash crowd. So somebody just, lots of people aggregating, such as there's a sale and lots of people come in, or IRCTC at 10 in the morning. So in these circumstances, you still need the network to keep operating in those hostile conditions, and you need mechanisms that will enhance visibility and scalability in those circumstances. The second is independent deployment. So independent deployment is that anybody can add to the network at any time. Old and new configurations will coexist. And even in that environment, the rest of the network should not get affected. So it was on the basis of these two ideas that he proposed REST. And REST it has a special relationship with HTTP, which is the canonical protocol for end user traffic. So REST was used to identify the problems. REST was used to identify problems with what was HTTP 0.9 originally. And then it was using that, a subset was identified. Excuse me. Okay, I need to see though.
Yeah, fine. Let me help you.
Yeah. Thank you. Thank you. Yeah. So it was used to create, identify the subset that was 1.0, and then it was used to actually derive the standard for 1.1. And REST is the reason why HTTP takes the form today, and has all these good properties which allowed it to scale and even after 30 years remain a useful protocol. So I'm not going to explain REST right now. I'll skip that. If you have questions, please come and talk to me later. But there is one issue, that is a lot of our traffic is real time. We need push notifications. We have applications where we are getting scores or stock tickers or collaborative documents where we need real-time traffic coming. And HTTP fundamentally is a request response protocol. So what this does is it forces those people who are creating applications to move the real-time traffic either to another protocol or to build it on top of HTTP, both of which are not very elegant solutions, as we'll just see. So the first case is you can switch protocols. But every time you switch protocols, you will walk back one of the constraints of REST, which means internet scale cannot be achieved. So you have WebSockets. WebSockets create an opaque tunnel between the end user and the origin server. As a result, intermediaries cannot help you scale that traffic. You have webhooks, which basically is saying clients become a server. And that is not feasible for lots of things. Browsers can't do it. Anything behind a NAT cannot do it. Mobiles can't do it. The third is you have all the things like WebSub, WebPush, MQTT, which all require broker or a hub in between. So you are responsible for being the intermediary. You cannot just use any element in the network to do it. The other option is to use HTTP, but the HTTP solution that has been proposed called event source, or the general technique that is server sent events, has only one media type, and that is a text-based media type, so it's not really good for binary traffic. It does not even, the browser standard does not even allow you headers, and you cannot send something like authentication information, for example. And the last problem is it's unmaintained. So I like to compare that to the Model T of the internet. You can have it in any color as long as it's black, or have it in any media type as long as it's text event stream. So the question is, can we do better? Yes, we can. So I'm proposing a new standard called Events Query. But before we go into that, I want to just give you a sense of what we are trying to build here. So we want to fetch our notifications over HTTP because already we are getting our data over HTTP. Why do you want to shift to another protocol? We want to add notifications to any resource, not just have an endpoint which will aggregate resources. You can still have endpoints, but it shouldn't be a preferred mechanism of doing things. The other is you want the notifications to be reliable and in order, because you do not want the client to be the one who has to manage. So if you change protocols, your timing might mismatch, and suddenly you have a situation where you missed a notification in between, and then you have to go back and check whether was there synchronization between the actual data you got and the notifications you had. Another thing we are trying to do is we can fetch notifications and after getting the representation, because the first thing you do is I want data, and then I want to find out how that data changes, and we want to be able to do that. The thing I pointed about one media type, HTTP allows content negotiation, so you can actually choose different, whether you're getting an HTML document or a JSON, so you choose according to your need. And the same principle can be applied here. And finally, we want intermediaries to participate because we want the protocol to work at internet scale. So what's events query? So events query uses a new HTTP method called query. So this is, you can think of query as a get with body or a post which is safe and idempotent. And in that, you send a request where you can negotiate what's the kind of, if you want a representation body, you can ask for that. And then you can ask what kind of notifications you want. We define one extra header field, which is just to send properties about the connection. I'm basically using it to define duration. And we have two response modes. You can do long polling, or you can do a streaming mode. So why we chose the query method? So unlike get has a very strict restriction that you have to send back a representation of a resource. Whereas query is more liberal, it says you can send any data that is related to a resource. Query also gives you for free an accept query header where you can, which is the media type you will use to make the query. So when you see the accept query header, you already know this resource accepts a query, and by inspecting the header value, you can see if it's the query that supports events or notifications. And the request body can be used, has a lot of space. So it's a regular HTTP body, so you can use it to send information about what kind of representation you want or what kind of notifications you want. So this is the basic discovery. So you send a head request to any resource, and if it has notifications, it will send back an accept query header, and that will say, okay, here's a format in which I can accept a query with notifications. So here's a long polling request. So you're making a query to a resource. You specify, okay, this is the content type, and you send an empty body. So the empty body is saying that I'm negotiating the media type within the headers itself. I just want one notification. Long polling means just send me a single notification as soon after you get one, or until the time that is there, which is expired or not. Duration equals to 0 in the specification defines that the duration of the connection is chosen by the server, or if you ask for a time which is in seconds, it will give you the amount of time there is connection for that time up to some maximum time, because you don't want to leave the connection open infinitely. So here's the response. So the response will come in two parts. The first would be all the headers. The headers has a special header called incremental. This is a new standard which is almost going to become an RFC. It's already in the queue. So incremental tells any intermediary server, don't hold on to this traffic, don't buffer it, just forward whatever you get. And the media type is, the content type is telling you that there's going to be a notification coming. The duration is telling you how long this connection will be kept open. If there's no notification in this time, it will close the connection without, it will end the response. It won't close the connection in after 240 seconds, for example, here. And then when a notification comes, it will just give you whatever the body of the notification is. So here's a streaming example. So in a streaming request, you have to specify in the body what kind of notifications you're looking for. Otherwise, the headers are similar to the long polling case. And here in the body, we are saying, okay, we'll accept notifications of, the events property is saying that we'll accept notifications of type event notification. And the response, again, we'll first send back headers. So in this case, the server has chosen to send a multi-part request. So multi-part is this really old standard RFC 2046, where you send multiple bodies with a separating boundary. So as soon as the traffic becomes, a notification comes, it sends a notification. And the one in teal is the notification separated by the boundary. And then after a while, say another notification comes. So it sends a notification again. And in this case, it was a delete notification. So the resource does not exist anymore. So it actually ends the stream by sending a boundary with a double dash. So this is specified again in RFC 2046. So next we'll do an example where we are sending a stream with a representation first. So the only difference from the previous case is that we also define the state property where we are saying, okay, give me the body, the representation of the resource first, and then we will send the event notifications after that. And in response, you first immediately send the headers and the body, and that is then separated by the boundaries. And then when a notification comes, you can send the notifications just like the last time. And there's a delete notification just in same case as the last time, so the stream closes. So this is really simple to implement as far as the clients go. It is still just a fetch request. Only thing is your method is changed to query, and your body is a little bit more complicated in that it has the state and events properties that you have to send to the server. And when the response comes, you basically are getting a stream of responses, and you can use a library. I have, for example, a library for splitting multi-part. So you can just send that to a splitting library, and that can give you, say, async iterator in case of JavaScript, which will split up the representation and then the notifications. So we already have two implementations of this. One is a canonical one that I had done at the beginning, which I used to push the draft. A second one, which is being used by Jamie, who works in Ericsson Research. He has used this to implement the Camara protocols. These are protocols which are used by telecommunications industry, and in particular, he was looking at how can I monitor SIM swap when people change SIMs. For example, if a phone is stolen, you can monitor through events if somebody has switched the SIM in the phone. So to engage with this work, I already have a draft on the link that is on the slide. And there is a GitHub repository where I would encourage you to open issues if you are interested. And you can always contact me on the HTTP API mailing list where this work is done. Yeah, that's it from me. Thank you.
Any question?
CoAP protocol, constrained application in IoT scenarios?
So CoAP has a similar thing called observe. Yeah, so observe method, and there is a, so Jamie has used this has two implementations where one he uses a CoAP for it and the other he uses HTTP. The point is CoAP works in your IoT or constrained environments where actually that's more useful. But if you want traffic over over normal internet and your device is on some other side of the world, you probably want to use this in that case.
Thank you.
Yeah.
Yeah, so the proxies come into the picture, so it will redirect the traffic of HTTP to the CoAP, right?
That can always.
So at that environment, is it possible to implement? Or is it
that would require some work. I think you'll need to change when you switch. The proxy would have to have some knowledge, but the idea of standardizing the traffic over events query would be that that proxy becomes a standard thing rather than the problem. For example, Santhosh had pointed out everybody is sending their own kind of notification traffic.
Okay.
So you don't want to do that. You can have a standard traffic being sent.
Okay, fine. Thanks. Anyone from the audience? So let's move on to the next. Thank you. Thank you, Rahul.
Thank you. Wait.
Okay, so just a minute.
I'll remove everything you can announce. Your shoe is there. Can you lift your shoe?
Sure.
Thank you.
Your name is right aside. Refresh that. You're not able to find select.
Wait, we'll go to this. I'm just finding the slides.
ये तो रहा है सब कुछ नंबर इसको डाउनलोड करना है ये PDF है आपका स्लाइड्स
So he uploaded. Okay, so let's move on to the next, the Sushant Ash Rao. So he is a software engineer at Microsoft, working on Azure storage and with experience on the distributed systems, operating systems, and computer networkings, along with the databases. He actively explores all part of the Linux kernel and has a strong focus on the kernel's networking subsystems. So although he is not a full-time the kernel developer, but he's routinely works on the kernel-related side projects and community efforts, with particular interest in eBPF and performance engineering, and his talk on understanding eBPF and XDP. So let's, Sushant, there's yours.
Thank you, Vishal. So I'll quickly get started with what the talk will be basically about. So it's about how to achieve high performance networking. So this networking is more on the host networking side and not on the overall network itself. So this is more on the host networking side and how to achieve near line rate packet processing. So for that, the Linux kernel folks came up with a brilliant architecture where they allowed running code in the Linux kernel itself. Like that's what essentially eBPF provides, and XDP is just a icing on the cake above eBPF. So eBPF is like the base foundation for XDP. So now coming to why eBPF, right? So basically before eBPF you could not run dynamic code in the kernel. So that's essentially what eBPF solved. Before you had to either use kernel modules or use some other techniques to be able to run any custom code in the Linux kernel. So that's essentially what eBPF has solved. So there are many advantages of why eBPF works better than any of the existing solutions. So none of them were able to provide any sort of safety mechanism from preventing the kernel entering into panic. So if you have buggy code, if you have poorly written code, then you can never have a safe kernel. Like testing the kernel would always require recompiling and a lot of such issues. Then cross version maintainability and so on. There were like a lot of issues that were there with before eBPF world. With eBPF world, we have a lot of additions that have been done. So it basically makes the Linux kernel agile. So especially after Linux kernel version 5.15, you have a lot of agility that has been built into the Linux kernel. So you're able to test, iterate, test, right? That endless SDLC can continue, and that's essentially what eBPF sets out to solve. So I think all of us know what Berkeley packet filter is. So BPF is the bare or core mechanism of what we have in terms of libpcap, right? So BPF is what actually provides you the packet captures that we all are very used to dealing with, right? So that's essentially what Berkeley packet filter provided. And for Berkeley packet filter to work, there was a existing micro VM that used to run in the kernel, and that's what essentially provided the BPF capability, like packet capturing capability. So somebody thought that why not add an E to the BPF and make it eBPF, and that's essentially the nomenclature very clearly identifies what eBPF is. So it's extended Berkeley packet filter. So you had BPF VMs running already, micro VMs in the kernel. So the simplest thing that one could do was provide an icing on the cake. So essentially what they did is they expanded the scope of the BPF VM. And today BPF VM has full capability on what are the things that it wants to run. I had a slide on that, I think, but I've hidden it for now. But when the slides are shared, you can take a look at that. But essentially what happens in the expanded BPF VM is that you will be able to, so basically before there were only, I think, 6 registers that were available, and there was no stack that was available. So in the new eBPF VM architecture, this is what has changed. So now you have 11 general purpose registers, and this is what makes the architecture extremely scalable. So you're able to run dynamic programs in the kernel using this particular micro VM. So this is essentially the register format of the eBPF VM, and how exactly it uses these registers. Like I've mentioned what the scratch registers are and what these do. If you're interested, you can discuss with me later on, but for the purpose of saving time, I'll be skipping over this. So this is essentially, and the biggest advantage is you now also have a stack pointer, and that's what is essentially stored in the R10 register. So that's basically what provides dynamic code execution in the kernel, and that is where you can leverage dynamic program execution in the Linux kernel. So now the biggest advantage eBPF has is interaction with the user space. So as we all know, any application that we write is always in the user space. So there was no way that we could look at what the kernel is doing, what the kernel is perceiving, what is happening within the kernel, within its memory, right? There was no visibility. So this is exactly what eBPF solves. eBPF provides you a way to interact with the user space application. So the kernel can have its own memory view, but you can share that memory view with the user space programs. So you can run any user space program that you want, and as long as you have a compatible eBPF program, feeding it the necessary data. Like for example, it can be how many packets have been processed, right? So if you want to push those statistics into some remote telemetry server, you can do that by using this. So the kernel by default tracks certain parameters for you. And if you want some additional tracking that you want, then you can implement an eBPF program yourself, share the statistics that you gain out of it with the user space program. Then the user space program can do whatever it wants, right? So that is the biggest advantage that eBPF provides, which is the kernel and the user space interaction. So the kernel space now can share some information with the user space, and that is exactly what is done using eBPF maps. eBPF maps are pinned kernel pages which cannot be swapped to disk, and they're based on top of the BPF file system. BPF file system is just an abstraction over the current in-memory storage. So basically none of the eBPF maps are persistent. They are purely in-memory and are purely meant for the purposes of sharing data from kernel space to user space. So that's exactly what this provides. And the data, very importantly, please note, is pinned by the kernel and allocated on kernel allocated pages only. It is just that this data, this kernel pages, can now be accessed by user space. That is the biggest distinction that one must note. So before, nobody could ever access kernel pages, but now the distinction is that user space can read and write to kernel allocated pages. But these are very restricted and very specifically designed kernel pages which will be used for storage. So this outlines what exactly the BPF file system is and what it is based on top of. So BPF file system is entirely based on top of kernel memory, and whatever we want to allocate, deallocate, everything is handled by our programs itself. So the kernel can
add any data into the BPF maps, and the user space can read and also write to the BPF map. So that is the major distinction that eBPF programs provide. So now, basically, eBPF maps, the nomenclature might be a little misrepresentation, I would say, or it's bit of a misnomer. It's not purely maps. It has all kinds of data structures that it supports. So the name map is just, a broader term that has been used, but internally it supports a lot of different data structures. So it has queue, stack, ring buffer, tries. Tries are especially what is used in, routing information that you want to store. So this is essentially what is provided in terms of the kernel's capability. So the kernel gives all of these kind of data structures. So whichever is convenient to your specific use case. So before I showed a slide where eBPF had applications across a wide spectrum of things. So it started from networking, then moved to security, then moved to monitoring, and now the scope is just expanding. There are some limitations to eBPF, but its capability is very, very vast. And that's one of the biggest advantages that eBPF has. So this is a generic overview of how the kernel processes the packet. So the Berkeley socket interface, it's named like that, but it's not exactly how it's implemented in the kernel. But this is just for a very quick overview of how exactly this is processed. So the kernel space is where the sockets start, and whatever is above, like for example today, all the application layer, HTTP, DNS, whatever you want to call it, all of them is always processed in the user space. So the socket is only provided in terms of an address family, like IPv4, IPv6, and so on. So up until the transport layer is what is implemented in the kernel. Anything beyond the transport is always implemented in user space. For example, TLS or anything else, right? It always comes into user space. So user space is what actually solves the problems for you. And kernel space is always that gives you reliability, because those are like very stringent protocols that need to be very correctly implemented and correctly enforced. So that's essentially what happens. This is a very detailed overview of how exactly the kernel processes the packet. But for a very quick reference, we just need to remember that there is a network interface card. The network interface card is managed by the kernel's driver, and from the kernel's driver, it moves to the rest of the kernel's processing stack. The reason why this diagram is very important is that XDP performs high performance, or is able to provide high performance networking capability because of its very design. So in the current receive path, right, as soon as the driver receives the packet, it immediately allocates an SK buff. SK buff is the most basic structure that is there in the kernel, which has a lot of metadata. It's a very huge data structure, but the data structure is very, very specifically designed for tracking the entire lifetime of that particular packet throughout the kernel stack. So the kernel has different layers, like from the L2 data link layer to the application layer, right? Application layer, like I mentioned before, is in the user space, but up until the transport, which is TCP or UDP, those are the ones I remember having been implemented. There are a lot of other transport protocols also that have been implemented, but aside from that, it keeps track of this entire state, which is very, very vital for the kernel's networking capability. Now, that is exactly what the XDP thing will look out to solve. So this is a generic overview of how exactly the RX path works. So the NIC gets a packet, the NIC raises a CPU interrupt, and then the packet gets handed over to the driver. And from there on, it continues processing. In the new API design, there's a distinction where it switches to poll mode right after the first packet arrives. So it sticks in the polling mode for some time, and then again the interrupt will be raised if the network interface card was not being used. So this is a very key distinction, that please note that net receive SKB is essentially where the SKB gets allocated. So the biggest cost is always the allocation of SKB. And yeah, so there is a subsystem called as TC subsystem. So the TC subsystem is what provides queue disciplines. So queue disciplines is what is used for traffic engineering, like, or traffic shaping, if you want to call it. So basically, however you want to shape your traffic, that's essentially what is provided to you in the form of queuing disciplines. So the most widely deployed queue discipline is FQCodel as of today. That's what runs on everyone's systems, including other operating systems such as Windows and Apple. So FQCodel is what is the queuing discipline implemented and used today. But there are a lot of different queuing disciplines implemented in the kernel. It's all about switching to the one that you need. But very important is that this particular queuing discipline provides you an extensive capability on shaping your traffic. So you can map to multiple queues, you can have different kinds of flows, different kinds of priorities, and so on. So there is an IETF working group which is focused on deterministic networking. So this is actually a very, very useful feature there.
the TC subsystem can be very, very beneficial in deterministic networking. And that's essentially the main use case of TC subsystem. But TC subsystem can always provide you extra, like a very high speed packet processing. It may not be to the level of XDP, which I'll get to in a moment, but even the TC subsystem and TC BPF can provide you a lot of capability in terms of traffic shaping, like scheduling of the packets, improving the packets like the packets time spent in the kernel, right? So today the biggest cost that everyone is paying is the overhead of a generic kernel. So Linux kernel is built for generic utility. It's not meant for a specific use case. So because of that, the kernel has a lot of networking components. So the easiest way is to bypass that component, and that is exactly what eBPF gives you. You're free to implement whatever you want with eBPF, and that's the biggest advantage you have here. So these are the different hooks specific to the networking stack. So specific to the networking stack, these are the specific hooks that we have. So TC ingress, TC egress, like I said, that's majorly for traffic shaping. So however you want to do. The XDP is the most important hook, and that is what gives you the maximum performance benefit. So this is a generic overview of that. So this explains what exactly does TC ingress do. So like I touched upon previously, right, there are different kinds of classes of TC. Like you have classful QDisks, you have stateful QDisks, and you have stateless QDisks. So basically the TC ingress, right? So TC ingress is having this particular TC classify function, and that's essentially where you actually run the hook of TC BPF. So TC BPF can be used, like I mentioned here, for various use cases. So you can classify the packets much earlier, like before it hits the further part of kernel. Then a lot of people do use it for DDoS protection also, although it does not give as great a capability, but it's still a lot more beneficial than your existing DDoS mechanisms. Like if you're using some other user space daemons, they will obviously pay the cost of full kernel processing. So that's the major advantage TC BPF also has in terms of DDoS protection, or any other form of protection you want to implement. And similarly, this is the TC egress hook, and this can be used for doing various improvements to the egress path. XDP, by the way, is purely for ingress. Yeah, so coming to the express data path, right? So this is the biggest advantage that we have. So here, like I have mentioned, right? So in the NAPI poll, that's where the XDP hook gets executed. So XDP is the fastest, like the name suggests, right? So XDP is express data path. So the reason why we have this express data path is to bypass entire kernel processing. So you have zero kernel processing that will happen. So the moment it hits the driver, the raw frame is handed over to you for processing. That is the benefit of this particular program. So and XDP, like I mentioned before, is based on top of eBPF. So you just execute your eBPF program at the XDP hook. That's it. That's the base framework of XDP. And the reason why it performs so well, like I mentioned, is plain simple that at XDP hook, right, we have never allocated SKB. We only have this bare minimum structure. So this is exactly what will be given to you when you run the hook. So you have nothing but the bare data and the notification of which, so if your NIC has multiple queues, it just tells you which queue you received it on and which ingress which interface you received it on. So that's all the information you get in XDP. That's it. After that, it's your headache on how you want to break open the packet and what you want to do with the packet. So that is the biggest advantage that XDP provides. So you have zero allocation overhead, and this is the starting point of kernel's execution. So kernel has not even started processing anything. It just has received the raw data, the binary format, and that is what is handed over to you. So no checksum calculations, nothing, no validations, nothing. A raw frame is directly handed over to you. And these are the actions that XDP supports. So like I mentioned, XDP is purely an ingress hook. So whenever it reaches your network interface card, that is the end of story. XDP directly allows you to run any of these actions. So you can either drop a packet right there, you can pass it to the next, like for further processing into the kernel, you can retransmit it into some other interface. That's essentially what redirect does. And abort is just, like closing the program. So basically, these are the different actions that you have supported in the XDP program, and that is one of the biggest advantages we have. So right at the time it has been received on the NIC, you're able to decide whether you want to drop the packet, you want to process the packet forward, or whatever it is, right? So this is the biggest advantage, and today's biggest DDoS mitigations are built on top of XDP. So majority of the cloud providers have XDP deployed on their edge routers, especially to protect against DDoS mechanisms.
So there are different kinds of mode of XDP. So one is the native mode, the other is the generic mode, and the third is the offload mode. So native mode is where you require driver support, in which it has to implement the XDP hook. So there has to be a way in which the driver executes the eBPF program for you. So that implies that whichever network interface card you're using, its corresponding driver needs to support this particular operation or needs to support this hook. So that is what is native mode. The other is the offload mode, where you can run your eBPF program directly on the network interface card. So there are smart NICs which have SOC underlying their hardware. So that SOC is capable of running certain programs for you, and that is the biggest advantage that smart NICs give. So you can directly offload your execution onto the smart NIC, and you can save your CPU. Similarly, there is generic mode, but this is not very performant because it runs after SKB creation. So it's equivalent to your TC ingress hook. So there is really no point of running XDP in generic mode, because it is a generic hook that's there in the kernel, and without driver support, the performance is always lost. So this is exactly what I was talking about before. So address family.
Finished. Just 2 minutes.
Yeah, okay, sure. So
2 minutes only. We don't have time. Can I take 5 minutes?
Okay. Yeah. So basically, like I mentioned before, right? So AF is what is used to represent an interface socket, rather. I'm sorry when I mentioned interface. It's essentially what's used to implement a socket. So you have AF INET, AF INET 6, and similarly the different varieties of sockets that are there. Similarly, one of it is the AF XDP. So XDP is essentially the protocol that is used to interact with this socket, and that is provided by the kernel, right? So basically in the kernel there is so basically in XDP there is a native mode called as zero copy, which means the kernel's raw frame that I was talking about before, right? The XDP MD is directly handed over to user space, and that is what is this user memory. So you can register a pre-allocated buffer where you hand over the raw packet to the user space. So from that user space, it is entirely your problem on how you want to deal with it, and that is implemented by this BPF redirect map. So I told you about XDP redirect, right? So that is exactly what this syscall is. So when you return XDP redirect, BPF redirect map will be used to redirect it to the user space memory. So this user memory is what exactly provides, your ultra fast packet processing. Flow track D is an implementation by Cloudflare where they have their flow tracking. So since it was unidirectional flow, because the return path was a direct server return in their proxy design, they implemented flow track D where they could track all their TCP flows. So that was the TCP flows as well as UDP flows. So that's where flow track D laid the fundamental implementation of XDP based like this particular zero copy XDP based flow tracking and general implementation. So this is about UMEM. So UMEM is what I was referring to as user space memory. It has 4 queues like it was shown before. And yeah, so this is an overview of how exactly the NIC receives the packet and then puts it onto the fill queue, and from the fill queue, the kernel, the user space program will dequeue from the RX queue, and from the RX queue it will move, like basically you get the packet into your user space program, and from there whatever you want to do you can do. And similarly you can directly bypass the kernel stack for egress also. So there is a TX queue and a completion queue. Completion queue is what is used to record what has been completed, but TX queue is used by the kernel to directly emit raw frames. So the TX queue can be used to directly emit raw packets. So basically entire kernel processing is bypassed with this. Yeah, I think I'll end with that.
Thank you. Thank you, Sushant. Any question from the audience? Yeah.
Hey, Sushant, one question. So how does AFXDP compare with in terms of performance against DPDK?
So it depends on what is your use case, right? So DPDK is entirely replacing your kernel with a user space program, right?
Yeah.
That's the key distinction you need to take note of. There you require extreme custom support from the driver because you're bypassing the kernel entirely. So you need a very custom implementation from that. That is number one. Number two, there is the biggest performance benefit you will get is DPDK so you have to pin your CPU on that for that particular network interface card. Like whichever is going to be consuming the, so as you know, it is poll mode, right? So you keep polling the network interface card for all the packets that have been received. So always, no matter whether you've received the packet or not, you're always running the CPU. You're always polling. That is the biggest difference. In XDP, it is event triggered. So the moment the network interface card receives, then you trigger the XDP hook. So you're never burning CPU unnecessarily on polling. That is the difference. But if you ask me the flip side of it, you have to raise interrupt for the driver to start execution.
Exactly.
So there is always, pros and cons. XDP is the mode in which you can run with kernel support itself. So without having to depend on community, I would not say community, but a third-party software outside of the kernel. So XDP is purely for local as in like kernel inbuilt functioning. So you don't have to depend on custom hardware, custom support, with respect to the network interface card or any of the other libraries. So you can run a lot of programs directly on that. So in terms of performance, there are, like I said, flips and pros and cons. You need to decide based on your use case. So if you think in the larger sense that this particular design, so with respect to SmartNICs, etc., right, this particular XDP offload is always beneficial. So you would always want to rely on this over DPDK. But there is also a way in which you can integrate AFXDP with DPDK.
Okay.
So I'll explain more on that with you, but essentially that's essentially what will happen. And DPDK, like I said, is very beneficial, but you need to decide between the pros and cons. This is fully built into the kernel.
Yeah.
So I've actually used the DPDK and was able to achieve some line rate with some SmartNICs, but I've never used XDP. So do you have any data point on with any like 1000 gigabits or 100 gigabits SmartNICs you have been able to achieve? What are the kind of performance or numbers
you achieve near line rate.
Yeah.
So you can, and what Cloudflare has recorded is, I think, 14 million packets per second, if I recall correctly.
No, I'm saying for the XDP.
Yeah, XDP only. Okay. Cloudflare has XDP implementation, not DPDK.
Okay.
So Cloudflare's implementation is based on top of XDP, and their recorded performance was 14 million packets per second.
Okay.
On that specific interface that they had. So it achieves near line rate, and also the packet scaling is very high without burning additional CPU. That's the bigger distinction you need to take note of. So you don't burn additional CPU unnecessarily. So that is the advantage you have. So if you just think in terms of line rate, you can burn 100% of your CPU and achieve line rate. The other option is this, where you don't burn CPU and still achieve line rate. So XDP gives you achieving like the attainability of near zero CPU utilization by executing over raw frames. But you should very importantly note that all the kernel protections built around your application will go away. Like kernel has a lot of protections built in terms of checksum calculations and so on. So all of it will be lost away the moment you bypass the kernel. So whenever you're choosing XDP, you have to be very mindful of why you're choosing XDP over your native kernel.
So for Cloudflare, you're mentioning Cloudflare has a hybrid DPDK plus XDP.
No, they don't have DPDK. It's purely XDP.
Purely XDP. Okay.
Okay, so thank you, Sushant. Thank you very much. Yeah. Okay, so let's move on to the next presentation.
You give the introduction, Michael.
Okay, so the next speaker is Vishal Kamath. So he is a fourth-year student pursuing computer science and engineering at National Institute of Technology, Karnataka, Surathkal, and his the research area is in the computer networks and systems. He was leading the Kosh NITK and is a volunteer of FOSS Mangalore, and he contributed many the open source project, including on the Linux kernel. So Vishal Kamath, the talk on the improvements to the FQPI. So Vishal, over to you.
Thank you, Vishal. Yeah. So today I'd like to talk about basically my experience of IETF, as well as continuing after my first IETF, and in particular improving FQPI in some aspects. So yeah, this is the agenda, but yeah, mainly I was given the opportunity to attend IETF 124 in Montreal with some colleagues of mine, and we presented our work at the CCWG, the hackathon, and hack demo happy hours. Mainly, my work was regarding testing the primary Q discipline, as Sushant had mentioned, about FQCodal versus FQPy, and I'll get into what FQPy is, on an access point we had on the IETF network, as well as my colleagues had some other work they were presenting as well. We also got the opportunity to attend multiple working groups like the, other than CCW, TSVWG, ICCRG, TCPM, etc. So we had a lot of discussions with many experienced IETFers. We received a lot of feedback on our work, improvements, etc. And so overall it was a great experience. One thing that stuck with me, obviously, was even though you may not be present on site at the IETF, you can participate remotely, and always contributing to the IETF is a help that everyone would appreciate. So that's why I've continued to try helping out, playing my part in contributing to IETF. And so one thing that we have at NITK as a group of researchers had developed is this algorithm called FQPy. Now, FQPy has two sort of meanings. One is that it's an active internet draft at the TSVWG. It's been under development, and it's been progressing through the TSVWG. For example, being adopted last December, and we continue to have updates on the internet draft, like this IETF as well. But in terms of the algorithm itself, it's an active queue management algorithm, also known as a queue discipline. It operates on the packet TX or egress path, and the purpose of FQPy, or also known as flow queue proportional integral controller enhanced, is to mitigate latency and throughput, which is usually hampered due to the large buffers that we have, just like in the software just before the NICs. So obviously, as mentioned, the default is FQCodal, and we've been running experiments to see how well FQPy performs, and we've seen that it performs pretty well, analogous to FQCodal itself. Now, I've worked on a few things, and in particular, I started on working with experiments related to FQPy. And another thing that I had worked on, this was after IETF 124, was, as Dhruv mentioned, the success of an internet draft is only greatly enhanced when you have implementations and good support for the draft. And so there were two particular network tools that I found that FQPy was missing, and so I contributed to that. And while doing this contribution, I also realized there were some improvements we could make in the Linux kernel itself, so I'll also be talking about that. Now, the experiments we've conducted regarding FQPy started as a fifth semester course assignment. We carried out tests regarding FQCodal versus FQPy on various topologies, whether it was in emulation in network namespaces or on the physical hardware like an OpenWRT router or a mobile hotspot. We were basically just trying to compare FQCodal and FQPy in those two particular metrics. We were generating traffic using Flint, which is a traffic generator specifically for these buffer bloat purposes, using tests like RUL and TCP and down. We also tested in different environments, such as on our campus network, as well as in the IETF 124 hackathon network, which I was able to do in person. And results on these were presented in IETF 123 and 124, as well as we'll be conducting experiments this IETF as well. Now, as I mentioned, after the IETF 124, I was playing around with some of the scripts I'd made for automating these tests, and I was trying to do it in the Golang language, and I realized this library, GoTC, didn't have support for FQPy, so I decided to contribute it. And so this library in particular, unlike the standard IP route 2 package or for traffic control, this networking library directly uses netlink sockets. So in order to implement support for FQPy, I had to implement the netlink API for FQPy, as well as marshal and unmarshal, basically parse the payloads that would be sent to the kernel and receive them from the kernel, and then integrate that. That's been merged last December itself. Another tool that we had found out was this tool called QoS-Mate, which is a tool specifically that you can use on OpenWRT routers to optimize performance and allow, control prioritization of specific traffic types. For example, when you have some sort of gaming traffic or low latency traffic, you would want to give some sort of prioritization to that. So this tool called QoS-Mate can be used for this. It also provides a web interface through the Lucy interface on OpenWRT routers. And I found there were several QDisks present, but of course FQPI was not there, so I decided to contribute that as well. And so this sort of implementation involved enabling FQPI on the router, and QoS-Mate involved some different sort of what should I say, setups or setups specifically for QoS-Mate, whereas which involved using Cake purely, which was probably out of scope, using HTTP along with different subclasses, using HFC, and using a hybrid QDisk as well. And so in different cases where we saw FQCodal was involved, we decided to replicate FQPI as well. Now, the interesting thing that required some thinking was in cases where FQCodal was implemented, if you want to put FQPI's parameters obviously are different from FQCodal, so we had to decide what the particular values of parameters would be, especially since we weren't necessarily using the default. So that took some thinking as well. And of course, working on JavaScript, we had to slightly change a view and introduce a new view in order to enable FQPI. It hasn't been merged yet, but we'll follow up with the QoS-Mate people. This work was presented at IETF 125, thanks to Professor Mohit. As I mentioned, while we were investigating, or while I was implementing the particularly the GoTC library, I realized going through the kernel code for FQPI and FQCodal, I realized that the particular class statistics, or what makes sense for FQCodal and FQPI, is per flow statistics. So as you know, with flow QPI or flow QCodal, you have packets being hashed into separate flow buckets. In particular, the default is 1024 buckets. And so you can have, so each of those flows has a pi or a codal AQM inside of each of them. And so you can get statistics for each of those flows. Now, the particular thing is that FQCodal had a tracking of these statistics for each of the flows, but FQPI did not. And so out of curiosity, I was like, this is interesting. We could probably try and implement it. And then it turns out that Hemendra, who's here today, had worked on this patch few years back, and so decided why not collaborate with him and try and get this feature upstreamed into the kernel. And so yeah, this sort of upstreaming this has been quite the effort. We've spent over 2 months, but it's involved basically appending these FQPI class statistics into the existing structure, and we had to make sure that we weren't breaking the user space ABI, because by which I mean, basically there was an API that was involved for FQCodal, but whereas for FQPI, there was already struct which was only specifically for the overall QDIS stats. So we had to slightly move away from the FQPI's ABI so that we can account for new class stats and QDIS stats to be introduced in the future as well. So some slight differences were there. Other than that, just enabling parsing and then calculation of the statistics as well. Currently, our patch is in the needs act state, so hopefully we will get it merged soon. As for this particular IETF, we want to continue doing our experiments. In IETF 124, we ran experiments comparing FQPI and FQCodal on an access point. This time we would like to do it on our access point as well as on a mobile hotspot and see what sort of results we're getting, as well as we've been working on some memory improvements and optimizations to FQPI. Join us at the TSVWG to get the updates on FQPI as well. But yeah, open to questions.
Yeah, so thank you, Vishal. Any question from the audience? Okay, so if you have, then you can connect with him at the tea time. Let's move on to the next presentation. So our next speaker is...
Alright, if I introduce myself?
Yeah.
I have a slide for that, so... No problem.
Okay, so he will introduce himself about that. Okay, thank you. Over to you.
Slides.
Yeah. Very good afternoon. I'm Abhyuday, and welcome to the talk on scalable simulation of quick networks using PicoQuick and NS3. So here's today's agenda. So we'll start with who I am, followed by a quick introduction of Quick, then the problem that we'll be seeing and the solution of that, followed by a brief architecture and some example results, and we'll wrap it up with Q&A. So yeah, who am I? I'm Abhyuday Hegde. I'm a third-year engineering graduate pursuing Bachelor's of Technology in Computer Science and Engineering at National Institute of Technology, Karnataka. My primary interests are computer networks and systems. And yeah, I've been working on a couple of projects under Professor Mohit, spanning from Quick to edge room to congestion control, and couple of other things. And yeah, my hobbies include watching anime and then a couple of other things, like I also like equity markets. And okay, coming back to the topic, what is Quick? Quick is, okay, doesn't have a particular full form as such. It is a UDP based transport protocol, and it has a couple of advantages, like it has built-in TLS 1.3, so you don't need extra handshakes for establishing the TLS 1.3 connection. And it also includes, like in TCP, we have the connection being made using the 4-tuple, which is the destination IP, source IP, destination port, and source port. Whereas in Quick, you have something called as connection IDs, which essentially decouples IP addresses from the rest of the path. And this enables you for connection migration, essentially the path migration, wherein let's say you have on your phone, you have mobile data as well as cellular, like you have the cellular data as well as Wi-Fi connected. So even if one of them drops, it seamlessly switches to the other without the connection actually dropping. So these things are possible in Quick only because the connection does not depend particularly on the IP address. The server recognizes the connection based on the connection ID which is there. And any data that you send through Quick, like Quick has this concept called as streams, wherein each of the stream is, you can think of it as independent data paths, like independent flows. So this, this is a major advantage, and it prevents the head of line blocking which happens in TCP. So even if one of the streams is blocked, the other streams are not affected by it. It just continues going. So there's a diagram on the bottom left side. So there, the streams have been visualized. So the 1, 2, 3, which you can see in orange, can be considered as one stream. The green is one more stream, and the blue part is the other stream. And the bottom right diagram is the percentage increase in the adoption of Quick year by year. So as you can see, it is constantly growing. And yeah, it'll be the backbone of HTTP3. So Quick would be a huge contributor to the future internet. So yeah, what is Quick is, so everything is good about Quick. So what is the current problem in it? So the thing is, as network researchers, we would want to evaluate any particular protocol on a very large scale. So you'd have to have some way of simulating Quick networks and testing it out with different bandwidths, different latencies, different routing protocols, different congestion control algorithms, and you need to have a standardized suite or a way of doing it. So now currently, what options do we have for this? So first thing that you can think of would be setting up real test beds, but it'll be expensive. Not everyone would be able to set up a test bed if you want to, let's say, simulate, if you want, let's say 100 nodes, and if you want to keep changing the links or any properties, then it wouldn't be realistic for individuals to do so. One more thing that we can think of would be emulation. So you can have containerized emulation, or you can use Linux namespaces and check out different topologies. But then one thing that you would immediately notice would be it doesn't scale well. Like let's say you want to emulate 100 or 200 nodes, then the amount of resources required would again be very large. So this brings it down to network simulators. Now, what we noticed is, on one hand, you have PicoQuick. So PicoQuick is a minimalistic C language implementation of the Quick protocol, and it adheres the RFCs that have been defined. So RFC 9000 is the most important RFC related to Quick that defines how Quick should be, and this has been implemented by Christian Hutema and is being very much actively maintained. On the other hand, you have NS3, which is again a very famous network simulator, a discrete event network simulator, and you can model any topology that you want, and it is widely used by most of the people in the industry. So these were the hints. So these were the two things that we noticed, and we thought, why not have a connection made between them? And that is what we made. We bridged the gap, and the result was the PicoQuick NS3 module that students of NITK made. Now, PicoQuick NS3 module, we are not implementing anything vastly new. It can just be thought of as a kind of a wrapper to the existing PicoQuick library which is there. So tomorrow, let's say there is some change to the Quick RFC itself, and this change has to be, now this change will be implemented in the PicoQuick library by the maintainers. So all we have to do will be just sync the upstream repository to our project, and as long as the API signatures have not been changed, it should be seamlessly integratable with the PicoQuick NS3 module. So the point what I'm telling is we wouldn't need to make any major changes, even though there is an implementation change tomorrow made in Quick. The second thing is, for the researchers or the users who are using it, it'll be a very straightforward use, because this will just be any other topology that you are creating using NS3, so it won't be anything new. So how will the output be? So you'll get a couple of outputs, like connection-wise PCAP captures and QLogs and multiple graphs. So more on output and example output in the later slides. So here's a brief overview of how this works, like the Quick NS3 module. So you have the client node and the server node. So in that, all that you'll be provided will be the Quick client app and the Quick server app. So these are the NS3 applications that will be provided. Now these can be directly installed into the node. Now each of these, each Quick client app, or let's say Quick server app, will be owning an instance of Quick transport. Now Quick transport can be thought of as the brain of the the entire server and the client. So each of one will be having one instance of Quick transport, which will be owning the NS3 UDP sockets. It will be owning the Quick context, Quick connections, and the Quick context and connections will in turn be calling the actual PicoQuick APIs. So the user would never be calling PicoQuick APIs directly. So it will be very straightforward for the user to install each of the apps. And the NS3 simulator, yes. So in certain API calls that will be made to PicoQuick, you would have to pass a time, and for that, NS3 simulator's simulated time is passed. Again, the guy who is, like the researchers would not have to worry about all of this. So all they'd have to worry about is how they'll be using Quick client app and Quick server app. Now this is a sample output format. So will be you'll be like as soon as the simulation is done, you'll be provided with the client and server side QLogs. Now what are QLogs? QLogs are logs that are specific to Quick itself, like it is Quick event-based logs, and these can be very beautifully visualized by uploading each of these to QVisualizer. Now QVisualizer is again an open source website where you can just take these logs, one server-side log, one client-side log, upload them, and then see the entire flow of the packets. As you can see over here. So each of the events can be beautifully visualized. Then, of course, you have the PCAP capture of each of the, let's say, routers, or like each of the interfaces involved in the entire topology. After that, you have a couple of trace points exposed in both the Quick server app as well as the client app, which can be used to plot a few graphs. So these are a few graphs. The blue line and red line over here represent multipaths. So there is a multipath example which is also included in the repository in the example section. So here the graphs represent, the blue path represents one of the paths, and the red color graph, red color lines represents the other path being used. So over here the graphs are like, the left side top part is cumulative bytes sent versus time, left side bottom part is throughput against time, and then you have congestion window behavior as well as the queue fullness behavior, queue occupancy behavior, yeah. So yeah, this was it about the Peacock and S3 module. So this will be one of the things that will be presenting at IETF 126 this time at Vienna. And thanks to all the contributors, all the authors, thanks to Mohit sir for his guidance, that yeah, we were able to complete the projects. This is the QR code of it. If anyone would like to view the repository, it's an open source one. Thank you. Yeah.
Yeah. So thank you, Abhyuday. So, question from the audience.
For setting the system, did you had some findings as well that you want to share? As in, like when you did the testing with Quick, did you find something that would be good for? I'm thinking from the
integration just got completed back. So now we are going to the IETF hackathon next week. So we are going to use the C4 congestion control algorithm of Christian.
Perfect.
And Christian wants to take help of this patch, and his 3 drafts are in TSPWG. Those drafts code will be now done during the hackathon.
Perfect. So it will be interesting to see how we are able to use the system to get some results, because what would be more interesting to the IETF audience is not so much as how you did it, but once you have done it, what have you?
Right.
What's
so
the
now,
information you've got?
Yeah, like simple thing as changing the congestion control algorithm is just changing a few strings, like erase cubic, just type C4, and then it'll be like straightforward, simulation of that.
Yeah, thanks.
Yep.
One interesting thing in your first graph that you mentioned about Quick adoption, and you said that it's increasing. In some ways, if you look at that graph, it's got kind of stagnant. Like it's not really you got all that increase at the start, but now we are in the stagnant phase. Do you have any thoughts on that?
The peak increase from 21 to 22 and 23 itself, like that region was because all the CDNs started adopting Quick, and so the volume became very, very huge. But then after that, it is almost 40% as of now.
And it's a wildly successful protocol. If you are seeing something at 40, and you shouldn't think, oh, it needs to keep growing. I think this is for a long time. This is.
Lars has arranged a side meeting called.
Yeah, I know. More Quick how. And one of the feedback that I kind of gave was why? Give us more for what reason? What do you want to actually achieve for this? And in IETF, there is all these conversation about, I deal with it, BGP over Quick, PSEP over Quick, NetConf over Quick. People want to do everything on Quick, but let's do it if there is an advantage of it, not we don't have to move everything on Quick for the sake of it. But very good presentation. Thank you.
Thank you. Yeah.
One more, please, Abhyuday.
One more question?
Yeah, sure.
It's okay. So this is not directly on your material, but Quick more broadly, and this is open to your team and your professor also. So I was giving a talk about satellite networks recently, and one audience member who's part of APNIC said that Quick, when deployed over satellite networks which are low, high latency and variable jitter, BBR, the congestion control algorithm, which is part of TCP, I believe, is a better fit compared to Quick. And I was not sure that there was either an apples to oranges comparison going on there, or do you guys have any heuristics on? So my understanding is from a congestion control, and if you're streaming media, lots of web images or video, which is better from satellite networks perspective, for example.
Okay.
We are going to get Starlink and maybe other in the future in India too. And secondly, Quick only requires application layer, right? User space.
Only the user space.
There is no need to be anywhere in the kernel space, correct?
As of now, yes.
Yeah. So if you could talk about both the BBR versus Quick, and again the deployability of
Sure.
BBR versus Quick.
BBR versus Quick, I'll take. Yeah,
Go ahead.
So BBR versus Quick, I think there is some confusion with that, because BBR as such is a congestion control algorithm and Quick is a protocol. Now Quick can be made to use BBR as the congestion control algorithm, Cubic as the congestion control algorithm. Now Christian Utema has his own C4 as the congestion control algorithm, and that I think we can evaluate which one suits the satellite scenario better. So that will be worth noting. Like, will BBR function better in a high latency environment, or Cubic, or C4? So, I think
so it's not just about TCP packet and window sizes.
So yeah, that's precisely what Abhyuday said. So BBR is a congestion control algorithm which you can use with TCP also.
Right.
And BBR is a congestion control algorithm that you can use with Quick as well. Okay. For example, the Uber and Dropbox, they have done BBR implementation on Quick. They didn't use TCP for BBR congestion control algorithm. So now what is the concept, what Dhruv mentioned in the morning, like Lego blocks, right? So nowadays when you speak about congestion control in IETF, you don't attach it with TCP only any further. So now Quick is an equivalent protocol for which congestion control algorithms apply. So BBR is a part of Quick if you would like to be a part of Quick, or else you can put the same congestion control algorithm in TCP. So that's a correct thing what he also pointed out. So that's the first part of the question. Second is, I'll come to the satellite part later, about the kernel. So next week, so what happens is whenever the IETF happens in July, and it is specific to July, this doesn't happen in March and November, just the week prior to the IETF week, because generally IETF in July happens usually in Europe, and the Linux NetDev community, the network stack community, they have their own conference exactly a week before IETF, so that those who are a part of the Linux community plus IETF, they can kind of go on a single trip and finish off. So I was checking the agenda of the NetDev that is starting another 2 days from now, and one person is already coming up with a Quick implementation in the Linux kernel. So he has implemented Quick in the Linux kernel, and he has written that it is ready to be pushed into the production. But now I'm waiting to listen to his talk. I'll not be, so the meeting is not in Vienna. This is in some another city in Europe, but we can remotely participate in NetDev. And I'm actually interested to see what has been the performance improvement, particularly when they have pushed it into the kernel stack. But as on now, most of the implementations of Quick have been user space. This will be the first in-kernel implementation that we are going to witness in another 2 or 3 days from now. About the satellite thing, I would encourage you to take a look at TipTop. The TipTop is a working group which is called Taking IP to Other Planets, and one internet draft has been pushed where they are actually checking Quick for the satellite communication. Exactly what you asked. I can share the link of that internet draft with you.
Thank you.
Yeah.
Okay, so let's now move on to the next in this networking stack, the presentation. Now we call the professor of those two students, Mohit P. Tahiliani. He's an associate professor at NITK, and his talk on the reducing the tool latency by optimizing the control delay queue discipline. So over to you, sir.
All right, so hello everyone. I'm Mohit. I'm presenting the work that is being currently done by one of my PhD students, Deepa, one of my alumni MTech student, Vivek, Aniket is also alumni, Arun. So these last 3 are MTech students. They were assisting us, but the major work is done by Deepa. So all credits to them for this work. The talk is about reducing tail latency by optimizing a very popular queue discipline which is called CODAL. The full form is controlled delay. A little bit about CODAL before I jump into what we are doing. So CODAL queue discipline was one of the first queue discipline that said, let us measure queue delay directly. Previous algorithms used to look at queue length and say whether the network is congested or not. But what CODAL came and said is, queue length being 10 packets or 100 packets doesn't tell you anything, because you may have a very fast outgoing link. If you have a fast link, 100 packets on a fast link is nothing. But 10 packets on a slow link can be too much. So let's directly look at queue delay, because the user perceived delay directly is measured by Q delay, how much Q delay you have. So they introduced this algorithm in 2012. The main idea of this algorithm is to minimize the impact of buffer bloat. Buffer bloat means when you have excessive buffers, and those are unmanaged buffers. So if you have way big buffers, then your Q delay is going to be significantly high. So buffer bloat was a term coined in 2011, and CODAL was a part of an effort that was done. That time there used to be a working group called AQM working group, Active Queue Management Working Group, which has been now terminated because most of the work was done between the time frame of 2013 to 2020. This algorithm is described in 8.2.8.9 and is already a part of the Linux kernel. A slightly different version of this was introduced called flow queue CODAL, wherein you have multiple queues and each queue runs its CODAL instance separately. So when a packet arrives, you look at the 5 tuples, source IP, destination IP, source port, destination port, and the protocol field, and perform a hash. And then you put it into one queue. If another packet belongs to the same flow, it will be put in the same queue. But if it belongs to a different flow, it will go into a different queue. But each queue has a CODAL instance running separately. So this is a very popular variant today. It is also standardized it also is an RFC in 8.2.9.0. So they are back to back. You can see 8.2.8.9, 8.2.9.0, both became RFCs in the single time frame. And today, most of the Linux distros are using FQ CODAL as default. So if you have an Ubuntu operating system, you can just check the default queue discipline that you use. It is FQ CODAL. CODAL is also popularly combined with yet another old queue management algorithm called BLUE, and combination of that is known as Cobalt queue discipline. And that's also implemented as a part of the CAKE framework. CAKE is Common Applications Kept Enhanced. It is deployed in home gateways. It is an OpenWRT based queue discipline. Again, CODAL is a part of that queue discipline. So these are the practical use cases where CODAL algorithm is used. Now let's take 2 minutes of time to understand how it works. I'll not go into the full depth, but without explaining this, I won't be able to tell what students have done. So CODAL has 2 phases and just 2 parameters that you need to configure. The 2 phases are called dropping phase. One is called non-dropping phase. It is very clear that in non-dropping phase, we don't drop the packet, but in dropping phase, it doesn't mean that we keep dropping all the packets. You drop the packet based on one mathematical equation, which I will show in the next slide. Not the equation number 1, but the equation number 2, which will come later. So dropping phase, you drop packets, but not all the packets. You decide upon some time interval. And non-dropping phase is very clear. You don't drop the packet, and the algorithm starts by default in the initial phase is the non-dropping phase. So you don't start the algorithm in the dropping phase. There are 2 parameters. Target means how much Q delay is acceptable to you. So that is typically configured as 5 milliseconds, but you can change it. So if you don't change anything in Ubuntu, the operating system will say 5 milliseconds of Q delay is acceptable. Beyond that, I don't want the packets to be queued. It is not a good sign because the application may face performance issues. And interval, I'll explain about it later, but the default value is 100 milliseconds based on a rough assumption that the internet RTT is typically around 100 to 150 milliseconds. So the authors have chosen that value. In non-dropping phase, what we do is we calculate the queue delay for every packet that is outgoing, not the incoming packet. When you dequeue a packet, you run the equation called the current time at the dequeue and the time when it was enqueued. So when the packet is enqueued, you put a timestamp on the packet and you use that timestamp during dequeue to get the current queue delay. Now you see whether this current queue delay is more than what you can accept. So if it is more than 5 milliseconds, don't jump into the dropping phase. It could be a temporary burst. So allow the burst to pass by and don't overreact by directly going from non-dropping phase to dropping phase. So how much time do you should wait for the burst is defined by interval. So what you do is when you see that the current queue delay has become more than target, you start a timer and wait for 100 milliseconds. For entire 100 milliseconds, if all the other packets have a queue delay greater than target, then this is not a temporary congestion. This is a long-lasting congestion. You need to move from non-dropping phase to the dropping phase and then start selectively dropping the packet. So this is exactly what I have written here. And by the time when you are waiting for 100 milliseconds, even if one packet got a queue delay less than target, then it was potentially a temporary congestion. You don't need to react. You better stay back in non-dropping phase. A very simple algorithm. But now once you enter the dropping phase, what do you do? Once you enter the dropping phase, first of all, drop the outgoing packet. And now every packet that you drop has a counter. Initially, this counter is 0. Now you dropped one packet, so count became 1. And I mentioned to you that in dropping phase, you don't drop every packet. Then how do I drop the packet? Wait, you just now dropped one packet. Now you will calculate when should be the next drop. So how do you calculate that is given by equation 2. The next drop time will be, of course, later than the current time. So current time plus interval divided by count. Now let's do a simple math. I just dropped the first packet, so count is 1. Square root of 1 is 1, interval is 100. That means I dropped one packet now. The next packet drop will be after 100 millisecond. One more packet drop will be after 100 divided by square root of 2, then square root of 3, and that is how eventually Codal keeps dropping the packets. It becomes aggressive if you continue to remain in the dropping phase. That means if congestion is still not going below 5 millisecond, then you will become very aggressive. The time gap between the packets will keep reducing. And eventually a time might come that you will drop almost every packet because the sender is not responding to your congestion signal. Now, there was a fundamental problem that we identified in this. Deepa found out. She asked the question, why is it square root? From where did it come? And when she started tracing the genesis of this, we identified that this comes from Matt Mathis' macroscopic behavior of TCP paper of 1998, which was tied up very closely with algorithm called Reno congestion control algorithm. The fundamental TCP of 1980s and 1990. This square root genesis has from there. Now today, Reno is not existent, almost. Very few places are using Reno. Every operating system so Linux moved to using cubic in 2007. I think Microsoft and Apple followed after that, and around 2004, by 2018, which is 8 years before, almost all operating systems have moved to cubic, including Android. But Codal still continues to use this equation based on Reno. So all that she did was put a cube here and put a fourth root here. That's it. And how did she get the value? So now you will read in the updated equation, count to the power 3, and here is a fourth root. And how did she get that number? She just mapped it to cubic. She removed Reno assumption and she said, no, everybody is using cubic. Everything else in the algorithm is exactly the same. There's not even one line that she has updated. The entire source code that she has written is hardly 6 lines in Linux kernel and about same in NS3. Before I go there, just wanted to show you a simple example of what happens. So assume that your current time is 1000 and you just dropped one packet. So your next drop time will be 1100 because current time is 1000, interval divided by square root of 1 according to the previous equation, it becomes 1100. Now second packet drop will be 1100 plus 100 divided by square root, which is 71. So next packet drop will be 1171. So if you see the drop time, the first drop was at 1000. The gap between these two is 100. The gap between this and this is 71. The gap between the other two is even lesser, even lesser. We identified that since all operating systems are using cubic, but Codal is following this drop pattern, Codal is unable to manage the queue delay to what it should have been managing. That means it is not able to control the queue delay in the range that it was expected to control. And after we changed just that simple particular equation, you can see the difference here. So first basic test we did is, we just put number of TCP flows, all are cubic, 1 flow to 50 flows, and you can see the improvement in the updated algorithm as to how much queuing delay has been impacted by just a tiny little equation adjustment. After that, we said, okay, we should not jump on the conclusion that it is all going to work fine. So we said, okay, let us plot how are the packets getting dropped. So you can see here, the uniformity that you see in the packet drop pattern with Codal++. With the old Codal, you can see it took a lot of time to bring the queue under control, whereas this one brought the queue under control very fast. Another way to visualize is the tail latency. Tail latency means when 20-30 TCP flows start simultaneously. This is the peak latency of 400 in the beginning with Codal, and you can see we brought it down by about 100 milliseconds by just making one math equation. And this is again the queue delay in millisecond. After this, we went on to do very rigorous work. So we took up NS3 and we took up Nest. NS3 is a pure simulation. Nest is Linux network namespace build tool which our college has developed from last 6 years. It's openly available in GPL v2. We did experiment with Codal. We also did experiment with FQ Codal. We plotted the 99th percentile. We plotted 95th percentile and median. And particularly when you use aggressive algorithms like UDP, you see a significant improvement in Codal++, because Codal++ does not operate with so much time gap what Codal operates. So it reacts faster to the sender's behavior. And this is the way improvements we got with NEST and NS3. So we did pure simulation, then we did emulation. Then we reached out to a company called Quantum Networks. They are Make in India brand. They have their, so they don't do anything related to quantum. First thing first. So don't go into that quantum. What Nalini told today, the name is somehow quantum. I don't know why. They are, you can think of them as equivalents of Cisco's and Juniper or Tejas Network that do the access point or switch manufacturing, right? So they gave us their access point, which is QNI 270, which is one of their very popular access point deployed in many popular places in India. Cannot name it because of confidentiality, but many colleges, many top hotels, 5-star, 7-star they have. So they gave me this model and we deployed our algorithm on OpenWRT. So it's an OpenWRT based device. So we just went and changed because of a very tiny deployment complexity. So we did it and we reproduced the results with Codal, Codal++, FQ Codal and FQ Codal++, and we everywhere saw notable improvement. So then I told, so by the way, how did we run the test in access points? We used the Flint tool, which Vishal was mentioning in the presentation. It's called Flexible Network Tester. It has a benchmarked test called RRule, which is called real-time response under load. That means you want to see when the network is highly loaded, how is your response to the real-time traffic. And if you want to know how this test is developed, it is not by us, it is by the buffer bloat community. Here is a spec, the specification of that. At a high level, it runs RTT measurements using ICMP ping and UDP round trip time measurement and loads up the network with 8 TCP streams, 4 downloads and 4 upload. But there is much more to this if you go into the spec. This is very high level information that I have given. So once we got all these results, now we have also submitted a paper because she's a PhD student. She needs to, as a rule of the university, she needs to write paper. So we have submitted a paper, but more importantly, we are now making a 0-0 draft of this to submit it to IETF. And I'm confused because it's a very tiny change. You can see it's just a square root of count is replaced by count cubes 4th root. And we don't know whether it should be a separate internet draft, or one important thing is RFC 8289 of Codal is an experimental RFC. It's not a standards track. So sometimes what happens is experimental RFCs go on to become standard, and maybe I can start a new effort at IETF to make Codal as a standard and say that when you make a standard, remove square root of count and put it as a count cube 4th root rather than having a separate RFC written only for proposing this change. So this confusion is there, but then Dhruv is there, and I'll talk to other people and find out what I have to do. Thanks to the IIESoc community for mentoring us, but that was the presentation. If I have any questions, you can tell me any questions. Yeah.
So Mohit, this change in equation, it seems it's tied to the algorithm. And if you were to use a different algorithm, you'd probably see another change in the equation. So do you have some thought of some kind of a general formulation for this?
To Sudhir's question that he asked, so we said BBR, right? So what I did not present, but we have the results in the paper, is we have run it with BBR also. So BBR congestion control is totally different than cubic, but still so we have gone with the most dominant one. And generalizing this is not so easy, the Codal equation, because the original design of Codal itself is totally assuming that you have TCP on the other side.
Right.
Not even UDP. So my previous research, I have shown that the original Codal, which you can see I have tried indirectly hinting here also, I have shown in the past research in one of the papers that if you use Codal with UDP, Codal as an algorithm doesn't do well at all. It's not able to control the latency.
Okay.
But I didn't have a solution at that time. Now Codal++, although is not oriented towards UDP, just because it is more aggressive, it is giving very good performance. S5 here is UDP. And you can see all S5s are very high with Codal. You can see 45, you can see 862, you can see 997. These are all UDP. And even though it is tailored to cubic, because cubic is a dominant protocol, it is performing relatively much better than original Codal. To confirm that we don't become too rigid in our design, we ran all BBR experiments also, but BBR version 1. Version 3 is already out in IETF now. So BBR version 1 is available in the kernel, and V2, they have anyways discarded, V3 is coming up. So we'll wait again and test this algorithm against BBR V3, because many services and many applications are starting to use V3. Another thing that we have not tested is with Quick, but observations wouldn't significantly change, because this is a interaction between a congestion control algorithm and a queue management algorithm. It shouldn't UDP, and you don't need to do anything to Pi. Pi is immune to having an unresponsive sender. Codal is not. Codal needs separate design for being immune to unresponsive sender. But now, I work with the buffer blower community at large, and it's not about pushing only FQPy in the community. I saw a tiny bug, and now where is this used? So this is used in Cake. Codal is used in Cake. So if you look at LibreQoS, they have 1,000 ISPs in the world, and 1,000 ISPs are actually migrating to Codal very fast because of LibreQoS. So this is an encouragement to them that with such a tiny equation change, you can get good improvement in the latency. But I'm also trying to push FQPy. FQPy is under real testing right now in Pune in one place. So I would say if we want TCP congestion control agnostic, sender agnostic AQM mechanism, I would lean towards Pi. Pi is from RFC 8033 Cisco's algorithm. We made FQPy. Codal, I don't think we can make it totally independent. So that's why we chose, it was a choice about which congestion control algorithm would you prefer, and we preferred Cubic because still dominant is Cubic. But we did run with PBR V1, and results are way better with Codal and Codal++.
Thank you.
Okay, I think we overshot the time.
Yeah, so let's...
T is there.
Just have a discussion during tea, it would be good. Or you want to ask question? One question you can take?
I can discuss with him later on. We can, I mean, we can start having
tea.
Cup
So
of
let's
tea.
have
I'll have a
break,
discussion.
and then 4 o'clock we will start the last sessions.
So let's start our last leg, 3 presentations. First we have Swami. Swami is a director of product line management in Nokia with around 28 years of experience, and he's responsible for network automation solution, focusing on transport slicing and IP optical. And today he's be talking to us about IP over DWDM and how the coherent digital pluggables are changing the game.
Thank you, Dhruv. This goes up, right? Okay, thank you. Before I start this, right, this is something that I told to some of the people. I started my career 30 years back, and my first office was just a block away from here, right? And yeah, long memories, and I just kind of went back in time when I got there, right? Okay, so my topic is a bit of how IP over WDM is evolving. I expect that big part of the presentation would be on it's like going to be like an introductory topic for many of you. It'll be more presentation on what's happening in the industry. And as I was assembling my presentation, I was thinking of, what should I put as why this is being done, right? And then I saw the people who are presenting before me. Then I realized that everybody is already going to present why we are doing this, right? People talked about AI. There was, networks for AI, AI for networks, AI for users, data center networking, right? All of that is, very interesting. Very nice, technology evolution. Most important point in that is that whether the network is something that is closer to the user, whether the network is something in the data center, in the core, wherever you have, just by having AI applications, AI training, AI inferencing, there is more data that is being transmitted across the network, right? And because of that, network operators, whether they are, your telecom operators, your ISPs, whoever they are, they need to keep adding more capacity into the network, right? And when you add capacity in the network, it brings with it, you need to add new equipment, you need to build the whole protocol stack, and you need to take equipment to where you can put them, right? I mean, ideally, if I have a data center in a place, I want to expand it, I want more space in the data center to put them, right? You don't get that, right? Because the places where buildings are built, there are other buildings on the side, right? Nobody is going to just say, hey, my data center is going to expand, right? I'm going to, just demolish the building. They'll say, oh, next plot is available, you go to Tumkur, you can put there, right? I'll give you land and, figure out water, right? So you will, because of the additional network needs, you have no clue right now on where your network expansion is going to happen. And once you do that, then, how you put them, how much power you need, how much compute you're going to put there, it's a cost for people who are running the networks, right? And in that space, the operators of networks are looking at how they can manage the cost of building it. And the technology that I'm going to present here, kind of helps them in managing the cost, right? Okay, so the figure on the right is what we have as a transport layer stack today, right? So what you have is that there is an IP router, right? And the IP router, generates your layer 2 traffic, right? There's a layer 3 above, there's a whole lot of protocol stacks that, everyone spoke about. It brings in the Ethernet traffic that gets sent to a transponder, right? And transponder is a component that does the optical to electrical conversion. So all the data that comes in is put into a particular wavelength, and that is then sent through a DWDM line system to be routed to go from one place to another, right? That one place to another could be between different cities, it could be different continents, or it could be between a GPU and a server, which are either in the same data center, or it could be in a data center that is there across the city, right? So this is the traditional stack, right? Now, with the evolution, there is a technology which is called as a coherent DWDM pluggable. What it does is that it moves the function that does the electrical to optical conversion and puts it into a router, right? And what that component does is then it sends the wavelength directly into the DWDM line system, right? Why is this very powerful? It's collapsing the layer, right? And when you do that, you get benefits in space and you get benefits in power consumption, right? And that is a very compelling advantage that nobody can deny, right? And someone who has tried this out, they said that they got 95% gain, cost and power, okay? So depends, right? But this is something that's compelling, right? Now, what I did was I put the previous diagram in a way, way our mind visualizes the network, right? Because we understand end-to-end, right? So on the top is what we have as a traditional network that exists today, right? This is something that's probably there in almost all networks, right? So I have a router, right? That router has a plug, an Ethernet plug, right? That connects to another Ethernet plug, right? So if I have multiple, right, if I need to have more capacity, I will have many of them. These plugs go here. Now I have a transponder. What it does is that it takes the bits that come in, and then it does the electrical to optical conversion, and then it puts it on a wavelength, and then the wavelength is sent, and then you have the demultiplexing and optical to electrical conversion on that day, right? So if you look at the actual hardware components, right, I have 1, 2, 3 on one side. Right? Now, when I move to coherent optics, right, what I have is I have a router, right, and I have a plug, right, and I'm just using the term ZR here, right, because I'll come to what ZR is. So the coherent here implies that it's a wavelength that it goes on, and that wavelength can fit in a particular envelope that is kind of published, right, and it's set across, right. So you are getting rid of the transponder, and you are getting rid of the pair of plugs that you are connecting from router to the transponder, and the entire thing is replaced by this, right? Now, the term that is used typically in the industry is ZR, right? Now, the ZR comes as an evolution of reach, right? There used to be something which was called as DR, FR, LR stood for long range, ER stood for extended long range, and Z stood for I don't know what, zillion, right? Now, in the industry parlance, DR is 500 meters, FR is 2 kilometers, long range is 10, ER is 40 kilometers and 40 plus, right? So what this implies is that the fiber can go greater than 40 kilometer distance, right? 40 kilometer does not seem a very long distance, right? For a country like India, you're looking at hundreds and thousands of kilometers, right? But think of someone who is running a data center, right? And that data center operator does not have a single building, right? He has multiple buildings, right? The distances between buildings could be, 5, 10 kilometers, right? It could be like in a campus. Then that fits in, right? Single fiber, it's able to take everything put together, right? So it's very compelling, right? Again, like the benefit is the cost savings in terms of the equipment that you're going to buy and the power that you need to put in and the space it occupies, right? So most vendors have this solution with a brand name. I am from Nokia, so we call it coherent routing. Cisco calls it as routed optical network. I should have put HPE, but in my mind is Juniper, right? Juniper calls it Cora, and I searched for it. I could not find a Huawei brand name, but maybe it's there. But the point is that from a vendor space, they understand the benefit of the technology, and it's branded and it's being positioned, right? There are pitfalls too, right? there are things that one needs to take care, right? So how does it look, right? What I did is I took a photograph of how the plug looks. It's this big, right? Slightly bigger than this. Now within this plug, right? This is going to take from the backplane or from the router card. It takes the raw byte stream and then it emits out a photonic laser, right? So inside that, it actually has three, components, right? So it has a tunable laser with a local oscillator, right? So because it's a tunable laser, right, you can go and say that, you need to use this particular frequency and start working on that, right? And it has a coherent, a DSP, a chipset, which takes care of your error correction and everything that you need to manage on a communication stack, right? So you need to have error correction built in. There are standards on that, right? And for people who are kind of familiar with the communications 101 that you would have learned in that, right? There is a Shannon-Nyquist algorithm that determines, right, depending on the noise that you have in a channel, what bit rate you can transfer it, right? And that is basic, channel communication, and whatever is the principle behind that, all of that would be kind of covered by the chipsets that's there, right? And there is a photonic integration, and the density form factor is industry standard, which is called as the QSFP double density or an OSFP plug, right? So that's something that's specified. The other thing is that the whatever plugs that you are going to put in the hardware, it will have a specific wattage rating that you can handle. It cannot be, it cannot be more than 10 watts around, right? So around 15 watts it can do, but typically it can be around 10 watts to do that, right? So this is, from a hardware perspective, what this plug brings in, right? So the way that plug works, it's 5 steps, let's say, right? Or actually 4, but it's something similar there, right? So at the first step, right, from the router, you would have your layer 3 routing functionality, all your protocols, right? It processes through them, right? And you have an Ethernet client in which the entire Ethernet frame comes in, right? That passes through the DSP, right? And there is a specific modulation scheme that is applied. So there is a standard which is called as 16 quadrature amplitude modulation. This is the basic for a standard which is called as ZR, right? And then tunable wavelength, one wavelength, in the C-band. And then you have a line system which can be ROADM, which can be EDFA, it can be Raman. These are standard deployments, right? And depending on the type of medium you have, you can go from 50 kilometers to 3,000 kilometers, right? That's possible, right? And then you have the reverse on the far end, right? This is there. Now, there is a limiting factor in what you can do, right? And that's the DSP processing, right? So all the packets transmission, right, has to happen within the frame that you allow in that wavelength, right? So there is a limit on the width of the wavelength that you can put in. So if I need to make sure that whatever data stream is going to fit into that, my DSP has to run hard. And if your DSP run hard, then it's going to generate heat. And if you want to transmit the wavelength to a longer distance, then you need to have a laser that shoots longer. And if you have more power on the laser, it is going to generate heat, right? The limiting factor for how much you can pack in has got nothing to do with the power or the rate at which you can transmit. It's got to do with how you are able to manage the heat that gets generated, right? Whether your system has a mechanical design of heat flow and heat sink, or whether you are having liquid cooling, right? So that determines, how viable your solution is, right? Can liquid cooling help? Yes. Is it going to make the solution very expensive? Absolutely, right? So what application you are using, what cooling technology you are using, that determines whether this solution is viable or not. Some vendors have cracked it, right? Typically, I don't see that there is a huge difference in capability amongst the vendors, right? It's the same chipset, it's the same algorithm, it's the same form factor, right? So a card, this is this big, it's able to have something like 20 to 25 ports, 400 gig each, going to 400 kilometer distance. Okay. Okay, so this is a kind of, the difference between coherent versus gray optics, right? In the legacy or gray optics, right, the data was encoded on or off, right? So one pulse meant one bit. It's either on or off. While in coherent optics, you actually have a modulation scheme which uses the state of polarization to do the multiplexing. So the standard one for a 400 gig wavelength is actually, which is 16 QAM, which sends the signals at 60 gigabaud rate. Now with 16 QAM, you're able to get 400 there, right? And then there are specific DSP recovery mechanisms to boot the optical signal to noise ratio. And with this, you are able to go, even 100 kilometers distance, 100, 120 kilometers without needing to re-amplify your signal. Now, when industry talks of ZR, it's, the 400 ZR, the entity that has standardized it is Optical Integration Forum, or OIF, and this takes you to 80 to 120 kilometers distance, and there are very specific client rates that's fit in, right? And in this case, what they do is that the OIF actually calls all the vendors, they do the interop, and they give you a certification that it works. Right? So in this case, you can do a complete mix and match of components from any vendor. You put it together, it would work. Right? Now, what happened was there were people who wanted to try out other modulation schemes, and using the other modulation schemes to push the distance and the reach to a longer way, right? So they played around with the modulation scheme, right? So they went with QPSK and 8QAM, and there were people who also used something which is called as probabilistic constellation shaping, PCS, which takes the distance to even further longer. Now, the others are not standardized, right? They are at best what can be called as a multi-source agreement. Multi-source agreement are like, two people just get together, hey, let's interop. Okay, so now we have interop, and we will claim that, you can work, your component and my component can work. There is nobody like an OIF who has said that, it is certified and it would work, right? So typically, the other standards, right, they work only if you source all the equipment from the same vendor, right? It may work for some people, right? If you buy all the components and everything from the same vendor, you can go, for longer distances with the same cost and with the same profile. So then, the other factor for trade-off is how much data you can transmit and how much distance you can transmit, and you can trade off between them, right? So the way you trade off is by changing the modulation scheme, right? QPSK will get you 4 states, right? So your phase can be in one of the 4 states. So if you take the 4 states and encode them, you will get 2 bits, 0, 0, 0, 1, 1, 0, 1, 2, right? So 2 bits per that, right? With this, you can go a very long distance, right? When you go to 8QAM, you get 3 bits because your symbol can be in 8 different states, and you get 3 bits. And when you go to 16QAM, you get 4 bits, right? So with the same frequency, with same optics, you get either 2x, 3x, or 4x the rate, right? So what it implies is that by changing the modulation scheme, I can run my plug either in a 400 gig mode, or in a 300 gig mode, or in a 200 gig mode, while the 400 can go, say, 100 kilometers, the 200 can go 1,000 kilometers, right? So how you do this depends on how you are going to design your network, right? Everything else remains the same, right? This is, very powerful, right? It's a small piece of plug that you can configure and make it work. Which brings, if I do this, why do I still need an optical line system? There were people who said, hey, routers can do everything. Can we knock the optical completely off? Routers will talk to routers directly, right? The line systems are still important, right? That's the point I wanted to do, right? What it does is that the line systems actually provide the amplification when, let's say, you are able to go up to 80 kilometers, and if you want to go from there to, say, 150, you need to have an amplifier that will, take your signal and amplify and put there. That amplifier comes as a part of an optical line system. The optical line system comes with a multiplexing and demultiplexing, where you can take multiple wavelengths, put it in one, and send it out in a single fiber, right? You can use EDFA and Raman to go very long distances, like continental distances, like 1,000, 2,000, 3,000 kilometers, you can do that, right? So the line system is still needed. It's just that, only the optical to electrical conversion has moved to the routers, right? Now, when this happens, there is a bit of a confusion on whether now when you collapse the layers, does it appear as a single network or whether it's still two separate networks, right? And there is, okay, so before I go there, no, that's second part of that, right? So in all of this, right, there are multiple standards organizations that are trying to standardize the functions, right? So OIF is trying to make implementation agreements and make sure that all the products that you put together work together, right? The Open ROADM is saying that, no, I'm going to make my own standards and my standards are the best ones and you should follow this. Then you have something which is called as OpenZR Plus, which is not a standards organization. You just put a plus. It is just an MSA. It is just two vendors talking to each other and saying that we are compatible, we will go with this, right? And then there is something which is called as CMIS, right? Now CMIS works with OpenConfig, and CMIS is essentially kind of an interface that works between the plugs and the router, right? It's an interface that specifies how your electrical signals and how your buffers and how your registers will work together, right? So there is a plethora of standardization organization who's claiming that, you know, our solution is the best and please deploy that, because it's a new technology, right? Everyone wants to put their hat in, right? So it got very complex, right? When this technology got introduced, it got so complex. The Telecom Infra project, which is essentially an organization of operators, right? What they did was in 2021, I think, they came with a white paper that published an architecture that said, when you are having a network that's built of pluggables and line system and routers, we are going to come up with a way of managing this network, because we would like to keep how you are going to manage them separate, how you are going to orchestrate them, right? So the summary of the white paper I've put in this slide, right? What this white paper said is that, okay, pluggables that are there in the routers, since it's part of the router, it has to be managed by an IP domain controller, because for an equipment you can have only one controller. So you do this, and you use OpenConfig as a standard, and between the router and the pluggable you keep CMIS, right? Now this definition itself had a problem, because OpenConfig had less attributes compared to what CMIS was having. So even as they were defining it, that they realized there is a problem and they stated that, right? So that's one, and then they said, okay, you can have OpenConfig GNMI, whatever is open standard, you pass it straight away to the hierarchical controller. Then they said hierarchical controller should talk to the optical domain controller, and the optical domain controller should use netconf TAPI2 to manage the line system, right? Because this is architecturally very nice, very clean, keep it separate. They just came with two options. In one option, they said everything is, completely separate. In second option, they said, as an exception, optical controller can read the state information and telemetry from the router. Maybe for troubleshooting, you may need some information, make it read only, right? That's what they said, right? And actually, this is the only place until IETF came in the picture where they looked at the entire picture. Today, this is the kind of only reference, where they have looked at it. This was published entirely by operators. It is an operator vision. Vendors did not participate in this. Nobody, talked about, the pros and cons of how it can be done, right? Now, what happened? The technology keeps evolving, right? So somebody said, hey, I have come up with alternative ways of managing this, right? One thought was, which is the host-based control, which kind of aligns with what the OIF tip mantra paper said, which is, everything packet domain owns the plug. I mean, essentially that's what it says, right? Plug is attached to the router. If it is attached to the router, the packet domain should manage this. And it has come with a set of functionality that is there. And if you see that there is a IETF draft that kind of describes this is how it should be done. Okay, I've just listed it out. You can go read that, but that's a summary. The summary is that because the plug belongs to the router, it should be managed as a part of router, and the packet controller should take care of it. Right. The other one is a competing vision, which says the plug is doing an optical function. The optical controller should manage this, right? And there is a draft that presents this, right? And it says that if the optical controller has the visibility of the plug, it can do a whole lot of functions, planning and setting things up very easily, and this should be there, right? These are competing visions. 2 IETFs back, there was a great debate on this, and as in anything in IETF, right, we could not achieve consensus, right? So the debate still goes on, right? I'm hoping that at some point in time we will all get together and we will agree on that, or maybe we don't agree on that, but the work is still going on there, right? So this is all the work that is related to that, right? So there is work in the CCAMP working group, right, which for all intents and purposes takes care of everything that's optical, right? So in terms of what the functionality that gets covered in the entire solution, managing the line system, managing the interfaces is all covered in multiple drafts here. There is one draft in the working group which is managing the coherent plugs, right? It's still work in progress. There is a reason, even though this is an individual draft, I still put it out because it is a competing vision, and I think that we should still, give justice to that, right? So please read that, because this kind of competes with the vision that's there, right? And the TEAS working group is actually looking at the complete end-to-end management solution as a part of the ACTN architecture, right? And within that, there are 3 drafts, okay? One is on how the ACTN principles can be applied to the packet optical integration. It's looking at the applicability. There is one on what are the use cases that needs to be covered as a part of the whole solution, right? And then there is one on assurance. The assurance is very generic, not specific to the pluggables, but this is important, right? So all these drafts cover parts of the IP and optical integrated solution. There's a lot of work that's going on. I did not want to present what these drafts are saying, right? I mean, if you're interested, please, my presentation will be there. It will be available. Please go and see them, right? So this is my final slide, right? What I would say is that the using plugs, the coherent plugs for setting up the networks has a very compelling scenario, right? It provides cost and power advantage that is really unmatched, right? It's just that, there is some amount of watch outs that you have to do. And if I look at that, the biggest problem I would say is the organization, right? This is something that I think as an industry, we have not managed to get out yet, right? I'm hoping that as the networks evolve, right, the IP and the optical teams, kind of converge on how they use the tools and how they understand each other. But this is still a big challenge, right? So there is an organization and a cultural and a mindset gap. There are things on power and interoperability that needs to be considered. But, we have a lot of work on standardization there, right? I mean, I don't even know today which of the standards will be helpful and which will not, right? I'm joining in all the discussions, right? Sometimes back to back, and one will say one, the other will say the opposite, and then I'm confused, right? But it's there, right? It's deployable, and the people who are completely not bothered by standards are your Googles and Apples of the world, right, and Amazons. They have actually built this, right, for them, for the amount of data centers that they have deployed, right. If there is some technology that's going to give them 30-40% advantage, right, in cost, they take it, right. It's just that they have not published what they have done, right, and probably they have they have a different vision, right, that this is something for operators and vendors and system integrators on how to take that, right. So this is my little bit of show and tell, right. Thanks for listening. I know it's a kind of a tangential topic to what we have been discussing in the morning, but I hope this was useful. Any questions?
Thanks. Any questions for Swami? Yes, please go ahead.
So is there any discussion on the restoration part? Because in multi-layer networks, that is a big issue, that you have optical layer that detects its own faults, and it can also take a alternative wavelength or alternative port. At the higher layer, you have again a restoration mechanism. With this now it is very simple, because I see only 2 layers, but then there are a lot of channels, modulator, demodulator, many more components. And in the controller architecture, I felt that is the one of the advantage of that SDN architecture, where you can still do a central control and do a one restoration action. But after that slide, again you showed there are host-based control and then domain-based control.
I know.
So I was just wondering, is there a discussion on the standards for restoration, how it should be done?
Okay, so I see 3 questions in what you asked, right? So let me answer one by one, right? As of today, the existing standards protocols don't cover multi-layer restoration, okay? The restoration is still layer by layer, in the sense that when there is a failure, let's say in one of the links, the optical network will detect the failure and it will react based on whatever policies it are there, and the router, the layer 3 layer, will detect based on that, right? So the layer 3 will be based on typically based on BFD, and the optical will be based on detecting the loss of signal and taking whatever actions are there. You may or may not have control plane, so it works, right? If you have a good network design would know that I already have protection in the optical layer, hence I don't need to protect in layer 3 or vice versa.
Like the Sonnet.
Like Sonnet.
Yeah.
No, Sonnet is slightly different. In Sonnet, there was a protocol that did this. In IP over WDM, there is no protocol that does that, right? So that's as of now, right? I mean, in I don't know, 10 years back, there was something which was called as a GMPLS. You and I, some vendors collaborated. We thought we had a good idea, but it didn't go anywhere. Maybe there are a few deployments, it didn't happen, right? So that's one part, right? Now, can a controller help in using the controller capability to do restoration? Absolutely, it can do, right? And that is kind of agnostic of what architecture it's chosen, right? Because it's a function, right? It's a function controller, whether that function is existing here or here or here. It's a function that detects that, hey, I have a failure here. I need to reroute, I need to recolor, I can do that, right? But again, since there are no standards, it will be vendor-specific implementation, and each vendor will always claim that my implementation is better than the other, right? So that's the second part of your question, right? The third part is that this architecture looks very nice. It looks very clean. We have zero implementation of this, okay? The reason why we have zero implementation of this is this, right? One is that there is a gap between what CMIS as a capability is providing and what OpenConfig can provide, right? So what the industry thought processes, right? And when I mean by the industry, it's not only the vendors, it's also the operators and everyone, is kind of saying that open config is useless. Okay, I'm paraphrasing, but that's essentially it. I want to have seamless access directly, right? Now, whether it makes sense to have register access directly is a big debate. There is an IETF draft on this, if you want to do, which is come from NTT, that they want to have seamless expose there. So there is some work there. So there is a gap here, right? The other gap that's there is that with this architecture, on the packet controller, which so far was kind of stopping at layer 2 Ethernet, you are going to add more capabilities on the optical, which is going to be built by experts who have no understanding of optics, right? So, yes, so whatever you build, in order to force fit in the architecture, might not be there, right? And if you're trying to solve a problem here, which is already solved here, by the way, right? Whatever is the problem statement of how am I going to react to a power change, how do I detect a failure, how do I detect a signal degrade, what are the kind of algorithm I run by looking at the FEC and OSNR and how I'm going to do, all of that is a solved problem here, right? So if it's a solved problem, why solve here again, right? So that's a debate, right? So just because something looks very nice on a PPT does not mean that it's very good on that, right? And I'm, as myself personally, I'm not convinced one way or the other, right? I'm open to the suggestions and we proceed.
Thank you so much. Thank you, Swakin. Let's have our next presentation. Tanmay is an applied scientist at Microsoft who's been working on AI security and privacy. His research spans security, cryptography, privacy preserving, machine learning, all the nice little buzzwords. And today he's talking about VPN traffic identification and censorship resistance.
Thank you. So today I'll be talking about VPNs, and since it's pretty late, I think I'll be very simple in my terms. This is not working. Okay. So yeah, I'll start with the ideal pathway. Yeah. So how basically VPNs work right now? So there is a VPN client that exists, and then there is an internet service provider, which you basically have connect with to a VPN server, and then basically routes your or forwards your traffic through their server. Now what happens is, when there's no VPN, you're directly trusting the internet service provider for all the traffic, and you're depending only on TLS encryption, which is provided by the end server side. So number of protocols that are used VPNs today are like OpenVPN, IKV2, and WireGuard, which is coming up, and recently TLS. So some older protocols have also been now deprecated or were used before this year, were like point-to-point, L2P, and SSTP, which are now depreciated because of their old protocol usage and the cryptographic signatures that they were using. So I will be covering majorly the newer protocols and not the older protocols, because I have detailed more them in the paper. So how tunneling actually happens is basically you need to connect these two different networks using a VPN tunnel based on certain protocols that the VPN protocol is following. What I mean is basically at the OpenVPN level, what happens is basically it creates a virtual interface within your system so that it appears to as a network device, and your traffic first follows to that virtual device, and then the OpenVPN encrypts that in the packet, encapsulates your original packet within an OpenVPN packet, and then it routes to the real interface, and then it gets routed to the normal network, kernel network stack. Similarly, the reverse happens at the other endpoint, which is solving your case. So now what happens is, in this connection, as I mentioned, this encrypted packet is internally within itself is also a normal IP packet, because when it reaches the end host, it needs to forward to the actual endpoint that you are trying to reach. So there have been a lot of VPN identification studies in the past about how VPN traffic can be detected without decrypting it, or is OpenVPN actually fingerprintable, and can TLS be actually used in circumvention or censorship, and how people are using it. So, but why currently this VPN is now much more matter is to that, because currently countries are now moving to how we can block VPNs. Not only websites, or particularly they're also curtailing on the apps that they see that people are using to bypass search blocks. Say if a certain app is blocked in a country, people try to get on VPN and then try to still get it. But now countries are moving to even block VPN. So we wanted to study, can you actually block reliably the VPN traffic and identify using the firewalls or the middle boxes that exist today, right? So these are the first restriction. Can adversary identify VPN traffic using DPI-based middle boxes, or based on the current data sheets and the manuals and actual practical testing? And what are the hardware offerings that they do offer? Similarly, which protocols are most or the least vulnerable to these blockages or are basically easily identifiable? Then we move to what evasion strategies do actually work, or are there any workarounds that people can do right now to basically evade these practical solutions? So the threat model that we are going to be discussing is like an ISP level adversary, which has access to firewalls and middle boxes across the network. And one of the key thing is that we cannot do large scale ML on the middle boxes at firewall at line rate. That we are going with assumption is that because in the live scenario, the key threat model is that you cannot do it in the live. You can obviously allow to do it in a post traffic phase, like where you have basically the traffic has already passed and you can do an analysis on that. But as of now, you cannot do large on ML models on the line rate scale. So our choices of VPNs, and we do a lot of based on choice of VPNs, we went along with the protocol diversity and public usage, like which are the most popular, and which are VPNs that claim to be that they can obfuscate your network or can be basically prevent blocking within the countries like Iran and Russia and others. And for traffic examination, we use standard traffic tools and kernel level modules. And markers, we were basically looking for any identifiable markers like SNI, plain text identifiers, packet size patterns, and other protocol signatures. And to do that, actually, we went with actually reverse engineering the applications of VPNs and other parts in the network stack to actually figure out how the data is getting flowed and what can be actually detected. So, and further, we tested across all major platforms. So to counter any variation across platform and operating system devices, because within operating system, network stacks sometimes differ and which protocol they are based on. So for that, so for choice of VPNs, these are the major VPNs that we took, and this also had some less known names, but they were chosen, as I mentioned, because of their protocol diversity or the claims they are making. Yeah. So I'll go to the protocol definition of this, like how we are going to do is, first we are looking at open source VPNs, and we are also looking separately at proprietary VPNs. By proprietary VPNs, what I mean is the protocol is actually not open source, that the companies like NordVPN and ExpressVPN have their own protocols, but we basically defactor it and we look at what exactly essentially is the protocol or what version of modification they are doing to that. So for commercial VPN connection, so currently commercial VPN connection follows a two-step client application aware process where you have to download their VPN application, and then it uses firstly an authentication server to fetch the VPN gateway credentials. Like what happens is you're not directly connecting to the endpoint. Say you want to connect to Russia, you want to connect to some place. So what essentially happens, you connect to the server endpoint, which just does an authentication for you and routes back your actual host endpoint client IP. You need to connect and other further credentials for that. Now what happens is that this is also one of the major weaknesses of this architecture is that if the VPN client is blocked in this authentication or in this fetch phase, you will never be able to connect to any of the VPN servers because you don't have that information. Another thing is that some VPN providers actually, like Proton VPN, I think I'll mention in the slide, but I am saying actually package it within the application, those endpoint IPs, which is not a best practice to follow also, because I can obviously reverse engineer their binary and then extract out all the major IPs that they are hosting, and it would be very easily for an adversary to block their large chunk of the IPs. And as I mentioned, the weakness is just the application can block. So for OpenVPN, this is the basic protocol, how it happens. So there is an initial TCP UDP connection that is started. OpenVPN works over UDP or TCP as base configuration. But there are two essential packets which are control hard reset client v2 and the server v2, which actually carries an opcode. And in the default configuration of OpenVPN, what's the problem that we figured out is that the OpenVPN opcodes are plain text. So what this actually does is this. So when you basically look it through even simple WireGuard packet tracing, you can see that it is able to identify the opcodes, but the actual data, user data is encrypted. But this basically makes OpenVPN vulnerable to fingerprinting very easily by ISPs or any other actors. Like if the person is using VPN or not, you want to detect that. It's simple as that if trying to this specific feature of opcode is present. And so we did a more configurable study. Like we not only analyzed the normal commercial vanilla cases, we also analyzed what happens when malformed packets get sent to it, how it basically can be detecting using, say, probing, say if you're doing VPN. And we also looked at the pre-shared key mode, which is the exception in this case, which actually encrypts the complete packet. But what happens in this case, it's not scalable. So for the pre-shared key mode, you have to be actually share the key beforehand with the end user, which is not very not possible in deployment scenarios. And so we actually propose a new protocol for OpenVPN, which we are working on right now to make it more robust and not have these weaknesses of like encrypting only some certain part of the packet. So next major protocol that is being used now is WireGuard. So WireGuard is just next gen lightweight UDP based. So essentially at the bottom it's using UDP, and on top of UDP, like Quick, it has been implemented in such a manner with in very fast handshake initiation. Like if you see OpenVPN, it has a long phase of connecting and verifying the user before even the data gets sent. With WireGuard, it's like the first initial handshake packet, and then the data packets start flowing. But even then, WireGuard suffers from this plain text and fixed offset repeated identifiers, which can easily be used to track WireGuard as well. So if you are basically starting the initial packet handshake, it will always start with a certain matching of patterns of zeros, which is easily identifiable by a basic level filter. So now come to node links, which is the proprietary part of the protocols. What is node links is doing is basically a modification on top of WireGuard. So what happens is the WireGuard has this problem of that user level anonymization cannot happen within WireGuard, because at the back end you need to have assigned a certain key for a particular user, and then you cannot have that. So how NordVPN basically wanted to do that, solve that with a temporary dynamic identity assignment at their endpoint, which basically pools certain users to a certain common pool, so that it is not easily linkable or traceable back to the user. And next, another VPN protocols that is now VPNs are using is actually TLS 1.3, and the reason that they are using is because what happens is that if you're trying to merge with the normal browsing traffic, what happens is that it becomes harder, or the collateral damage is higher to block such traffic, because you might be able to now blocking normal browser traffic or VPN traffic. You need to be 100% certain if it is VPN or not. So right now the potential markers that the VPN people identify is the SNI, which is the server name identification, and if it comes in the block list or not. Then the number of cipher suites also plays a role. Like if you're only using a single TLS cipher suite within the TLS broadcast, then it also becomes a marker, because browsers generally have a fixed 10 to 12 sets of cipher suites that they advertise, and certain applications, if they're like limiting them to exactly one cipher suite, that itself is a giveaway in some cases. And certificates also are checked, but in TLS 1.3 and other quick-based protocols, there is encrypted certificates, so that becomes harder in this case. So TLS-based VPNs are like Proton VPN stealth mode and ExpressVPN Lightway. So, and another interesting or not journal way is that another like VPN providers like Viper and Perfect Privacy are also using SSH-based tunneling to actually mimic the traffic of an enterprise SSH or something, so that it also becomes harder to detect, and it's looked as a benign protocol. But if you actually try to look it through the WireGuard, what you would find is just TCP-based connection. It cannot understand what the kind of protocol is there, and even with the specialized filtering you put onto it, you would be hardly able to get if it's an SSH or not. And the only way to identify is in the first few packets, there's a special SSH protocol banner that actually comes. So we were also able to identify through that they internally within the tunnel what they are actually using. And these are the, as I mentioned, these are the popular obfuscation that they are trying to even, so one of the SNI fields are being monitored, so VPN companies try to randomize the SNI field, but that itself is also can be a giveaway. And we have seen with papers describing people publishing no SNI fields, and Proton and Lightway basically do this browser mimic TLS kind of thing, where what they try to in this case is they try to take a normal TLS connection as would happen within the browser like Chrome, Firefox, and they take that exact configuration to their VPN tunnel and mimic that. So the idea behind simply is the collateral damage and hiding within the crowd. So for SSH, Viper's Chameleon is basically doing SSH tunneled OpenVPN within internally also. First, they basically do an SSH for the initial handshake to hide the OpenVPN initial handshake that I mentioned, the opcodes, and then they tunnel it through the SSH tunnel to basically provide another second kind of guarantee that they are obfuscating any kind of visible markers in that. So the only benefit of doing this is that it's a very high collateral damage if you're not doing a deep packet inspection or analysis for this case. And for the evasion techniques, one of the easiest known is used is SNI poisoning. But SNI poisoning is also not cannot be used on infrastructures like Cloudflare, where they have a strict checking of cloud SNI versus a certificate name. So what happens is if they're not strict checking, you can actually do SNI poisoning and it will route it correctly because it gets routed based on the actual certificate and not the whatever poisoned SNI is there. But Cloudflare has this check where the SNI and the hostname check should always match. So these kind of evasion techniques does not work. Another one that is universal and can work on any kind of provider is this MTU manipulation that we have come up with, which is like the standard 1500 bytes and taking advantage of packet fragmentation. We were able to, in our experiments, evade detection by firewalls and middle box without doing any kind of man in the middle. And we had a minimal performance hit for text-based traffic, at least on these cases. So these are the performance results for where we reduce the MTU from for the journalistic traffic on websites. And for testing, so the main idea is that there is not a huge decrease within the space, even if you do a lower MTU based on the current gen networks. For firewalls, so how do we actually test all this? So we took an actual modern firewall and updated it to the latest OS that it supports. And why that this matters is basically because in the current generation, what happens is now the blocking and all these firewall capabilities are tied to a software update. So if if new protocols come, the firewalls are now basically dependent on this kind of feature update that they can get. So we were able to see how vanilla VPN is blocked or not, and if an XOR patch bypass that exists within this with OpenVPN is able to bypass it or not. And based on this, we were able to see that there are certain features that they publish on OpenVPN as well, like if there are any protocol changes and how they are getting the signatures for this. For configurability, we were able to see on this that you can only change certain specific fields and patterns. You cannot do dynamic kind of nature for detections, and that was the essential part when we started with the assumption that because when you're, what's happening is in OpenVPN and other cases is that the packets key feature that can be detected is sometimes dynamic, and it changes according to the offsets and the particular client configuration that they set. So a single config across the journalistic will not actually be realistic in actual deployment scenarios. It would have a higher collateral damage. And finally, we have a table where we are summarizing what are the weaknesses within each protocol, within each VPN, and are they fingerprintable or not, or can you basically, if they are fingerprintable, why they are fingerprintable, and if they are not, what is the reason, and other cases. And the limitation for the study, I would just mention that right now, we don't have the access to actual ISP infrastructure because for the study specifically. So that is only one of the major things that are, but to combat that, we try to do as much testing on enterprise grade hardware as we can. And certain others, like there can be more broader selection of VPNs, and there can be basically certain changes with application updates of firewalls. As I mentioned, that they are now software based, even on hardware. So these testing versions and things can change according to the time. And we also have a protocol, but I don't think I have time to go deep into the protocol step by step. So what I would just mention on the protocol is that it will achieve full complete packet level encryption, and it will also combat that two-stage authentication step that we see, which is a real blocker. And yeah, so this is a paper, and if you have any questions, you can, or you're happy to take a look at the paper.
Thank you so much. Excellent talk. One simple question, like most of the people who want to block VPNs, like especially the governments, they definitely don't want to touch enterprise VPN. Yeah. And so when you are thinking in the packet format, what are the giveaways between, oh, this is a commercial VPN versus, oh, this would be an enterprise VPN, even though they might be using the same sort of protocols underneath?
Yeah, so one of the thing is basically the SNI and the certificates that you are using, but essentially that's the game of the VPN providers, and is also that if you are using VPNs, essentially any protocol, even if you are an enterprise, you're going to use the same protocol as OpenVPN. If you say your enterprise has deployed Fortinet, which essentially is a TLS based now. Earlier they were used on OpenVPN, now they are also moved to TLS based VPN. So which is like similar to, as I mentioned, that they are trying to mimic the browser traffic. So it's like if the companies are trying to, at the protocol level, you cannot change anything. So there is a huge point of collateral damage if you directly block any protocol level for a VPN. So that is one of the case that is always in this case. Yeah.
Thank you. Any more questions? Yeah.
You mentioned that SNI was being used to block access, like based on reading the SNI, right? Even in TLS 1.3, but TLS 1.3 has encrypted client hello, right? So how exactly would SNI be exposed?
So the thing is, there are cases where, so the TLS encrypted client hello only works in cases where it's configured to use such that. First of all.
Yeah, so most of the TLS 1.3 implementations do support encrypted client hello, right? So I know there is another version where you don't have encrypted client hello in TLS 1.3, but most of the currently deployed versions have SNI encrypted, right? So the evasion then should work, like as in you pass anything in the SNI shouldn't make a difference because it's encrypted and can't be, because firewalls today suffer that only, like the previous firewall implementations which relied on SNI can no longer use it with encrypted client hello.
Yeah, so that is true, but in this case that ECN specific flag should be enabled. So in our testing, what we have seen, even at TLS 1.3 that is being used by major website, it does not enforce that it will only connect you with if you are using ECN or not. If you send a packet of TLS 1.2, it will downgrade your connection and connect with you that. So there is this attack that people use specifically in other cases also, that if they want to detect, if I want to detect if you're using any kind of VPN or not, I would not just limit myself to TLS 1.3 or to connection. I will force you to downgrade to TLS 1.2 for all these kinds of unencrypted channels. Like I mentioned that in TLS 1.3 there is encrypted certificates also with that which comes in. What that essentially is the problem, like for the attacker's adversary. but they can always do a downgrade attack, and for compatibility reasons, most of the servers that we looked at have an ability to that. They will downgrade your connection if you
for compatibility they do downgrade,
Yeah.
but as long as your client is updated, you should always have encrypted SNI, right? Like you will always have encrypted client going in and not
definitely. So the thing is, in this case, the stealth VPNs I mentioned, they have this strict policy that they will only forward or connect if there is this TLS 1.3 with this specific cipher suite. But that is also a giveaway in the sense that the cipher suites are published. Like even in this encrypted client, there is this pattern, like these are the cipher suites that server supports, and these are the other certificates that are provided. So what these companies were doing is that basically they were sending only a single cipher suite in their encrypted client hello as well. So that basically gave away that it's a kind of VPN signature. It became a signature for them because how they are configured in the backend, they were always using a particular cipher suite with their application.
That's true, but that also like you were mentioning, right? That's a harder it is more riskier, right? Because a lot of websites can enforce TLS 1.3 and specific cipher suites for the simple reason that it needs to be secure. Like as in they have a lot of upgraded security and performance also. So it could be genuine traffic also, which you will end up blocking, right?
So that's a caveat here in all this study is that the collateral damage you have to basically see with all these kind of configurations you're making.
Just one follow-up there. So you also mentioned that this OpenVPN traffic that was being fingerprinted using opcodes and similarly WireGuard also. So that's, I think, been like, it has happened, like it's been known for some time, right? So as the solution, like you mentioned that if you use DPI only, then it's detectable, right? Because you need to inspect the L7 protocol. This is an L7 protocol. So unless you split open this, you will not be able to see the L7 layer, right? So unless you do proper DPI, you will never be able to view these opcodes, right? So
at the FHIR level, what we've seen is that they do have this capability of like as a feature now, not only like from the end user perspective who's configuring the firewall, he just have to drop from the drop down choose a VPN, and he doesn't have to like for how easy it is. Like we want to also consider like if you wanted to block, how easy would it be to just go to a firewall config and set say block OpenVPN and it would be blocked. So that is one of the cases that we wanted to like analyze. And second, even with the, like the TLS 1.3 point that I'm coming back to is basically is like how harder is it to detect. Like the whole aim of the study is like if I have an adversary and I want to detect what you're using, what can I do and what are you guys doing, or all these insights on that. And we basically tried contacting the VPN company as well to fix their protocols in any way possible.
Got it. Yeah, that's what I wanted to verify. Like the TLS part, right? Like how was it easily detectable? Like that was my main question. Like with TLS 1.3 and ECH, was that easily fingerprintable or detectable? That was my. So
TLS is detectable by default, but the only detectable thing was the number of cipher suites if everything is encrypted. Why we were able to confidently say is because there is like a monthly or a yearly kind of TLS study that comes out what's the adoption of TLS 1.3 over 1.2 and what is being used. And in that, if you go to the cipher suite and all this, you would see that 90% of the connections have this kind of cipher suites being published. Only less than 10% of the connections have only particular pattern of cipher suite published. So one of the cases like is that if you know about Tor browser, right? So Tor browser is basically based on Firefox, right? But it lags behind Firefox in updates. So if Firefox has updated the cipher suite version, so what happened is Firefox is on like 150th version or something, and it has a certain particular set of cipher suite. But Tor browser is like 30-40 versions behind. So in that there's an older set of cipher suites. So what became apparent if you are using a Tor browser or not is just simply that was a study that happened that they were able to detect just based on the cipher suite number of which are advertised, if you are using a Tor browser or not. So that is one of the cases. And those specific set only belong to those specific applications.
Yeah, thanks, Yara. Let's thank you so much.
Thank you.
Excellent presentation. And now we are at the last presentation of the day. And we have for that two speakers who have traveled all the way from Calcutta and Guwahati for this. So thank you for coming. So first we have Anand. Okay.
We'll be introducing a project over here and some of the initiatives that India Internet Foundation is working upon, and in collaboration of IIT Guwahati what we are doing. Perhaps we have kind of gone through many technical presentations enlightening across the day. This is something that we built in around 5 to 6 years. The idea was whenever we have started, it is a platform by the community for the community. A decade of community engagement on different aspects of internet protocols and standards with the community, different stakeholders, ISPs, academia, enterprise networks and others. And then we have tried to get those insights and experiences to build a measurement system, a platform for the country. So this is a measurement system which is right now working. You have heard of RIPE Atlas, SCADA, Planet M and other measurement systems that are there in US and Europe, in Japan. There was something that was needed for Indian research community to kind of work upon the data repositories. This is a two-way end-to-end measurement system where we have, the left you will see, there are Anycast networks which is hosted in different institutions like IIT Guwahati, here in ISC Bengaluru and other institutions as well. These are 4 or 5 servers which is hosted as Anycast CDNs where we can provision virtual machines for you, anybody who is interested in research. And these are Raspberry Pis across India, around 300 internet measurement anchors. There is a portal aiori.in. You can go into that portal, log in into there, and our backend team will provision some points for you so that you can fire, ping, traceroute, DNS and other commands over there. Take the results and then you can work on your research. The final part over here is when we will developing this, we have developed this very plug and play architecture wherein any institution who wish to use these Raspberry Pis, they can use it, and there will be a complete bifurcation whether we will not be using the data of them. And also we can provide virtual machines if you are working on eBPF, you want to provision your own protocols, then it's very easy to do this. It's completely a distributed architecture that has been built. There are various tools and technology. I will not go through the kind of results that we have produced. It is for the different stakeholders and that's there in different portals. So if you wanted to know your network details, I have taken it from a local host, that's why you are not getting there. The website latency, you can check it from aori.in. The measurement portal v2.aori.in, which I was talking about. The DNS Viz, which is giving you all perspectives of DNS visualization from recursive servers to authoritative servers, root servers, CCTLD servers. Then IXP Viz, which is kind of providing lot many information, and we are taking data from different measurement systems as well. It is very interoperable. We have APIs, exposed APIs that can be given to you so that you can use those. The RPKI Viz and even the IETF Viz. This is something that was a requirement from community to understand what is happening in IETF. We have curated and kind of done some AI LLM models in IETF-viz.aori.in, which provides what is the global and Indian participation, which working groups they are working upon, what are the topics that are being discussed. That's there in the visualization portal. So these are different visualization portals that you can use. It's all there. So I'll not dwell more detail into this. And then over to Venkatesh sir, because after this we have collaborated with IIT Guwahati to work upon some of the courses and initiatives. Over to you, sir.
Yeah. So as you know, Anand mentioned, everybody in India knows when I started teaching networks, I had set up Planet Lab node at IIT Guwahati. That was the only way in which we could participate in internet measurement. And it was behind enterprise firewall, so a lot of restrictions, so nobody could measure actually anything out of the network. Then I subscribed for a separate internet connection, went on to do measurements for a couple of years till Airtel started rate throttling and blocking the network completely. And that is when I moved out of complete active measurement and passive measurement. And once I met Anand, I felt that this is much easier model to deploy Raspberry Pi nodes as anchor points and they have a product called DNS in a box, which you could deploy any institution. So the clusters we have deployed in several institutions now. So we have some problem statements over this. So one of the initiative that I have started is that in every networks course that I do, now I ask students to log in onto this AORI portal and do the lab experiments on the portal and come up with measurement details, then analysis of the results, rather than asking them to do ping from some website. They don't know what is the location of that website from where they are doing ping, right? So instead of that, now you are knowing the anchor location, you could do measurements from there. You know the ISP details, so you could actually do longitudinal measurements also. So we had some very interesting student projects coming out of this experimental initiative. We also had a course, topics in networks, which basically loosely, talks about network telemetry and then internet measurement, particularly with data centers, etc. There also we have used this platform. Our idea is to, publicize this, platform as well as the set of lab experiments and the kind of studies that you could do to different academic institutions. So we have curated a course called Internet Engineering and Operations. So we are going to teach that in IIT Guwahati. And after a while, we also would go live on the NPTEL, platform, so that more institutions can understand how to, start with internet measurement. What is there, first of all, to measure in internet, right? So when I talk to a lot of teachers from colleges, they don't understand what do you do out of measurement, right? Why do you even have to measure? What do you want to measure? And then what do you gain out of doing this measurements? So then I discuss different, research problem statements, for example, from venues like IMC, PAM, etc. And then they understand, what is the use of doing measurement on, internet platforms. So that's, what we wanted to cover about the academic initiatives at IIT Guwahati. Anand.
Thanks, Venkat sir. So it was something so motivating, kind of whenever we met, and we spent many times to understand what the academic framework should be. And because of his recommendations, we have changed, even updated the portal, so that whenever a faculty joins in the portal, there are students who could join under him or her, and then the students can fire measurements and they can put on the assignments, and assignments can be even directly uploaded into that.
LMS also integrated into this
so
platform.
We have integrated LMS because of his recommendations, and right now it is kind of used in many institutions who are there. One of the problem statements then we have catered is whenever we have kind of presented it to EPNIC, IETF and other forums, they told that where you will find the community in India who understands measurement, who understands internet engineering. What we have done is in 2 years back, in 2024, we have started AORI 1, 2, 3 as an yearly initiative. And that's the AORI 3 that we are presenting right now. It's an yearly initiative wherein we reach out to the community, the academic community across India. First, we have collaborated with IEEE, around 5 students' workshops in 5 locations in the country. And there were around 5 workshops we have done, 250 students we have trained, 23 hackathons, and we have 69 students and faculty joined those hackathons based on this particular platform. And then we have two teams who were actually presenting in IETF 122. So that was the first year of community engagement that we have done. The second year was 11 faculty workshops. We have gone to 11 locations across India. 291 faculties were trained. 50 student workshops locations happened. Around 1,500 students directly one time participated and measured many parameters across 1,500 locations from India. And then 53 remote hackathon teams joined, and in physical hackathon there were 23 teams. All the projects that they have done is something which is there hosted in GitHub, open source, and anybody can contribute on those projects. This was from AORI 1, this is from AORI 2, the problem statements we have given. And these all problem statements, the source code is there open, and you can kind of go to portal.aori.in/hackathons. You can have the PPT, GitHub, and the PDF. Everyone who has participated, won, and right now, the community is engaging on those open source projects. Right now, phase 3 has already started, and this is an outreach for phase 3. This time we are kind of, because sir is handling ISEA also, so we have partnered with ISEA project of METI, and we have reached out to around 100 institutions, and this time it's a train the trainer program. The 100 faculties will be getting trained, and they will be taking the workshops, and these 100 colleges, they will be going through the student workshop, so 50 each. So we are kind of going through 5,000 students this time, and the scale is pretty large because we have right now that infrastructure in place, and the faculties who have joined us in AORI 2 becomes our ambassadors. So they are kind of doing this. So in the beginning I have told it is for the community, by the community. So ultimately it will go to the community so that it could be sustained. And that's how these faculties will train themselves and then train the students, and then they will participate in the hackathon. If you are interested, you can be mentors. If you have some problem statement, please reach out to us. There are people who are working on these problem statements and they could work on them. If you wish to mentor those students, you are most welcome. We seek mentorship also, so we will be kind of giving this ads in our social media channels for the mentorship for problem statements, and then the hackathon will, this is the timeline for AORI phase 3. There are 5 areas we have identified. Oops. Internet measurement, cybersecurity, smart cities, 6G and future networks, and cloud computing and IoT. These are the 5 thematic areas this time. It has been identified. Based on that, the hackathon problem statements will be curated. And the measurement components will be DNS performance, IPv6 readiness, routing, RPKI and BGP visibility, CDN and incast latency mapping, and network performance and internet resilience. So these are the why you can engage. You can share operational problems, compare measurement, validate deployments, collaborate on open source tools, and build regional data sets. So we are looking for engineers, ISPs, IXPs, NRNs, universities, CDN operators, anybody who is interested, who could kind of collaborate, join over here, and can build help building this community in India. Thank you.
Any questions? Thank you so much. Questions? Questions? Questions?
So regarding the VMs, what exactly was that? Like you can on-demand provision a VM on one of the 300 RPIs that you mentioned?
Yeah, not the 300 RPIs, but the Anycast servers that we are having. It's a private cloud that we have built. So let's say if you wanted to do some experiments, we can provision those VMs over there. Even in RPI also it is a virtual machine. So what can be done is, on those PIs also we have a direct, if let's say if you wanted to host an RPI, you can host that. There will be a virtual machine and you can have your own scripts. Like we have done a hackathon on PDM, so with eBPF, so that's there. So it's very plug and play. You build something, you plug into that framework and it just takes. And there's a portal which is kind of the framework we have. So we have a CI/CD pipeline over there. You build, you plug and play. That's all.
Okay, so it's like we submit and it gets deployed there.
Yeah. So if you're interested, you just mail in that mail ID. Okay, our backend team, the researchers will just get in touch with you, and they will provision you. There is a complete CI/CD pipeline, and we have a private GitHub repo we have that we work upon. So automatically it gets worked. Thank you.
Thank you so much. This is really exciting. I think, one suggestion which I would also say is, when we have done some measurements, we should also highlight something that we measured which was not known before. Yes. I think the scale part is extremely impressive. But I think what would also be very impressive, especially to at the ITF and APNIC crowd, would be that, yes, this is the new thing that our students have been able to measure and something that was not known before. And we need to highlight the technical as much as we highlight the the infrastructure that you guys have built.
Yeah, so everything is there in the website. So yes, definitely those slides I have missed to integrate. Definitely that's something to ask, that what we have, there are lots of interesting measurements that we have done. So I'll just put on those slides. Okay, thank you.
Thank you so much. And now let's ask Mohit to do the closing.
I'll do the closing after that. Just pass the message.
No, my message was, if whoever spoke today could post, I know maybe Dhruv will coordinate it, but just post your PDF if you don't mind sharing it.
The slides. We will be uploading on the Connections website.
Okay, and maybe your contact information, so if I or somebody else wants to follow up with you on LinkedIn or send you a chat message, because not everybody is identified fully in their WhatsApp DM or profile. So if you could just, I don't know, Mohit has posted everybody's photos, so maybe you could just reply to your own photo and say, this is my contact information or my PDF, whatever you feel like sharing, so we all have a thread to work off in the next few days. Thank you.
Perfect, sure, thank you. All right, so thank you everyone for staying back. We'll just have a small closing note. Now that we had this interesting line of talks today, and there are quite a few things that we all learned new, what are the next steps going forward? So Connections event closes today, but what can we do next is something that I wanted to highlight. First of all, if you think you would like to participate in IETF 126, of course, like Dhruv said, if you can travel, it's amazing, but given that it's only 1 week remaining, we would encourage you to do remote participation. So I have directly given you the link to the remote participation fee waiver. Once you go to that link, they will give you a code, and during registration, if you put that code, it just waives off the total fee. You can join for free. One note, when you are registering for IETF 126 remotely, for the fee waiver also when you use, there's an option to tick that I would like to register for hackathon. So don't forget that. Register for hackathon. The hackathon will be starting next Saturday, and you can remotely participate in the hackathon from here. Now you would want to know which are the projects in hackathon next Saturday they are starting. So I have given a direct link to all the hackathon projects. So please go through the projects, and some champions are listed. Champions means the members who are participating in the hackathon. You can just write an email to them that I would like to participate remotely from India, and I would like to help you in this specific objective over the next 2 days, and ask them to list yourself also as a champion there to show that you participated. If you want to know the detailed agenda of the IETF 126 meeting, there's a direct link I have given. Go through all the different meetings that are scheduled every day, and then see which one would you like to attend. Typically what we have learned from Dhruv and others is that we start marking our Google Calendar with the meetings that we want to attend, with the Meet Echo links, and also that on that day we don't have to keep looking out that which are the sessions going on. Side meetings also I have given you the link. So this is one information for all of you. These PPTs will be all uploaded on Connections website by tomorrow, so you can pick up these links from there. One good news, we all know that APNIC 62 is coming to India. It will be in Bombay this time in the month of September, starting September 8th. So what we have done is we have placed one of our events with APNIC 62. Our event is called RFCs We Love. These are two events that we do. Connections is an annual event, and RFCs We Love, we try to do it more frequently throughout the year through IIESoc. So IIESoc will be at APNIC 62. Our event is scheduled on September 7th, and it's on Monday. It is the day just before the APNIC meeting starts. So if you are traveling to Bombay on the previous day, you can attend this RFCs We Love. It is a 90 minutes session, and the registration link is available on the link shared at the bottom, okay, on the IIESoc website /RFCs We Love. Nalini already gave an information about the quantum webinar series that IIESoc and INTC are doing it together. One of the first one is already completed. The second one is scheduled immediately. And then there are the other, 5. I have written down the names of all the webinars, the order in which they are going to be conducted. And the details are available on the bottom link. Please make a note that you will have to register for the talk separately, each one of them, so that you can get access to the Zoom. And once the webinar is done, we also put the slides and the recording online. So if you missed out for some reason, you can go and check the recording afterwards. And finally, we would like to make a call for volunteers. We want more people to join us and help us in IIESoc. Primarily, we are looking for the new board members. We are also looking for somebody who can help us do a bit of outreach and also help us maintain our social media and website. So this is not something which is technical per se, but being a part of the IIESoc community and helping us volunteer in some or the other way always helps build network. We tend to meet people whom we have not met earlier and get to learn from it. So if here are some students, you can tell your other batchmates. There are so many new people, new faces that I met today. If you believe you will be interested in helping us out in any capacity that you can, or someone who would be interested in this kind of role, please put them in touch with us. We already have one of the volunteers whom we got from the IETF India group. Thanks to him for coming here and being with us throughout the day and helping us with all the logistics. And we can be contacted at info@iiesoc.in. That is the link. That's the email. You can just send us an email if you are interested in any of the roles. If you have any feedback about this event or in general about something that you would want us to do, maybe we can spend a couple of minutes on that, and we are happy to listen to you. So some feedback from the participants? Yeah, I can imagine. You can also write to us on info@iiesoc.in if you have any specific feedback.
The website needs a rescue. The website doesn't render very well.
The website doesn't render very well. Yeah, that's why, that is the reason we have a request for a website maintainer. Okay, yeah, we can do that, yeah. So we are happy to take any kind of support that comes. Right now, Dhruv and Vishal have been managing out of their time, little bit time that they get. So we would like to have a dedicated website maintainer, or rather I would actually make it maintainers. Multiple people are needed because somebody can be busy at one time. So it's open call. You don't need to be into networking to be helping us with website maintenance part or the social media. We are open to having anyone work with us. Eventually they would also get to know about what is IETF or what are open standards. Don't use WhatsApp. It has been one of the easiest way for us to communicate with the people. So we would focus on reaching out to people, and nothing against WhatsApp or nothing against any app. It's just about forming a team that can easily get together and nothing else. You want to say something?
No, we have a mailing list, post on mailing list maybe, but nobody does. So that
yeah, we have a mailing list. We have a mailing list.
We have an @IETF.org mailing list, which is something that we got, which you asked for now, you won't get it. The whole, and in fact, there is a talk that they might ask us to close it down.
I see.
As well, because IETF community India, we had one Bangalore as well. Once the IETF Bangalore hub.
You mentioned it in your opening today, right?
It's there.
It is there in the opening slides.
And it's again going back to the IETF principle, you can fight on principles or you can deal with the reality. This is the same thing we get from using GitHub as well. Many people hate it. Why are we using GitHub? GitHub doesn't support IPv6, and there is this whole internet area who's always angry at GitHub, but then that's where people are. That's what's easier. You have to. But at the same time, good thing is IETF doesn't force you to do anything. So as a working group, you can choose. You can decide to use GitLab and just go there. Nobody's going to stop you.
Or don't use Git, or don't use Git at all. Yeah. Just use the old XML, tracker. So
yes.
Yeah. So that the working groups do it in their own way, yeah.
But I think the main thing with feedback here was we have tried multiple ways to do connections things have evolved over time. People are busy. People are doing things. What format works best? Are you interested in set of talks? You yourself thought that, oh, I could have given the same talk much better. Tell us, like, how would we know? So give us feedback. Tell us what you want to hear. This was useful. This wasn't useful. I have a lot of feedback from myself itself, but like, which we will anyway discuss, but we want to hear from you as well. If you're shy and you want to just let the day get over, do that on WhatsApp. And as we were just saying, or email, whichever is easy. We have thick skin, so you can be critical. It's a IETF. It makes you go that way.
Yeah, last year we had a panel discussion. This year we did not. So if any kind of feedback comes from the community side, the U side, then we will plan accordingly for the next year. Yeah. Anyone else? Thank you. So thank you everyone for staying back, and looking forward to interacting with you all, either in the group or in the email or in some form. Thank you again for being here with us today full day. Yeah.